its own locking. Atomics is lock-free. 4.
This, I need to be last stream.
Being able to
I didn't plan to spend
program
an entire week, 7 days,
function or
on making a shader.
need to be atomic. For
This really needs to be it. Hopefully, this has to be last stream for this. Then I can actually get
5.
back to writing the JavaScript engine.
Typed array index. This function performs the following steps when called. Let byte index in buffer B.
That's the whole point. I just need to get this program done.
E A T
7 days, it's a whole week of time.
O M
I was planning for 4, and now it's 7. Luckily I'm close.
C E S.
Like, literally, almost done. All I need to do is get the freaking frame buffer into the fucking window, and then I'm good.
R. Mixor typed array int x value. This function performs the following steps when called. 2. Let or be a new read modify write modification function with parameters x bytes, y bytes that captures nothing when called. A return byte list bitwise op x bytes, y bytes return. Atomic read modify write typed array int x value or 70. ECMA International 2024, the 25th of April.
So I just need to, like, resolve these, and then I'm good. I think I'm still losing my voice, I don't know. I gotta drink some more water.
V A.
So I, like, find all these. I hate this software. I wish you could just use the streaming software for the mic. It sounds so bad.
A C C E S S capital O.
I need to download a freaking program to, like, denoise the stupid sound.
If type
Because the sound software, the sound suppression on this software is so bad.
LumVB
It's horrible.
T value perform revalidate atomic access typed array byte index in buffer let
Alright, so I gotta find these.
typed array element typed array perform set value in buffer byte index in buffer element type v true sexiest. The 5th of April 2012 atomic sub typed array int x value. This function performs the following steps when called. Let type be typed array element typed array. Let his little endian be the value of the
I'm literally so close to being done with the stupid shader.
If I write modification function with parameters x bytes, y bytes.
Got a triangle.
This little end
You know what, I'm gonna wait.
called a let x be raw bytes to numeric type x bytes,
All I gotta do is get the frame buffer to be put to the window.
y bytes.
That's all that's left. There's only a couple of these too.
Then
It's like duplicates.
subtract x, y, else. I assert x is a big int. 2. Let
1058.
subtract x, y, let difference bytes be numeric to raw bytes. Type difference is little endian. F assert difference bytes, x bytes.
No 1047.
Number of elements. G return difference bytes. Return. Atomic read modify write. Typed array.
Command buffer.
Subtract. The 5th of April 2013 atomics weight. Typed array. Int x.
So that's,
This function puts the surrounding agent
whatever that buffer is.
until the wait time
That I made.
a string
Up here.
is. It performs the following steps when called. Return. Do await. Sync. Typed array. Int x. Value. Timeout. The 5th of
This one, I think.
atomics wait async. Typed array.
Or not.
Value. Timeout. This function returns a promise that is resolved when the calling agent is notified or that the timeout is reached.
It's called, where the type is VK buffer.
Wait. Async. Typed array. Int x. Value. Timeout. The 5th of April 2015 atomics notify. Typed array. Int x. Count. This function notifies some agents that are sleeping in the wait queue.
Man,
Steps when called.
I hate this.
2024 671 1. Let byte index in buffer B. Capital V A L I D A T E capital A T O M
It's a VK buffer.
E
So I guess that's it.
C C E S S capital O N capital I N T E G E R capital.
So let's use this and assume it's okay.
True if count is
I think it's just a pointer.
a let CB plus, else a let int count B. To an integer or infinity, count B let CB max, int count. Buffer B typed array, let block B buffer, if a shared array buffer is false, return plus.
Assuming it's related to this, I'll use this.
Byte index in buffer, perform enter.
Because I have no clue. Chatbot makes the worst code.
Move waiters, WL,
It doesn't even run
free
most of the time.
S, do, a perform notify with
And the code that it does make that runs,
U1.
it's like far from impressive.
Let
It's like the simplest stuff
S3. Read
that comes from like Stack Overflow.
2016
It doesn't even write it.
value. This function performs the following steps when called. Let XOR be a new read modify write modification function with parameters x bytes, y bytes that captures nothing and performs the following steps atomically when called. A return byte list bitwise op x bytes, y bytes return. Atomic read modify write typed array int x value XOR the 5th of April 2017 atomics. Add at to string tag the initial value.
We're gonna name these like command buffer, I guess.
String value atomics. This property has the attributes false, false, true. 5.5 The JSON object. The JSON object is %JSON% is the initial value of the JSON property of the global object is an ordinary object. Contains two functions, parse and stringify, that are used to parse and
It's Chatbot. If this type is used only for command buffers.
prototype percent does
Hold on, never mind.
cannot be used as a constructor with the new operator. Does not have the
Command buffer is a different type, so it's the wrong type.
JSON data interchange format is defined in ECMA 404. The JSON interchange format
Dang it.
specification is exactly that described by ECMA 404. Conforming implementations of JSON parse and JSON stringify must support the exact interchange format described in the ECMA 404 specification without any deletions or extensions to the format. 5.5.1 JSON parse. Text. Reviver.
And it's a pointer.
And text. A JSON formatted string and produces an ECMA script language value.
Oh, it's an allocation.
Match represents literals, arrays, and objects with a syntax similar to the syntax literals, array initializers, and object initializers. After parsing, JSON objects are realized as ECMA script objects. JSON 72, copyright sign, ECMA International 2024. Arrays are realized as ECMA script array instances. JSON strings, numbers, booleans, and null are realized as ECMA script strings, numbers, booleans, and null. The optional reviver parameter is a function that takes two parameters, key and value. It can filter and transform the results. It is called with each of the key value pairs produced by the parse, and its return value is used instead.
I just use these command buffers for other things.
The structure is not modified. If it returns undefined, then the property is deleted from the result. Let some string be. To string, text, parse string to code points. Some string, as a JSON text is specified in ECMA 404. Throw a syntax error, exception if it is not a valid JSON text as defined in that specification. Let script string be the string concatenation of JSON string, and let script be parse text. String to code points. Script string. Script. Note. The early error rules defined in 1.3.2.5.1 have special handling for the above invocation of parse text. Assert. Script is a
Great.
completion be completion. Evaluity on of script. Note. The property definition evaluation semantics defined in 1.3.2.5.5.
You go like reset command buffer.
Let unfiltered be completion. 0. Assert. Unfiltered is either a string, a number, a boolean, an object that is
Begin. Command. Begin. Render pass. End render pass. Command buffer.
then
Or end.
ordinary object create. Object proto
I think JPA is missing all that stuff.
the empty string.
All of it.
Create data property or throw root. Root name unfiltered do return. Internalize JSON property root. Root name reviver 2. Else a return unfiltered. The length property of this function is 2. Note valid JSON text is a subset of the ECMA script primary expression syntax. Step 2 verifies that JSON string conforms to that subset. And step 10 asserts that parsing and evaluation returns a value of an appropriate type. However, because 1.3.2.5 behaves differently during JSON parse,
But for this stuff, it's handled differently.
evaluated as a primary expression rather than as JSON.
I hate all this stuff.
The early error for duplicate proto-properties and object literals, which likewise does not apply during JSON parse, means that not all texts accepted by JSON parse are valid as a primary expression, despite matching the grammar 5.5.1. 1 internalized JSON property, holder, name, reviver. The abstract operation internalize JSON property takes arguments holder, an object, name, a string, and reviver, a function object, and returns either a normal completion containing an ECMA script language value or a throw completion. It performs the following steps when called. Let val be get holder name. If val is an object, then a let isArray be isArray val be. If isArray is true, then I let len be length of array like val. Note 1 this algorithm
And it's tied to index 2. That's cool.
create data property return false. ECMA International 2024 673 2. Let I be 0. 3. Repeat. While I len let prop be to string I let new element be. Internalize JSON property val prop reviver. If new element is undefined, then a perform val prop 4. Else a perform. Create data property val prop new element 5. Set I to I plus 1. See else I let keys be. Enumerable own properties val key 2. For each string p of keys, do let new element be. Internalize JSON property val p reviver. If new element is undefined, then a perform val p3. Else a perform. Create data property val p new element 3. Return. Call reviver holder name val. It is not permitted for a conforming implementation of JSON parse to extend the JSON grammars. If an implementation wishes to support a modified or extended JSON interchange format, it must do so by defining a different parse function. 5.5 to JSON string if I value replacer space. This function returns a string in UTF-16 encoded JSON format representing an ECMA script language value.
Grid F2. I have command buffer. Command buffers.
The value parameter is an ECMA script language value, which is usually an object or array, although it can also be a string, boolean, number or null. The optional replacer parameter
This calls all the steps, whatever.
an array is a stringified, or an array of strings and numbers that acts as an inclusion list for selecting the object properties that will be stringified. The optional space parameter is a string or number that allows the result to have white space injected into it to improve human readability. It performs the following steps when called. Let stack be a new empty list. Let indent be the empty string. Let property list be undefined. Let replacer function be undefined. If replacer is an object, then if is callable. Replacer is true. Then I set replacer function to replacer be else. 674 ECMA International 2024. Note 2. In the case where there are duplicate named strings within an object, lexically preceding values for the same key shall be overwritten. I2. Let isArray be isArray replacer. If isArray is true, then set property list to a new empty list. Let len be length of array like replacer. Length 0 repeat. Okay. Len abcd.
Oh no, there's only one.
B to string.
But I sent it twice.
Let VB get replacer prop. Let item be undefined. If V is a string, then I set item to V. Else if V is a number, then
So inside of create command buffers,
V F.
I assign a malloc.
Then if V has a or internal slot, set item to
And then inside of
G. If item is not undefined and property list does not contain item, then I append item to property list. H set k to k plus 1, 6. If space is an object, then if space has an internal slot, then I set space 2 to number space b. Else if space
create command pool and buffers. So I think they're both. I'm only using one or the other.
space is a number, then a let space mvb to an integer or infinity. Space b set space mv to min 10 space mv. See if space mv 1. Let gap be the m
So I'm calling this, so it's only being said once.
space mv.
So that's fine.
The code unit 0 times 0020 space. Else if space is a string, then if the length of space 10.
And then
Otherwise let gap be the sub.
init all staging buffers is called after all this.
A let gap be the empty string 0. Let wrapper be ordinary object.
This does call end command buffer.
1. Perform. Create data property or throw wrapper
So I'd assume that it's safe
value. 2. Let state be the
to use command buffer.
organization record. Replace a function. Stack. Indent. Property list. 3. Return.
Inside of init all staging buffers.
State. The empty string. Wrapper. The length property of this function is 3. Note 1. JSON structures are allowed to be nested to any depth, but they must be acyclic. If a value is or can
Which is here.
structure, then this function must throw a type error except
So I'll just pass in
example of a value that cannot be string.
the same exact thing
0
for
equals JSON string if I. This must throw a type error. Note 2.
here where it's the issue.
Did as follows. The null value is rendered in JSON text as the string value null. The undefined value is not rendered. The true value is rendered.
I can't stand all these globals.
The false value is rendered in JSON text as the string value false. Note 3. String values are wrapped in quotation mark. Code units. The code units are escaped with prefixes. Control characters code units are replaced with escape sequences UHH, or with the shorter forms B, backspace, F, form feed, N, line feed, R, carriage return, T, character tabulation. Note 4. Finite numbers are stringified as if by calling to string.
Except,
And infinity regardless of sign are represented as the string value null. ECMA
man,
1024 675. Note 5
it
value
is getting the address here.
representation, such as undefined and functions, do not produce.
So to pass it a pointer then.
They produce the undefined value. In arrays, these values are represented as the string value null. In objects, an unrepresentable value causes the property to be excluded from stringification. Note 6. An object is rendered as
What is chat about?
B, left curly bracket, followed by 0 or more properties, separated with a U+002C.
I think it wants to like check command buffer.
E, right curly bracket. A property is a quoted string representing the property name, a U+003A, colon, and then the stringified property value. An array is rendered as an opening U plus 005b, left square bracket, followed
Or not.
values, separated with a U plus 002c, comma, closed with a U plus 005d, right square bracket, 5, 5, 2, 1 JSON serialization record. A JSON serialization record is a record value used to enable serialization to the JSON format. JSON serialization records have the fields listed in Table 75. Table 75. JSON serialization record fields. Field name, value, meaning, replace a function object or undefined. A function that can supply replacement values for object properties. From JSON stringify's replace a parameter property list, either a list of strings or undefined. The names of properties to include when serializing a non-array object. From JSON stringify's replace a parameter gap, a string, the unit of indentation. From JSON stringify's space parameter stack, a list of objects, the set of nested objects that are in the process of being serialized. Used to detect cyclic structures. Indent, a string, the current indentation, 2552. To serialize JSON property, state, key, holder. The abstract operation serialize JS.
So this code, it just says begin command buffer.
Serialization record, key.
The other code calls end command buffer.
Either a normal
It starts with begin command buffer.
or a throw compile tion. It performs the following step.
Hold on, no it doesn't.
Get, holder, key. If value is an object or value is a big int.
This is render,
Jet,
not begin. This says begin.
callable to JSON is true. Then I set value to call.
Why doesn't this code do reset?
Key 3. If state is not
Because it's the first time it's called maybe.
value 2, call, state, holder, key, value 4. If value is an object, then 76. ECMA International 2024. AB. If a value has an internal slot, then I set value to.
Does reset command buffer need to be called after,
Then I set
before,
string, value, CL.
end command buffer?
Then I set value to value, DLs if value has an internal slot. Then if value, if value, if value, if value, if value, set value to value is null. Return null is true. Return true is false. Return false is a string. Return quote JSON string. Value is a number. Then if value is finite, return to string. Value be return null.
Because if you don't have to call reset before end,
Error exception 1.
why call reset after it ended later?
Value is false. Then a let is array b is array value b if is array is true. Return serialize JSON array state value c return
Chatbot thought for 5 seconds.
state value 2 return undefined
I almost tripped it up.
2 3 quote JSON string value. The abstract operation quote JSON string takes argument
It says end command finalizes, puts it in the next executable state.
times zeros.
Reset is used after the GPU is finished with it
Escapes certain
to return it to the initial state.
action interprets value
So you can VK begin again.
code points.
You call reset while it's in the recording state
It performs the following steps when
to abandon what you've recorded so far.
reading solely of the code unit.
But you only do that if you want to discard it.
Quotation mark for each
You don't need to end the buffer first in that special case.
did in the code point column of table 76. Then I set product to the string
But it's not reset while it's pending.
escape sequence for C is specified in the escape sequence column of the corresponding row. B else if C has a numeric value less than 0
So end, submit, wait, reset, begin.
space, or C has the same numeric value as a leading, surrogate, or trailing surrogate. Then I let unit be the code unit whose numeric value is the numeric value of C. 2. Set product to the string concatenation of
That makes no sense.
ape unit C else. I set product to the string concatenation of product and UTF-16 encode code point.
So this is invalid because VK end buffer requires the buffer to still be in recording state, but you reset it first.
Product.
Begin, copy command, reset begin. Okay, so why didn't it call reset before the first begin? So tell chatbot, what is the state after end command buffer? Is the reset command buffer absolutely necessary? It makes it more difficult to template things. No, it's not strictly necessary. You create a new command buffer each time, or you create your command pool and destroy recreate the pool instead. If you want to reuse the command buffer after submitting and executing, yes, you must reset it.
The term conditional keyword, or contextual keyword, is sometimes used to refer to the keywords that fall in the last three categories, and thus can be used.
What does it mean by destroy? Does it mean free?
Syntax, reserved word. One of await break case catch class const continue debugger default delete 2 else enum export extends false finally for function of import an instantiate new null return super switch this throw true try type of var void well with a yield 24 ECMA International 2024 note 1 per 5 1 5 keywords in the grammar match literal sequences of specific.
What does this mean? Destroy, be technical, question mark, or no question mark.
Sequence. An identifier name can contain Unicode escape sequences, but it is not possible to declare a variable named else by spelling it else u. 65.
So why the hell, if it has to be freed, do I have to reset at all? It doesn't know those are used if it's been freed.
Currently used as a keyword in this specific.
I'm gonna try without it.
Future reserved word.
Without calling fucking reset.
As a keyword in future language extensions. Similarly, implements, interface, package, private, protected, and public are future reserved words in strict mode code. Note 3, the names
I gotta pass this in.
words, but they are subject to some
My address.
mode code. C13118645155115511561 and 15881. 2.8 punctuators. Syntax. Punctuator. Optional chaining punctuator. Other punctuator. Optional chaining punctuator. Look ahead decimal digit. Other punctuator. 1 of, comma, equals plus, percent plus plus, and equals
Or not.
equals
This is a global, so I'll just keep it global. Which makes it simpler.
Div punctuator, equals sign. Right brace punctuator, 2.9 literals, 2, 9, 1 null literals. Syntax. Null literal. Null. ECMA International 2024 225. 1, 2, 9. 2 Boolean literals. Syntax. Boolean literal. True, false. 2, 9. 3 numeric literals. Syntax. Numeric literal separator. Numeric literal. Decimal literal. Decimal big integer literal. Non-decimal integer literal. Plus sep. Non-decimal integer literal. Plus sep. Begin literal suffix legacy octal integer literal. Decimal big integer literal. 0 big int literal suffix. Non-zero digit decimal digits. Plus sep opt begin literal suffix. Non-zero digit numeric literal separator decimal digits. Plus sep.
Oh my god, I made a copy of it. Where is it?
Integer literal. Sep. Binary integer literal sep. Octal integer literal
Here.
integer literal sep. Begin literal suffix. N decimal literal. Decimal integer literal. Decimal digits. Plus sep opt exponent part. Plus sep opt. Decimal digits. Plus sep exponent part. Plus sep opt. Decimal integer literal exponent part. Plus sep opt. Decimal integer literal. 0 non-zero digit. Non-zero digit numeric literal separator opt decimal digits. Plus sep. Non-octal decimal integer literal. Decimal digits. Sep. Decimal digit. Decimal digit sep. Decimal digit. Plus sep. Decimal digits. Plus sep. Numeric literal separator decimal digit. Decimal digit. 1 of 0 1 2 3 4 5 6 7 8 9. 26. ECMA Internatio. Now 2024. Non-zero digit. 1 of 123,456,789. Exponent part. Sep. Exponent indicator signed integer sep. Exponent indicator. 1 of EE. Signed integer. Sep. Decimal digit sep. Decimal digit sep. Decimal digit sep. Binary integer literal. Sep. 0b binary digit sep. 0b binary digit sep. Binary.
Run it again.
Binary digit sep. Binary digit plus sep. Binary digits plus sep. Numeric literal separator binary digit. 1 of 0 1. Octal integer literal sep. 0 octal digit sep. 0 octal digit sep. Octal digits sep. Octal digit sep. Octal digit plus sep. Octal digits plus sep. Numeric literal separator octal digit. Legacy octal integer literal. 0 octal digit. Legacy octal integer literal octal digit. Non-octal decimal integer literal. 0 non-octal digit. Capital L E G A C Y. Capital O C T A L. Capital L I K E. Capital D E C I M A L. Capital I N T E G E R. Capital L. Non-octal digit. Non-octal decimal integer literal decimal digit. Capital L E G A C Y. Capital O C T A L. Capital L I K E. Capital D E C I M A L. Capital I N T E G, E, R, capital L, 0 octal digit, capital L, E, G, A, C, Y, capital O, C, T, A, L, capital L, I, K, E, capital D, E, C, I, M, A, L, capital I, N, T, E, G, E, R, capital.
What does this call do?
1.
That same chatbot said to make a counter to hold the current frame or the flip buffer, whatever.
2024 to
It said to manually increment it or whatever
0x hex
each time you use that. But then I see this function where it like gets an image index. Is that related to the flip buffer?
plus 7
So annoying.
to hex digit. Hex digit. 1 of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, def A, B, C, D, E, F. The source character immediately following a numeric literal must not be an identifier start or decimal digit. 2, 9, 3, 1 static semantics. Early errors. Numeric literal. Legacy octal, integer literal, decimal, integer literal. Non-octal decimal integer literal. It is a syntax error if the source text matched by this production is strict mode code. Note to non-strict code. This syntax is legacy. 2, 9, 3, 2 static semantics. MV, a numeric literal stands for a value of the number type or the big int type. The MV of decimal literal. Decimal integer literal. Decimal digits is the MV of decimal integer literal, plus the MV of decimal digits 10n, where n is the number of code points in decimal digits, excluding all occurrences of numeric literal separator. The MV of
Oh, I hate chatbot so much.
literal. Exponent part is the MV of decimal integer literal. Is the MV of exponent part. The MV of
Wait, this can time out.
integer literal. Decimal digits exponent part is the MV of decimal integer literal plus the MV of decimal digits 10n, 10e, where n is the number of code points in decimal digits, excluding all occurrences of numeric literal separator, and e is the MV of exponent part. The MV of decimal literal. Decimal digits is the MV of decimal digits 10n, where n is the number of code points in decimal digits, excluding all occurrences of numeric literal separator. The MV of decimal literal. Decimal digits exponent part is the MV of decimal digits 10e, n, where n is the number of code points in decimal digits, excluding all occurrences of numeric literal separator, and e is the MV of exponent part. The MV of decimal literal. Decimal integer literal exponent part is the MV of decimal integer literal 10e, where e is the MV of exponent part. The MV of decimal integer literal. 0 is 0. The MV of decimal integer literal. Non-zero digit numeric literal separator op decimal digits is the MV of non-zero digit 10n plus the MV of decimal digits.
For fuck's sake.
In decimal digits, excluding all occurrences of numeric literal separator.
It says do not do this. That's what it told me to fucking do.
Decimal digit.
God damn it.
Decimal digit. The MV of decimal digits. Decimal digits numeric literal separator decimal digit is the MV of decimal digits 10 plus the MV of decimal digit. The MV of exponent part. Exponent indicator signed integer is the MV of signed integer. The MV of signed integer. Decimal digits is the negative of the MV of decimal digits. The MV of decimal digit. 0 or of hex digit.
Man.
Octal digit. 0 or of 228. ECMA International 2024. Note, for example, 3 inches is an error and not the 2 input elements 3 and in legacy octal escape sequence. 0 or a binary digit. 0 is 0. The MV of decimal digit. 1 or of non-zero digit. 1 or of hex digit.
Doesn't matter though.
1 or of binary digit. 1 is 1. The MV of decimal digit. 2 or of non-zero digit. The MV of decimal digit. 3 or of non-zero digit. The MV of decimal digit. 4 or of non-zero digit. The MV of decimal digit. 5 or of non-zero digit. The MV of decimal digit. 6 or of non-zero digit. The MV of decimal digit.
Man.
The MV of decimal digit. 8 or of non-zero digit. The MV of decimal digit. 9 or of non-zero digit. Or of hex digit. 2 or of octal digit. 2 is 2. 3 or of hex digit. 3 or of octal digit. 3 is 3. 4 or of hex digit. 4 or of octal digit. 4 is 4. 5 or of hex digit. 5 or of octal digit. 5 is 5. 6 or of hex digit. 6 or of octal.
Call this here.
Is 6. 7 or of hex digit. 7 or of octal digit. 7 is 7. 8 or of non-octal digit. 8 or of hex digit. 8 is or of non-octal digit. 9 or of hex digit. 9 is the MV of hex digit. Or of hex digit. A is 10. The MV of hex digit. B or of hex digit. B is 11. The MV of
Let's remove all these.
C is 12. The MV of hex digit. D or of hex digit. D
This is so boring.
digit. E or of hex digit. E is
I just want to be done.
hex digit. F or of hex digit. F is 15. The MV of binary digits. Binary digits. Binary digit is the MV of binary digits 2 plus the MV of binary digit. The MV of binary digits. Binary digits. Numeric literal separator binary digit is the MV of binary digits.
I'm really glad that I'm not actually using this now.
Octal digits. Octal digits.
So I can just comment,
8 plus the MV of octal digit. The MV of octal digits. Octal digits. Numeric literal separator octal digit is the MV of octal digits 8 plus the MV of octal digit. The MV of legacy octal integer literal. Legacy octal integer literal octal digit is the MV of legacy octal integer literal times 8 plus T. The MV of octal digit. The MV of non-octal decimal integer literal. Capital L, E, G, A, C, Y. Capital O, C, T, A, L. Capital L, I, K, E. Capital D, E, C, I, M, A, L. Capital I, N, T, E, G, E, R. Capital L. Non-octal digit is the MV of
I have to go fucking semaphore? Man.
A, C, Y. Capital O, C, T, A, L. Capital L, I, K, E. Capital D, E, C, I, M, A, L. Capital I, N, T, E, G, E, R. Capital L times 10 plus the MV of non-octal digit. The MV of non-octal decimal integer literal. Non-octal decimal integer literal decimal digit is the MV of non-octal decimal integer literal times 10 plus the MV of decimal digit. The MV of capital L, E, G, A, C, Y. Capital O, C, T, A, L. Capital L, I, K, E. Capital D, E, C, I, M, A, L. Capital I, N, T, E, G, E, R. Capital L, E, G, A, C, Y. Capital O, C, T, A, L. Capital L, I, K, E. Capital D, E, C, I, M, A, L. Capital I, N, T, E, G, E, R. Capital
Maybe I should call this function right here.
capital L, E, G, A, C, Y. Capital O, C, T, A, L. Capital L, I, K, E. Capital D, E, C, I, M, A, L. Capital I, N, T, E, G, E, R. Capital L times 10 plus the MV of octal digit. The MV of hex digits. Hex digits. Hex digit is the MV of hex digits 16 plus the MV of hex digit. The MV of hex digits. Hex digits numeric literal separator. Hex digit is the MV of hex digits 16 plus the MV of hex digit 2, 9, 3, 3 static semantics. Numeric value. The syntax directed operation numeric value takes no arguments and returns a number or a big int. It is defined piecewise over the following productions: numeric literal, decimal literal, return round MV result, MV of decimal literal, numeric literal, non-decimal integer literal, return MV of non-decimal integer literal.
Because it does work to fill it with a solid color.
MV of legacy octal integer literal, numeric literal, non-decimal integer literal big int literal suffix. Return the big int value for the MV of non-decimal integer literal. ECMA International 2024 229.
Which means I gotta pass in the image index. That's cool.
Return 0z. Decimal big integer literal. Non-zero digit big int
I'll just make these back to functions.
big int value for the MV of non-zero digit. Decimal big integer literal. Non-zero digit decimal digits big int literal suffix. Non-zero digit numeric literal separator decimal digits big int literal suffix. Let n be the number of code points in decimal digits, excluding all occurrences of numeric literal separator. Let NV be the MV of non-zero digit 10n plus the MV of decimal digits. Return Z, MV 2, 9.
I should probably update this, split it up, so it does a copy after the current frame,
In single or double.
and it does paint the next frame.
Points may also be represented.
But just get it running first.
Points may appear literally in a string literal except for the closing quote code points. U plus 005
Is it not named function?
plus 000D. Carriage return. And U plus 000 line feet.
Oh, it's named this.
Points may appear in the form of an escape sequence. String literals evaluate to ECMA script string values.
Alright, so now I don't call this in here.
Use Unicode code points UTF-16
Pass it in.
1, 1, 1. Code points belonging to the basic multilingual plane are encoded as a single code unit element of the string. All other code points are encoded as two code unit elements of the string. Syntax: string literal, double string character sopt, single string character sopt, double string characters, double string character sopt, single string characters, single string character sopt, double string character, source character, but not one of or line terminator. LS, PS, escape sequence, line continuation, single string character, source character but not one of or line terminator. LS, PS, escape sequence, line continuation, line terminator sequence. 30. ECMA International 2024, escape sequence, character escape sequence, look ahead decimal digit. Legacy octal escape sequence, non-octal decimal escape sequence, hex escape sequence, Unicode escape sequence, character escape sequence, single escape character, non-escape character, single escape character, one of BFNRTV, non-escape character, source character but not one of escape character or line terminator, escape character, single escape character, decimal digit, XU, legacy octal escape sequence, 0, look ahead. 8, 9, non-zero octal digit. Look ahead octal digit. 0 to 3 octal digit. Look ahead octal digit. 4 to 7 octal digit. 0 to 3 octal digit. Octal digit. Non-zero octal digit. Octal digit but not 0. 0 to 3. 1 of 0, 1, 2, 3. 4 to 7. 1 of 4,567. Non-octal decimal escape sequence. 1 of 89. Hex escape sequence. X hex digit. Unicode escape sequence. U hex 4 digits. U. Code point. Hex 4 digits. Hex digit. The definition of the non-terminal hex digit is given in 1, 2, 9, 3. Source character is defined in 11.1. ECMA International 2024 231. Note 2. LF. MCR cannot appear in a string literal, except as part of a line continuation to produce the empty code point sequence. The proper way to include either in the string value of a string literal is to use an escape sequence such as n or u000 2 9 4 1 static semantics, early errors, escape sequence, legacy octal escape sequence, non-octal decimal escape sequence. It is a syntax error if the source text matched by this production is strict mode code. Note 1 in non-strict code. This syntax is legacy 2 9 4 to static semantics. SV, the syntax-directed operation SV takes no arguments and returns a string. A string literal stands for a value of the string type. SV produces string values for string literals through recursive application on the various parts of the string literal. As part of this process, some Unicode code points within the string literal are interpreted as having a mathematical value, as described below or in 1, 2, 9, 3. The SV of string literal is the empty string. The SV of string literal is the empty string.
Wrap this like if0,
Characters.
just to see if everything works, like syntax-wise.
Concatenation of the SV of double string character and the SV of double string characters. The SV
This little build, check things, but it's not running.
character single string characters is the string. Concatenation of the SV of single string character and the SV of single string characters. The SV of double string character, source character but not one of or line terminator is the result of performing UTF-16 encode code point on the code point matched by source character. The SV of double string character, ls, is the string value consisting of the code unit.
Missing screen texture and 1092.
Separator. The SV of double string character, ps, is the string value consisting of the code unit 0 times 2029. Paragraph separator. The SV of double string character, line continuation is the empty string. The SV of single string character, source character but not one of or line terminator is the result of performing UTF-16 encode code point on the code point matched by source character. The SV of single string character, ls, is the string value consisting of the code unit 0 times 2028. Line.
1073.
The SV of single string character, ps, is the string value consisting of the code unit 0 times 2029. Paragraph separator. The SV of single string character, line continuation is the empty string. The SV of escape sequence, 0 is the string value consisting of the code unit 0 times 0000. Null. The SV of character escape sequence, single escape character is the string value consisting of the code unit whose numeric value is determined by the single escape character according to table 38. Note 2 it is possible for string literals to precede a use strict directive that places the enclosing code in strict mode, and implementations must take care to enforce the above rules for such literals. For example, the following source text contains a syntax error, function invalid. 7. Use strict. 32. Copyright sign, ECMA International 2024. Table 38. String single character escape sequences. Escape sequence, code unit value, Unicode character name, symbol, B.
It's assigned to screen texture.
Backspace, BS, T, 0 times 0009. Character tabulation, HT, N, 0 times 000, line feed, LF, V, 0 times 000B, line tabulation, VT, F, 0 times 000C, form feed, FF, R, 0 times 000D, carriage return CR, double quote, 0 times 0022, quotation mark.
Oh my god, this is so annoying.
27, apostrophe, backslash,
Everything needs to be made
5C,
on the fucking CPU
SV of non
and then binded
source character but not one of escape character.
and then casted. This should all be on the GPU,
Code point matched by source character.
especially if I'm using memory that's already on the GPU.
Octal is
This is so annoying.
value consisting of the code unit whose numeric value is the NV of legacy octal escape sequence. The SV of non-octal decimal escape sequence. 8 is the string value consisting of the code unit 0 times 0038, digit 8. The SV of non-octal decimal escape sequence. 9 is the string value consisting of the code unit 0 times 0039, Digit 9. The SV of hex escape sequence. Hex digit is the string value consisting of the code unit whose numeric value is the NV of hex escape sequence. The SV of hex 4 digits. Hex digit is the string value consisting of the code unit whose numeric value is the NV of hex 4 digits. The SV of Unicode escape sequence. U, code point, is the result of performing UTF-16 encode code point on the NV of code point. The SV of template escape sequence. 0 is the string var, lu consisting of the code unit 0 times 0, 0, 0, 0, null 1, 2, 9, 4, 3 static semantics. MV, the MV of legacy octal escape sequence. 0 to 3 octal digit is 8 times the MV of 0 to 3 plus the MV of octal digit. The MV of legacy octal escape sequence. 4 to 7 octal digit is 8 times the MV of 4 to 7 plus the MV of octal digit. The MV of legacy octal escape sequence. 0 to 3 octal digit is 64. That is 82 times the MV of 0 to 3 plus 8 times the MV of the first octal digit plus the MV of the second octal digit. The MV of 0 to 3. 0 is 0. The MV of 0 to 3. 1 is 1. The MV of 0 to 3. 2 is 2. The MV of 0 to 3. 3 is 3. The MV of 4 to 7. 4 is 4. The MV of 4 to 7. 5 is 5. The MV of 4 to 7. 6 is 6. The MV of 4 to 7. 7 is 7. The MV of hex escape sequence. Hex digit is 16 times the MV of the first hex digit plus the MV of the second hex digit. The MV of hex 4 digits. Hex digit is 0 times 1000 the MV of the first hex digit plus 0 times 100 the MV of the second hex digit plus 0 times 10 the MV of the third hex digit plus the MV of the fourth hex digit. ECMA International 2024 233 1, 2, 9. 5 regular expression literals. The productions below describe the syntax for a regular expression literal and are used by the input element scanner to find the end of the regular expression literal. The source text comprising the regular expression body and the regular expression flags are subsequently parsed again using the more stringent ECMA script regular expression grammar. 2.2. 2. 1. An implementation may extend the ECMA script regular expression grammar defined in 2.2. 2. 1. But it must not extend the regular expression body and regular expression flags productions defined below or the productions used by these productions. Syntax: regular expression literal, regular expression body, regular expression flags, regular expression body, regular expression first char, regular expression chars, regular expression chars. Empty, regular expression chars, regular expression char, regular expression first char, regular expression non-terminator but not one of or. Capital R E G U L A R, capital E X P R E S S I O N, capital B A C K S L A S H, capital S E Q U, regular expression class, regular expression char, regular expression non-terminator but not one of or. Capital R E G U L A R, capital E X P R E S S I O N, capital B A C K S L A S H, capital S E Q U, regular expression class, capital R E G U L A R, capital E X P R E S S I O N, capital B A C K S L A S H, capital S E Q U, regular expression non-terminator, regular expression non-terminator. source character but not line terminator. Regular expression class. Regular expression class chars. Regular expression class chars. Empty. Regular expression class chars. Regular expression class char. Regular expression class char. Regular expression non-terminator but not one of or. Capital R E G U L A R. Capital E X P R E S S I O N. Capital B A C K S L A S H. Capital S E Q U. Note 1. A regular expression literal is an input element that is converted to a regexp object. See 22.2 each time the literal is evaluated. 2 regular expression literals I in a program evaluate to regular expression objects that never compares equals to each other even if the 2 literals contents are identical. A regexp object may also be created at runtime by new regexp or calling the regexp constructor as a function. See 2.2.2.4.34. ECMA International 2024. Regular expression flags. Empty. Regular expression flags identify part char. 2.9.5.1 static semantics. Body text. The syntax-directed operation body text takes no arguments and returns source text. It is defined piecewise over the following productions: regular expression literal, regular expression body, regular expression flags. Return the source text that was recognized as regular expression body 1.2.9.5. To static semantics. Flag text. The syntax-directed operation flag text takes no arguments and returns source text. It is defined piecewise over the following productions: regular expression literal, regular expression body, regular expression flags. Return the source text that was recognized as regular expression flags 1.2.9.6. Template literal lexical components. Syntax. Template. No substitution template. Template head. No substitution template. Template character sop. Template head. Template character sop. $. Template substitution tail. Template middle. Template tail. Template middle. Template character sop. $. Template tail. Template character sop. Template characters. Template character. Template character sopt. Note 2. Regular expression literals may not be empty. Instead of representing an empty regular expression literal, the code unit sequence starts a single line comment. To specify an empty regular expression, use Dart. ECMA International 2024 235. Template character. Look ahead. Template escape sequence. Not escape sequence. Line continuation. Line terminator sequence. Source character but not one of or $, or line terminator. Template escape sequence. Character escape sequence. Look ahead decimal digit. Hex escape sequence. Unicode escape sequence. Not escape sequence. 0 decimal digit but not 0. X. Look ahead hex digit. X hex digit. Look ahead hex digit. U. Look ahead hex digit. Look ahead. U hex digit. Look ahead hex digit. U hex digit hex digit. Look ahead hex digit. U hex digit hex digit hex digit. Look ahead hex digit. U. Look ahead hex digit. U. Not code point. Look ahead hex digit. U. Code point. Look ahead hex digit. Look ahead. Not code point. Hex digits. Sep. But only if MV of hex digits. 0 times 10 FF. Code point. Hex digits. Sep. But only if MV of hex digits 0 times 10 FF. Note template substitution tailors used by the input element template tail alternative lexical goal 1.2.9.6.1 static semantics. TV. The syntax-directed operation TV takes no arguments and returns a string or undefined. A template literal component is interpreted by TV as a value of the string type. TV is used to construct the index components of a template object, colloquially, the template values. In TV, escape sequences are replaced by the UTF-16 code units of the Unicode code point represented by the escape sequence. The TV of no substitution template is the empty string. The TV of template head $, is the empty string. The TV of template middle. $sign is the empty string. The TV of template tail is the empty string. The TV of template characters. Template characters is undefined if the TV of template character is undefined or the TV of template characters is undefined. Otherwise, it is the string concatenation of the TV of template character and the TV of template characters. The TV of template character, source character but not one of or $sign or line terminator is the result of performing UTF-16 encode code point on the code point matched by source character. The TV of template character, $sign is the string value consisting of the code unit 0 times 0024. $sign, the TV of template character, template escape sequences the SV of template escape sequence, the TV of template character, not escape sequences undefined, the TV of template character, line terminator sequences the TRV of line terminator sequence, 236, copyright sign, ECMA International 2024, the TV of line continuation, line terminator sequences the empty string 1 2 9 6 to static semantics, TRV, the syntax directed operation TRV take.
This is so frustrating. You make a freaking image or a copy, and that gets copied to a copy, which gets copied to a copy. So you make a separate off-screen image that gets copied to the swap chain, and the swap chain itself is copied to the video card. There's like 4 or 5 layers of copying something from A to B to C and then to D. How many times does the same thing need to be copied back and forth? Holy fuck. This is ridiculous. Freaking mem copy every damn thing. What the hell?
The TRV of template character and the TRV of template characters. The TRV.
Can you write directly to the swap chain? Yes. Well, then that's what I want to fucking do.
Is the result of performing UTF-16 encode code point on the code point matched by source character.
I don't care. I'm going right to the damn swap chain. This is so. I'm tired of the copy to copy to copy to copy of a copy. Holy crap. There's so many copies.
Escape sequence.
Oh my god. Alright, I'm done. This is just so ridiculous.
And the TRV of template escape sequence. The TRV of template.
Like, keep track of something.
The string concatenation of the.
There's no need for all the globals.
See?
This is literally, totally unmanaged. Everything, nothing in this is managed. So it's like, there's slop, and there's code to check for slop, and then there's copies of copies to account for slop, because no one knows what's where, what's what. Up is down, down is up. Just copy this, copy that. This is really annoying. This is chaos. I hate this. I gotta get this done. This is ridiculous.
Is the string value consistent?
Ridiculous.
078, Latin small letter X, the TRV of not escape sequence, X hex digit, look ahead hex digit, is the string concatenation of the code unit 0 times 0078, Latin small letter X, and the TRV of hex digit, the TRV of not escape sequence, U, look ahead hex digit, look ahead, is the string value consisting of the code unit 0 times 0075, Latin small letter U, the TRV of not escape sequence, U hex digit, look ahead hex digit, is the string concatenation of the code unit 0 times 0075, Latin small letter U, and the TRV of hex digit, the TRV of not escape sequence, U hex digit, look ahead hex digit, is the string concatenation of the code unit 0 times 0075, Latin small letter U, the TRV of the first hex digit, and the TRV of the second hex digit, the TRV of not escape sequence, U hex digit, look ahead hex digit, is the string concatenation of the code unit 0 times 0075, Latin small letter U, the TRV of the first hex digit, the TRV of the second hex digit, and the TRV of the third hex digit, the TRV of not escape sequence, U, look ahead hex digit, is the string concatenation of the code unit 0 times 0075, Latin small letter U, and the code unit 0 times 007B, left curly bracket, the TRV of not escape sequence, U, not code point, look ahead hex digit, is the string concatenation of the code unit 0 times 0075, Latin small letter U, the code unit 0 times 007B, left curly bracket, and the TRV of not code point, the TRV of not escape sequence, U, code point, look ahead hex digit, look ahead, the string concatenation of the code unit 0 times 0075, Latin small letter U, the code unit 0 times 007B, left curly bracket, and the TRV of code point, the TRV of decimal digit, 1 of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 is the result of performing UTF-16 encode code point on the single code point matched by this production. The TRV of character escape sequence. Non-escape character is the SV of non-escape character. The TRV of single escape character, 1 of BFNRTV is the result of performing UTF-16 encode code point on the single code point matched by this production. The TRV of hex escape sequence. X hex digit is the string concatenation of the code unit 0 times 0078, Latin small letter X, the TRV of the first hex digit, and the TRV of the second hex digit. The TRV of Unicode escape sequence, U hex 4 digits is the string concatenation of the code unit 0 times 0075, Latin small letter U, and the TRV of hex 4 digits. The TRV of Unicode escape sequence, U, code point, is the string concatenation of the code unit 0 times 0075, Latin small letter U, the code unit 0 times 007B, left curly bracket, the TRV of ECMA International 2024-237, code point, and the code unit 0 times 007D, right curly bracket, the TRV of hex 4 digits. Hex digit is the string concatenation of the TRV of the first hex digit, the TRV of the second hex digit, the TRV of the RD hex digit, and the TRV of the fourth hex digit. The TRV of hex digit is the string concatenation of the TRV of hex digits and the TRV of hex digit. The TRV of hex digit, 1 of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 ABCDEF. ABCDEF is the result of performing UTF-16 encode code point on the single code point matched by this production. The TRV of line continuation, line terminator sequences the string concatenation of the code unit 0 times 005C, reverse solidus, and the TRV of line terminator sequence. The TRV of line terminator sequence, LF, is the string value consisting of the code unit 0 times 000 line feed. The TRV of line terminator sequence, CR, is the string value consisting of the code unit 0 times 000 line feed. The TRV of line terminator sequence, LS, is the string value consisting of the code unit 0 times 2028 line separator. The TRV of line terminator sequence, PS, is the string value consisting of the code unit 0 times 2029 paragraph separator. The TRV of line terminator sequence, CRLF, is the string value consisting of the code unit 0 times 000 line feed. 2.10 automatic semicolon insertion. Most ECMA script statements and declarations must be terminated with a semicolon. Such semicolons may always appear explicitly in the source text. For convenience, however, such semicolons may be omitted from the source text in certain situations. These situations are described by saying that semicolons are automatically inserted into the source code token stream in those situations. 2.10.1 Rules of automatic semicolon insertion. In the following rules, token means the actual recognized lexical token determined using the current lexical goal symbol as described in clause 12. There are 3 basic rules of semicolon insertion. When, as the source text is passed from left to right, a token, called the offending token, is encountered that is not allowed by any production of the grammar. Then a semicolon is automatically inserted before the offending token if one or more of the following conditions is true. The offending token is separated from the previous token by at least one line terminator. The offending token is, the previous token is, and the inserted semicolon would then be passed as the terminating semicolon of the do-while statement 147(2). When, as the source text is passed from left to right, the end of the input stream of tokens is encountered, and the parser is unable to parse the input token stream as a single instance of the goal non-terminal, then a semicolon is automatically inserted at the end of the input stream. When, as the source text is passed from left to right, a token is encountered that is allowed by some production of the grammar, but the production is a restricted production and the token would be the first token for a terminal or non-terminal immediately following the annotation, no line terminator here, within the restricted production, and therefore such a token is called a restricted token, and the restricted token is separated from the previous token by at least one line terminator. Then a semicolon is automatically inserted before the restricted token. Note TV excludes the code units of line continuation while TRV includes them. CR, LF, and CR line terminator sequences are normalized to LF for both TV and TRV. An explicit template escape sequence is needed to include a CR or CR, LF sequence 38, ECMA International 2024. However, there is an additional overriding condition on the preceding rules. A semicolon is never inserted automatically if the semicolon would then be passed as an empty statement or if that semicolon would become one of the two semicolons in the header of a for statement C147. 4. Note the following are the only restricted productions in the grammar. Update expression, yield, await. Left-hand side expression yield await. No line terminator here. Plus left-hand side expression yield await. No line terminator here. Continue statement, yield, await. Continue. Continue. No line terminator here. Label identifier yield await. Break statement, yield, await. Break, break. No line terminator here. Label identifier yield await. Return statement, yield, await. Return, return. No line terminator here. Expression, plus and yield await. Throw statement, yield, await. Throw, no line terminator here. Expression, plus and yield await. Yield expression, in, await. Yield, yield. No line terminator here. Assignment expression in, plus yield await. Yield, no line terminator here. Assignment expression in, plus yield await. Arrow function, in, yield, await. Arrow parameters yield await. No line terminator here, equals. Concise body in, async function declaration, yield, await, default, async. No line terminator here, function binding identifier yield await. Formal parameters, yield, plus await, async function body, plus default, async. No line terminator here, function, formal parameters, yield, plus await, async function body, async function expression, async. No line terminator here, function binding identifier, yield, plus await opt, formal parameters, yield, plus await, async function body, async method, yield, await, async. No line terminator here, class element name yield await, unique formal parameters, yield, plus await, async function body, async generator declaration, yield, await, default, async. No line terminator here, function binding identifier yield await, formal parameters, plus yield, plus await, async generator body, plus default, async. No line terminator here, function, formal parameters, plus yield, plus await, async generator body, async generator expression, async. No line terminator here, function binding identifier, plus yield, plus await opt, formal parameters, plus yield, plus await, async generator body, async generator method, yield, await, async. No line terminator here, class element name yield await, unique formal parameters, plus yield, plus await, async generator body, async arrow function, in, yield, Await. Async. No line terminator here. Async arrow binding identifier yield. No line terminator here. Equals. Async concise body in capital C O V E R capital C A L L capital E X P R E S S I O N capital A N D capital A S Y N C capital A R R yield await. No line terminator here. Equals. Async concise body in ECMA into
Never mind.
239. Async arrow
The swap chain, it's not an image.
here. Arrow for
In the swap chain, image is like a pointer to a location on the video card.
when a plus or
So I can't just copy to the swap chain.
does a postfix operator
This is really stupid.
between the preceding
So I'll make a copy then.
token that
This is ridiculous.
inserted before the plus or token. Wanna continue, break, return, throw, or yield token is encountered and a line terminator is encountered before the next token. A semicolon is automatically inserted after the continue, break, return, throw, or yield token. When arrow function parameter s are followed by a line terminator before it equals token, a semicolon is automatically inserted in the punctuator causes a syntax error. When an async token is followed by a line terminator before a function or identifier name or token, a semicolon is automatically inserted and the async token is not treated as part of the same expression or class element as the following tokens. When an async token is followed by a line terminator before a token, a semicolon is automatically inserted in the punctuator causes a syntax error. The resulting practical advice to ECMA script programmers is a postfix or operator should be on the same line as its operand. An expression in a return or throw statement or an assignment expression in a yield expression should start on the same line as the return, throw, or yield token. A label identifier in a break or continue statement should be on the same line as the break or continue token. The end of an arrow function's parameter s and its equals should be on the same line. The async token preceding an asynchronous function or method should be on the same line as the immediately following token. 210. Two examples of automatic semicolon insertion. This section is non-normative. The source 12.3 is not a valid sentence in the ECMA script grammar, even with the automatic semicolon insertion rules. In contrast, the source 123 is also not a valid ECMA script sentence, but is transformed by automatic semicolon insertion into the following 123, which is a valid ECMA script sentence. The source 4A B 40 copyright sign ECMA International 2024 is not a valid ECMA script sentence and is not altered by automatic semicolon insertion because the semicolon is needed for the header of a for statement. Automatic semicolon insertion never inserts one of the two semicolons in the header of a for statement. The source return a plus b is transformed by automatic semicolon insertion into the following return a plus b. The source e equals b plus c is transformed by automatic semicolon insertion into the following a equals b plus c. The source if a b else c equals d is not a valid ECMA script sentence and is not altered by automatic semicolon insertion before the else token, even though no production of the grammar applies at that point, because an automatically inserted semicolon would then be passed as an empty statement. The source a equals b plus c d plus c print is not transformed by automatic semicolon insertion because the parenthesized expression that begins the second line can be interpreted as an argument list for a function call a equals b plus c d plus c print. In the circumstance that an assignment statement must begin with a left parenthesis, it is a good idea for the programmer to provide an explicit semicolon at the end of the preceding statement rather than to rely on automatic semicolon insertion. 210. 3 interesting cases of automatic semicolon insertion. This section is non-normative. Note 1. The expression a plus b is not treated as a value to be returned by the return statement, because a line terminator separates it from the token return. Note 2, the token plus plus is not treated as a postfix operator applying to the variable b, because a line terminator occurs between b and plus plus. ECMA International 2024-241. ECMA script programs can be written in a style with very few semicolons by relying on automatic semicolon insertion. As described above, semicolons are not inserted at every new line, and automatic semicolon insertion can depend on multiple tokens across line terminators. As new syntactic features are added to ECMA script, additional grammar productions could be added that cause lines relying on automatic semicolon insertion preceding them to change grammar productions when parsed. For the purposes of this section, a case of automatic semicolon insertion is considered interesting if it is a place where a semicolon may or may not be inserted, depending on the source text which precedes it. The rest of this section describes a number of interesting cases of automatic semicolon insertion in this version of ECMA script. 2, 1, 0, 3. 1 interesting cases of automatic semicolon insertion in statement lists. In a statement list, many statement list items end in semicolons, which may be omitted using automatic semicolon insertion. As a consequence of the rules above, at the end of a line ending in expression, a semicolon is required if the following line begins with any of the following: an opening parenthesis. Without a semicolon, the two lines together are treated as a call expression, an opening square bracket. Without a semicolon, the two lines together are treated as property, access, rather than an array literal or array assignment pattern, a template literal. Without a semicolon, the two lines together are interpreted as a tag template. The 13th of March 2011, with the previous expression as the member expression, unary plus or. Without a semicolon, the two lines tog through are interpreted as a usage of the corresponding binary operator, a regexp literal. Without a semicolon, the two lines together may be parsed instead as the multiplicative operator. For example, if the regexp has flags 2, 1, 0, 3, 2 cases of automatic semicolon insertion and no line terminator here. This section is non-normative. ECMA script contains grammar productions which include no line terminator here. These productions are sometimes a means to have optional operands in the grammar. Introducing a line terminator in these locations would change the grammar production of a source text by using the grammar production without the optional operand. The rest of this section describes a number of productions using no line terminator here, in this version of ECMA script. 2, 1, 0, 3, 2, 1 list of grammar productions with optional operands and no line terminator here. Update expression, continue statement, break statement, return statement, yield expression, async function definitions, 15.8, with relation to function definitions, 15.2. 42. ECMA International 2024, 13 ECMA script language. Expressions. 3.1 Identifier syntax. Identifier reference. Yield. Await. Identifier. Yield. Yield. Await. Await. Binding identifier. Yield. Await. Identifier. Yield. Await. Label identifier. Yield. Await. Identifier. Yield. Yield. Await. Await. Identifier. Identifier name but not reserved word. 3. 1. 1 static semantics. Early errors. Binding identifier. Identifier. It is a syntax error if the source text matched by this production is contained in strict mode code and the string value of identifier is either arguments or eval. Identifier reference. Yield binding identifier. Yield label identifier. Yield. It is a syntax error if the source text matched by this production is contained in strict mode code. Identifier reference. Await binding identifier. Await label identifier. Await. It is a syntax error if the goal symbol of the syntactic grammar is module. Binding identifier. Yield. Await. Yield. It is a syntax error if this production has a yield parameter. Binding identifier. Yield. Await. Await. ECMA International 2024-243. Yield and await are permitted as binding identifier in the grammar and prohibited with static. Note, semantics below. To prohibit automatic semicolon insertion in cases such as let await 0, it is a syntax error if this production has an await parameter, identifier reference, yield, await, identifier binding identifier, yield, await, identifier label identifier, yield, await, identifier. It is a syntax error if this production has a yield parameter and string value of identifier as yield. It is a syntax error if this production has an await parameter and string value of identifier as await. Identifier. Identifier name but not reserved word. It is a syntax error if this phrase is contained in strict mode code and the string value of identifier name is one of implement, s, interface, let, package, private, protected, public, static, or yield. It is a syntax error if the goal symbol of the syntactic grammar is module and the string value of identifier name is await. It is a syntax error if the string value of identifier name is the string value of any reserved word except for yield or await. 3. 1. 2. Static semantics. String value. The syntax-directed operation string value takes no arguments and returns a string. It is defined piecewise over the following productions: identifier name, identifier start, identifier name, identifier part. Let id text unescape be identifier code points of identifier name, return code points to string, id text unescaped, identifier reference, yield binding identifier, yield label identifier, yield, return yield, identifier reference, await binding identifier, await label identifier, await, return await, identifier, identifier name but not reserved word, return the string value of identifier name, private identifier, identifier name, return the string concatenation of 0 times 0023, number sign, and the string value of identifier name, module export name, string literal 1. Return the SV of string literal. Note string value of identifier name normalizes any Unicode escape sequences in identifier name, hence such escapes cannot be used to write an identifier whose code point sequence is the same as a reserved word. 44. ECMA International 2024. 1.3.1. 3. Runtime semantics. Evaluation. Identifier reference. Identifier. Return. Resolve binding. String value of identifier, identifier reference, yield, return, resolve binding, yield, identifier reference, await, return, resolve binding, await. Note 1. The result of evaluating an identifier reference is always a value of type reference. 3.2. Primary expression syntax. Primary expression, yield, await. This identifier reference yield await, literal, array literal yield await, object literal yield await, function expression, class expression yield await, generator expression, async function expression, async generator expression, regular expression literal, template literal yield await, tagged, capital C O V E R, capital P A R E N T H E S I Z E D, capital E X P R E S S I O N, capital A N, yield await, capital C O V E R, capital P A R E N T H E S I Z E D, capital E X P R E S S I O N, capital A N, yield await, expression plus in yield await, expression plus in
I told Chatbot,
binding identity.
can you break it down into separate functions? What needs to be called only initially, and what needs to be run later in the runtime and loop. I'm tired of this. This does not end. Chatbot said you're right. The while concept is long and exhausting, especially when mixing CPU and GPU resource flows. So let me break it down simply into two phases.
That such an evaluation only can occur for non-strict code.
Blah blah blah. Startup only once. And the Chatbot does this.
Mental syntax. When processing an instance of the production.
It's like the complete opposite of what I was asking. Chatbot's like, it's a long, exhausting process. It is. This is very boring. I'm tired of this. Chatbot's like, I understand, so here's how you do it. And it gives me steps and a comment. It doesn't actually update the example. Chatbot decided to be even more annoying. It gave me steps of what to do, so I still have to do all the fucking work. I told it, I'm tired of doing this. I'm tired of it giving me bad code that doesn't work. I'm tired of fixing that code. I'm tired of Chatbot. This is really dumb. This isn't helpful. So I asked Chatbot again. I'd ask it to put the code inside of functions, apparently. Because apparently it thought, yeah, this will be really helpful. I'll just like do this and not really actually give you what you're asking. It's really not helpful. It's really frustrating. I'm trying to write the JavaScript engine.
Resolve this binding. 3, 2, identify a reference.
I just need a shader program to pixelate the screen.
Syntax.
That's all I want. It's literally all I want.
String literal. 3.
This is ridiculous. This is so difficult.
Evaluation. Literal. Null literal 1. Return null. Literal. Boolean literal. If Boolean literal is the token false, return false. If Boolean literal is the token true, return true. Literal. Numeric literal. Return the numeric value of numeric literal as defined in 1, 2, 9, 3. Literal. String literal. Return the SV of string literal as defined in 1, 2, 9, 4, 2, 46. ECMA International 2024. 1, 3, 2. 4 array initializer. Array elements may be elided at the beginning, middle, or end of the element list. Whenever a comma in the element list is not preceded by an assignment expression, that is, a comma at the beginning or after another comma, the missing array element contributes to the length of the array and increases the index of subsequent elements. Elided array elements are not defined. If an element is elided at the end of an array, that element does not contribute to the length of the array. Syntax. Array literal. Yield. Await. Elision element list yield await. Element list yield await. Elision element list yield await. Elision assignment expression plus in yield await. Elision spread element yield await. Element list yield await. Elision assignment expression plus in yield await. Element list yield await. Elision spread element yield await. Elision spread element yield await. Dart. Assignment expression plus in yield await. 1, 3, 2, 4, 1 runtime semantics. Array accumulation. The syntax-directed operation array accumulation takes arguments array, an next int x, an integer, and returns either a normal completion containing an integer or an abrupt completion. It is defined piecewise over the following productions. Elision. Let len be next index plus 1. Perform. Set. Array. Length. Len. True. Note. The above step throws if len exceeds 232. 1. Return len. Elision. Return. Array accumulation of elision with arguments array and next index plus 1. Element list. Elision assignment expression. If elision is present, then a set next index 2. Array accumulation of elision with arguments array and next index. Let init result be. Evaluation of assignment expression. Let init value be. Get value. Init result. Perform. Create data property or throw array to string next int x. Init value. Return next index plus 1. Note an array literal is an exp ration describing the initialization of an array using a list of 0 or more expressions, each of which represents an array element, enclosed in square brackets. The elements need not be literals. They are evaluated each time the array initializer is evaluated. ECMA International 2024 247. Element list. Elision spread element. If elision is present, then a set next index 2. Array accumulation of elision with arguments array and next index. Return. Array accumulation of spread element with arguments array and next index. Element list. Elision assignment expression. Set next index 2. Array accumulation of element list with arguments array and next index. If elision is present, then set next index 2. Array accumulation of elision with arguments array and next index. Let init result be. Evaluation of assignment expression. Let init value be. Get value. Init result. Perform. Create data property or throw array to string next int x init value. Return next index +1. Element list. Elision spread element. Set next index 2. Array accumulation of element list with arguments array and next index. If elision is present, then set next index 2. Array accumulation of elision with arguments array and next index 3. Return. Array accumulation of spread element with arguments array and next index. Spread element. Assignment expression. Let spread ref be. Evaluation of assignment expression. Let spread obj be. Get value. Spread ref. Let iterator record be. Get iterator. Spread obj. Sync. Repeat. Let next be. Iterator step value. Iterator record. B if next is done. Return next index. C perform. Create data property or throw array to string next int x next. D set next index to next index +1. Note create data property or throw is used to ensure that own properties are defined for the array even if the standard built-in array prototype object has been modified in a manner that would preclude the creation of new own properties using 3, 2, 4, 2. Runtime semantics. Evaluation. Array literal. Elision let array be. Array create 0 if elision is present, then perform. Array accumulation of elision with arguments array and 0, 3. Return array. Array literal. Element list. Let array be. Array create 0 perform. Array accumulation of element list with arguments array and 0. Return array. Array literal. Element list. Elision 2. Let array be. Array create 0. Let next index be. Array accumulation of element list with arguments array and 0. 48. ECMA International 2024. 3. If elision is present, then perform. Array accumulation of elision with arguments array and next index. Return array. 3, 2, 5. Object initializer. Syntax. Object literal. Yield. Await. Property definition list yield await. Property definition list yield await. Property definition list. Yield. Await. Property definition yield. Question mark await. Property definition list yield await. Property definition yield await. Property definition. Yield. Await. Identifier reference yield await. Cover initialized name yield await. Property name yield await. Assignment expression. Plus in yield await. Method definition yield await. Dart. Assignment expression. Plus in yield await. Property name. Yield. Await. Literal property name. Computed property name yield await. Literal property name. Identifier name. String literal numeric literal. Computed property name. Yield. Await. Assignment expression. Plus in yield await. Cover initialized name. Yield. Await. Identifier reference yield await. Initializer. Plus in yield await. Initializer. In. Yield. Await. Assignment expression in yield await. Note 2 method definition is defined in 15.4. Note 1 an object initializer is an expression describing the initialization of an object, written in a form resembling a literal. It is a list of 0 or more pairs of property keys and associated values, enclosed in curly brackets. The values need not be literals. They are evaluated each time the object initializer is evaluated. Copyright sign. ECMA International 2024-249. Note 3 in certain contexts. Object literal is used as a cover grammar for a more restricted secondary grammar. The cover initialized name production is necessary to fully cover these secondary grammars. However, use of this production results in an early syntax error in normal contexts where an actual object literal is expected. 3, 2, 5, 1 static semantics. Early errors. Property definition. Method definition, bullet. It is a syntax error if has direct super of method definition is true. It is a syntax error if private bound identifiers of method definition is not empty. In, used as a cover grammar for object assignment pattern and may be recognized as part of a capital C, O, V, E, R, capital P, A, R, E, N, T, H, E, S, I, Z, E, D, capital E, X, P, R, E, S, S, I, O, N, capital A, N. When object literal appears in a context where object assignment pattern is required, the following early error rules are not applied. In addition, they are not applied when initially parsing a capital C, O, V, E, R, capital P, A, R, E, N, T, H, E, S, I, Z, E, D, capital E, X, P, R, E, S, S, I, O, N, capital A, N, or capital C, O, V, E, R, capital C, A, L, L, capital E, X, P, R, E, S, S, I, O, N, capital A, N, D, capital A, S, Y, N, C, capital A, R, R. Property definition. Cover initialized name. It is a syntax error if any source text is matched by this production. Object literal. Property definition list. Property definition list. It is a syntax error if property name list of property definition list contains any duplicate entries for proto and at least two of those entries were obtained from productions of the form. Property definition. Property name. Assignment expression. This rule is not applied if this object literal is contained within a script that is being parsed for JSON parse. See step 4 of JSON parse. 3, 2, 5. To static semantics is computed property key. The syntax directed operation is computed property key takes no arguments and returns a boolean. It is defined piecewise over the following productions. Property name, literal pro. Property name, return false. Property name, computed property name, return true. Addition to describing an actual object initializer. The object literal productions are also 250 ECMA International 2024. Note 1. This production exists so that object literal can serve as a cover grammar for object assignment pattern. It cannot occur in an actual object initializer. Note 2. The list returned by property name list does not include property names defined using a computed property name. 1, 3, 2, 5, 3. Static semantics. Property name list. The syntax directed operation property name list takes no arguments and returns a list of strings. It is defined piecewise over the following productions. Property definition list. Property definition. Let prop name be prop name of property definition. If prop name is empty, return a new empty list. Return prop name. Property definition list. Property definition list. Property definition. Let list be property name list of property definition list. Let prop name be prop name of property definition. If prop name is empty, return list. Return the list concatenation of list and prop name. 3, 2, 5. For runtime semantics. Evaluation. Object literal. Return ordinary object create. Percent object prototype. Percent object literal. Property definition list. Property definition list. Let obj be ordinary object create. Percent object prototype. Percent perform. Property definition. Evaluation of property definition list with argument obj. Return obj. Literal property name. Identifier name. Return string value of identifier name. Literal property name. String literal 1. Return the SV of string literal. Literal property name. Numeric literal. Let NBR be the numeric value of numeric literal. Return to string NBR. Computed property name. Assignment expression. Let X per value be. Evaluation of assignment expression. Let prop name be. Get value. X per value. Return to property key. Prop name. 3, 2, 5. 5. Runtime semantics. Property definition evaluation. The syntax-directed operation property definition evaluation takes argument object, an object, and returns either a normal completion containing unused or an abrupt completion. It is defined piecewise over the following productions: property definition list, property definition list, property definition, perform. Property definition evaluation of property definition list with argument object, perform. Property definition evaluation of property definition with argument object, return unused. ECMA International 2024 251. Property definition. Assignment expression. Let X per value B. Evaluation of assignment expression. Let from value B. Get value, X per value. Let excluded names be a new empty list. Perform. Copy data properties. Object. From value. Excluded names. Return unused. Property definition. Identifier reference. Let prop name be string value of identifier reference. Let X per value be. Evaluation of identifier reference. Let prop value be. Get value, X per value. Assert. Object is an ordinary, extensible object with no non-configurable properties. Perform. Create data property or throw. Object. Prop name. Prop value. Return unused. Property definition. Property name. Assignment expression. Let prop key be. Evaluation of property name. If this property definition is contained within a script that is being evaluated for JSON parse. See step 7 of JSON parse. Then, a let is proto set to be false. Else if prop key is proto and is computed, property key of property name is false. Then a let is proto set to be true. Else, a let is proto set to be false. If is anonymous function definition, assignment expression, is true and is proto setter is false. Then in let prop value be. Named evaluation of assignment expression with argument prop key. Else, a let X per value ref be. Evaluation of assignment expression be let prop value be. Get value, X per value ref. If this proto setter is true, then if prop value is an object or prop value is null, then I perform object, prop value be return unused. Assert. Object is an ordinary, extensible object with no non-configurable properties. Perform. Create data property or throw. Object. Prop key. Prop value 0. Return unused. Property definition. Method definition. Perform. Method definition evaluation of method definition with arguments, object and true. Return unused. 3. 2. 6 function defining expressions. See 15.2 for primary expression. Function expression. See 15.5 for primary expression. Generator expression. See 15.7 for primary expression. Class expression. See 15.8 for primary expression. Async function expression. See 15.6 for primary expression. Async generator expression. 52. Copyright sign. ECMA International 2024. 132. 7 regular expression literal syntax. C12. 9. 5. 3. 2. 7. 1 static semantics. Early errors. Primary expression. Regular expression literal. It is a syntax error if capital I, S, capital V, A, L, I, D, capital R, E, G, U, L, A, R, capital E, X, P, R, E, S, S, I, O, N, capital L, I, T, E, R, A, regular expression literal, is false. 3, 2, 7, 2 static semantics, capital I, S, capital V, A, L, I, D, capital R, E, G, U, L, A, R, capital E, X, P, R, E, S, S, I, O, N, capital L, I, T, E, R, A, literal. The abstract operation, capital I, S, capital V, A, L, I, D, capital R, E, G, U, L, A, R, capital E, X, P, R, E, S, S, O N capital L I T E R A takes argument literal, a regular expression literal parse node, and returns a boolean. It determines if its argument is a valid regular expression literal. It performs the following steps when called. Let flags be flag text of literal. If flags contains any code points other than D, G, I, M, S, U, V, or Y, or if flags contains any code point more than once, return false. If flags contains U, let U be true, else let U be false. If flags contains V, let V be true, else let V be false. Let pattern text be body text of literal. If U is false and V is false, then a let string value be code points to string pattern text. B set pattern text to the sequence of code points resulting from interpreting each of the 16.
So I got this whatever in place. I accidentally made this if 9. I might do if 0. If 0, whatever. My finger slipped. Hit 9. It ended up running. So I don't know, it works, whatever. And I was like, oh yeah, it's almost done. Oh wait, I accidentally left it on. Oh wait, it's working. I'm like, oh, I must have just forgot to set something. Like, okay, that's what I entered. I did if 9. I meant to do 0. I was like, oh wait, it's not done. I still have this here. So put this back to if 0. So I turn on this now. And when I turn this on, voila. A whole bunch of new structs, properties to set, things to initialize. Holy crap. This is the worst. Literal. The fucking worst. I'm almost done. Just a couple more structs to go. It's like structception. Just fucking structs. It doesn't end. I need to be done. I have to get to the standard. Can't do that until I have the program to pixelate the screen when I'm working on code that I'm not giving away for free. I simply need to be able to like toggle between when to show the screen and when not to. And I can't find a program that runs on an old computer like optimally. It really lags it down. So I gotta make one. Almost done. This took way too long. It just doesn't seem to end. It will end though. It has to be today. I'm so close to being done. There's no way. No way. Done today.
A let value be. Named evaluation of initializer with argument function object, else a let RHS be. Evaluation of assignment expression be let value be. Get value, RHS, return completion record, return, value, empty, class static block body, class static block statement list, assert, arguments list is empty, return. Evaluate class static block body of class static block body with argument function object, 0, 2, 1. For ordinary call evaluate body, F, arguments list. The abstract operation ordinary call evaluate body takes arguments F, an ECMA script function object, and arguments list, a list of ECMA script language values, and returns either a normal completion containing an ECMA script language value or an abrupt completion. It performs the following steps when called. Return. Evaluate body of F with arguments F and arguments list 1, 0, 2, 2. Arguments list. New target. The internal method of an ECMA script function object F takes arguments list, a list of ECMA script language values, and new target, a constructor, and returns either a normal completion containing an object or a throw completion. It performs the following steps when called. Let caller context be the running execution context. Let kind be F, if kind is base. Then, a let this argument be. Ordinary create from constructor. New target. %object prototype %4. Let callee context be prepare for ordinary call. F. New target. 178. ECMA International 2024. Note even though field initializers constitute a function boundary, calling capital F, U, N, C, T, I, O, N, capital D, E, C, L, A, R, A, T, I, O, N, capital I, N, S, T, A, N, T, I, A, T, I, does not have any observable effect and so is omitted. 5. Assert. Callee context is now the running execution context. If kind is base, then a perform ordinary call bind this. F. Callee context. This argument, be let initialize result be completion, initialize instance elements. This argument, F, see if initialize result is an abrupt completion, then I remove callee context from the execution context stack and restore caller context as the running execution context. 2. Return initialize result. Let constructor env be the lexical environment of callee context. Let result be completion, ordinary call evaluate body. F. Arguments list. Remove callee context from the execution context stack and restore caller context as the running execution context. 0. If result is a return completion, then if result is an object, return result. B if kind is base, return this argument. See if result is not undefined. Throw a type error exception. 1. Else a return if abrupt. Result. 2. Let this binding be constructor env get this binding. 3. Assert. This binding is an object. 4. Return this binding. 0. 2. 3 ordinary function create. Function prototype. Source text. Parameter list. Body. This mode. env. Private env. The abstract operation ordinary function create takes arguments fun. Shine prototype. An object. Source text. A sequence of Unicode code points. Parameter list. A parse node. Body a parse node. This mode. Lexical this or non-lexical this. env. An environment record. And private env. A private environment record or null. And returns an ECMA script function object. It is used to specify the runtime creation of a new function with a default internal method and no internal method, although one may be subsequently added by an operation such as make constructor. Dart source text is the source text of the syntactic definition of the function to be created. It performs the following steps when called. Let internal slots list be the internal slots listed in table 30. Let f be ordinary object create. Function prototype. Internal slots list. Set f to the definition specified in 1, 0, 2, 1. Set f to source text. Set f to parameter list. Set f to body. If the source text matched by body is strict mode code, let strict be true, else let strict be false. Set f to strict. If this mode is lexical this. Set f to lexical 0, else if strict is true, set f to strict 1, else. Set f to global 2. Set f to false 3. Set f to env 4. Set f to private env 5. Set f to get active script or module 6. Set f to the current realm record 7. Set f to undefined 8. Set f to a new empty list 9. Set f to a new empty list 0. Set f to empty 1. Let len be the expected argument counter parameter list 2. Perform set function length f len 3. Return f ECMA International 2024 179 10 2 4 capital A D D capital R E S T R I C T E D capital F U N C T I O N capital P R O P E R T I E F realm. The abstract operation capital A D D capital R E S T R I, C, T, E, D, capital F, U, N, C, T, I, O, N, capital P, R, O, P, E, R, T, I, E, takes arguments F, a function object, and realm, a realm record, and returns unused. It performs the following steps when called. Assert. Realm exists and has been initialized. Let thrower be realm. Perform. Define property or throw. F. Caller. Property descriptor. Thrower. Enumerable. False. True. Perform. Define property or throw. F. Arguments. Property descriptor. Thrower. Enumerable. False. True. Return unused. 0, 2, 4, 1% throw type error %. This function is the %throw type error % intrinsic object. It is an anonymous built-in function object that is defined once for each realm. It performs the following steps when called. Throw type error exception. The value of the internal slot of this function is false. The length property of this function has the attributes false, false, false. The name property of this function has the attributes false, false, false. 0, 2, 5. Make constructor. F. Writable prototype. Prototype. The abstract operation make constructor takes argument F, any CMA script function object or a built-in function object, and optional arguments writable prototype, a boolean, and prototype, an object, and returns unused. It converts F into a constructor. It performs the following steps when called. If F is an ECMA script function object, then A assert is constructor, F is false. B assert. F is an extensible object that does not have a prototype own property. C set F to the definition specified in 10, 2, 2. Else A set F to the definition specified in 10, 3, 2. Set F to base. If writable prototype is not present, set writable prototype to true. If prototype is not present, then A set prototype to ordinary object create. %object prototype %. B perform. Define property or throw. Prototype. Constructor. Property descriptor. F. Writable. Writable prototype. False. True. Perform. Define property or throw. F. Prototype. Property descriptor. Prototype. Writable prototype. False. False. Return unused. 80. ECMA International 2024. 102. 6. Make class constructor. F. The abstract operation make class constructor takes argument F, any CMA script function object, and returns unused. It performs the following steps when called. Assert. F is false. Set F to true. Return unused. 0, 2, 7. Make method. F. Home object. The abstract operation make method takes arguments F, any CMA script function object, and home object, an object, and returns unused. It configures F as a method. It performs the following steps when called. Set F to home object. Return unused. 0, 2, 8. Define method property. Home object. Key. Closure. Enumerable. The abstract operation define method property takes arguments home object, an object, key, a property key or private name, closure, a function object, and enumerable, a boolean, and returns either a normal completion containing either a private element or unused, or an abrupt completion. It performs the following steps when called. Assert. Home object is an ordinary, extensible object. If key is a private name, then a return private element. Method. Closure 3. Else a let desk be the property descriptor. Closure. True. Enumerable. True. B perform. Define property or throw. Home object. Key. Desk. C note. Define property or throw only returns an abrupt completion when attempting to define a class. Static method whose key is prototype. Direct and unused. 0, 2, 9. Set function name. F. Name. Prefix. The abstract operation set function name takes arguments F, a function object, a name, a property key or private name, and optional argument prefix, a string, and returns unused. It adds a name property to f. It performs the following steps when called. Assert. F is an extensible object that does not have a name own property. If name is a symbol, then a let description be name's value. B if description is undefined. Set name to the empty string. C else. Set name to the string concatenation of description. And else if name is a private name. Then a set name to name. If f has an internal slot, then a set f to name. If prefix is present, then a set name to the string concatenation of prefix. The code unit 0 times 0020 space and name. B if f has an internal slot, then I optionally set f to name. Perform. Define property or throw f. Name. Property descriptor. Name. False. Enumerable. False. True. Return unused. ECMA International 2024 181. The 10th of February 2010. Set function length. F. Length. The abstract operation set function length takes arguments f, a function object, and length, a non-negative int, ger or plus, and returns unused. It adds a length property to f. It performs the following steps when called. Assert. F is an extensible object that does not have a length own property. Perform. Define property or throw f. Length. Property descriptor. Length. False. Enumerable. False. True. Return unused. 0, 2, 1, 1. Capital F U N C T I O N. Capital D E C L A R A T I O N. Capital I N S T A N T I A T I. Func. Arguments list. The abstract operation. Capital F U N C T I O N. Capital D E C L A R A T I O N. Capital I N S T A N T I A T I. Takes arguments func, an ECMA script function object, and arguments list, a list of ECMA script language values, and returns either a normal completion containing unused or an abrupt completion. Func is the function object for which the execution context is being established. Note 1. When an execution context is established for evaluating an ECMA script function, a new function environment record is created and bindings for each formal parameter are instantiated in that environment record. Each declaration in the function body is also instantiated. If the function's formal parameters do not include any default value initializers, then the body declarations are instantiated in the same environment record as the parameters. If default value parameter initializers exist, a second environment record is created for the body declarations. Formal parameters and functions are initialized as part of capital F U N C T I O N. Capital D E C L A R A T I O N. Capital I N S T A N T I A T I. All other bindings are initialized during evaluation of the function body. It performs the following steps when called. Let callee context be the running execution context. Let code be func. ECMA script code. Let strict be func. Let formals be func. Let parameter names be the bound names of formals. If parameter names has any duplicate entries, let has duplicates be true. Otherwise, let has duplicates be false. Let simple parameter list be as simple parameter list of formals. Let has parameter expressions be contains expression of formals. Let var names be the var declared names of code. 0. Let var declarations be the var scope declarations of code. 1. Let lexical names be the lexically declared names of code. 2. Let function names be a new empty list. 3. Let functions to initialize be a new empty list. 4. For each element D of var declarations, in reverse list order, Do if D is neither a variable declaration nor a binding nor a binding identifier. Then I assert D is either a function declaration, a generator declaration, an async function declaration, or an async generator declaration. 2. Let fn be the sole element of the bound names of D. 3. If function names does not contain fn, then insert fn as the first element of function names. Note: if there are multiple function declarations for the same name, the last declaration is used. Insert D as the first element of functions to initialize. 5. Let arguments object needed be true. 6. If func is lexical, then a note: arrow functions never have an arguments object. B set arguments object needed to false. 7. Else if parameter names contains arguments, then a set arguments object needed to false. 82. ECMA International 2024. 18. Else if his parameter expressions is false, then a function names contains arguments or lexical names contains arguments, then I set arguments object needed to false. 9. If strict is true or has parameter expressions is false, then a note: only a single environment record is needed for the parameters, since calls to eval in strict mode code cannot create new bindings which are visible outside of the eval. B let env be the lexical environment of callee context. 0. Else a note: a separate environment record is needed to ensure that bindings created by direct eval calls in the formal parameter list are outside the environment where parameters are declared. B let callee env be the lexical environment of callee context. C let env be new declarative environment. Callee env. D assert the variable environment of callee context is callee env. E set the lexical environment of callee context to env. 1. For each string param name of parameter names, do a let already declared benv has binding. Param name. B note: early errors ensure that duplicate parameter names can only occur in non-strict functions that do not have parameter default values or rest parameters. See if already declared is false, then I perform env create mutable binding. Param name. False. 2. If his duplicates is true, then perform env initialize binding. Param name. Undefined. 22. If arguments object nay dead is true, then if strict is true or simple parameter list is false, then I let AOB create a mapped arguments object arguments list. B else I note: a mapped argument object is only provided for non-strict functions that don't have a rest parameter, any parameter default value initializers, or any destructured parameters. 2. Let AOB create mapped arguments object fun.
I told Chatbot originally
env. See if
they want to like invert the pipeline
binding argument
or like invert the display.
in strict mode code,
So Chatbot would like account for the shader effect.
so its mutability.
Now I just want to run it. I just want to fucking run it. I want it to work. I want to click run.
E perform env
But I can't do that
arguments
because apparently I need to bind it to the pipeline.
and arguments. 3. Else a let parameter
And apparently I have to bind it
let it
and I have to pass in something.
iterate to record arguments list. 5. If his
So I want to pass in
form iterate a binding initialization
not invert pipeline because it might not work.
undefined
I don't want to deal with a black screen. I just want to like copy the bytes.
of formals with arguments iterate a record in env 27. If his parameter expressions is false, then a note: only a single environment record is needed for the parameters in top level vars. B let instantiated var names be a copy of the
So now I gotta make
C for each element n of var names. Do
a freaking pass through pipeline.
then
A texture pass through pipeline.
v create mutable binding
Oh my god, this just doesn't end.
initialize binding n undefined. D let var
And I like compile it beforehand.
note: a separate environment record
Oh my god, I can't take it.
expressions and
I just want a simple thing. That's all I wanted.
function body. B
And I'm so close. And there's always one last little thing.
environment
This needs to be the last thing.
instantiated var names being
If it is and it works,
for each element n of var names. Do I
all that's left is to modify this
International
to pixelate the display,
83 1
but
instantiated varnate
I also have to like paste a 2D image on top of it.
parameter bindings does
Take it like the TV frame or whatever.
contains n then a let initial value be
I can settle for like just a black box for now. I'll just do that. Just settle for that.
false perform
And I'll add the fancy border that looks like the TV later.
note
Because I just want to be done. I can't. It does not end. It's a copy to this thing, to that thing. You set this, you init that, you uninitialize that, you make a freaking opaque handle pointer to this and that.
xenv
Holy crap, this is ridiculous. Everything works around the video card without actually working on the video card itself. Holy crap.
determine whether
It takes like 4 times the amount of code.
the eval codes
You literally have to call.
lexically scoped declarations. This is not needed for strict functions because a strict direct
You have to call
declarations in
map memory right before.
lexien
Then you have to do the operation.
the lexic
Then you have to unmap the memory.
nv3
If you're working on the GPU directly,
lexically scoped declarations of code.
this wouldn't have to be called before. That wouldn't have to be called after. Or after and before. Or before and after.
The same as a
You'd be able to just directly work with the memory.
name. Lex
But no, it's like all this extra before and after, do the operation, clean up. Holy crap, this does not end.
then perform lexien
I'm almost done though. It's gotta end. This has to freaking end. I just need a shooter program.
binding.
A simple little thing. It's taking 7 days now. 7 24-hour days.
For each parse node f of
This is really long. Really long.
of the bound names of
I need to be done.
a function object of
Almost done.
the c
Making shaders sucks.
fo false 7 return unused 0.3 built-in function objects. A built-in function object is an ordinary object. It must satisfy the requirements for ordinary objects set out in 10.1. In addition to the internal slots required of every ordinary object, see 10.1, a built-in function object must also have the following internal slots: a realm record that represents the realm in which the function was created, a string that is the initial name of the function. It is used by 2, 0, 2, 3, 5. The initial value of a built-in function object's internal slot is %function prototype %, unless otherwise specified. A built-in function object must have an internal method that conforms to the definition in 1.0.3.1. A built-in function object has an internal method if and only if it is described as a constructor, or some algorithm in this specification explicitly sets its internal method. Such an internal method must conform to the definition in 1.0.3.2. An implementation may provide additional built-in function objects that are not defined in this specification. Note 2b. 3.2 provides an extension to the above algorithm that is necessary for backwards compatibility with web browser implementations of ECMAScript that predate ECMAScript 2015. 84. Copyright sign, ECMA International 2024, 1.0.3.1. This arguments list. The internal method of a built-in function object f takes arguments this argument, an ECMAScript language value, and arguments list, a list of ECMAScript language values, and returns either a normal completion containing an ECMAScript language value or a throw completion. It performs the following steps when called: return, built-in call or construct, f, this argument, arguments list, undefined 1.0.3.2, arguments list, new target, the internal method of a built-in function object f, when the method is present, takes arguments list, a list of ECMAScript language values, a new target, a constructor, and returns either a normal completion containing an object or a throw completion. It performs the following steps when called: return, built-in call or construct, f, uninitialized, Arguments list. New target 1 0 3 3 built-in call or construct f. This argument. Arguments list. New target. The abstract operation built-in call or construct takes arguments f, a built-in function object. This argument, an ECMA script language value or uninitialized. Arguments list. A list of ECMA script language values. A new target. A constructor or undefined, and returns either a normal completion containing an ECMA script language value or a throw completion. It performs the following steps when called. Let caller context be the running execution context. If caller context is not already suspended, suspend caller context. Let callee context be a new execution context. Set the function of callee context to f. Let callee realm be f. Set the realm of callee context to callee realm. Set the script or module of callee context to null. Perform any necessary implementation defined initialization of callee context. Push callee context onto the execution context stack. Callee context is now the running execution context. 0. Let result be the completion record that is the result of evaluating f in a manner that conforms to the specification of f if this argument is uninitialized. This value is uninitialized. Otherwise, this argument provides the this value arguments list provides the named parameters new target provides the new target value 1. Note, if f is defined in this document, the specification of f is the behavior specified for it via algorithm steps or other means. 2. Remove callee context from the execution context stack and restore caller context as the running execution context. 3. Return result 0, 3, 4 create built-in function, behavior, length, name, additional internal slots list, realm, prototype, prefix. The abstract operation create built-in function takes arguments behavior, an abstract closure, a set of algorithm steps, or some other definition of a function's behavior provided in this specification, length, a non-negative integer or plus, name, a property key or a private name, and additional internal slots list, a list of names of internal slots, and optional arguments realm, a realm record, prototype, an object or null, and prefix, a string. And returns a function object additional internal slots list contains the names of additional internal slots that must. Note when callee context is removed from the execution context stack it must not be destroyed if it has been suspended and retained by an accessible generator for later resumption. ECMA International 2024-185 be defined as part of the object. This operation creates a built-in function object. It performs the following steps when called. If realm is not present, set realm to the current realm record. If prototype is not present, set prototype to realm. Let internal slots list be a list containing the names of all the internal slots that 10.3 requires for the built-in function object that is about to be created. Append to internal slots list the elements of additional internal slots list. Let func be a new built-in function object that, when called, performs the action described by behavior, using the provided arguments as the values of the corresponding parameters specified by behavior. The new function object has internal slots whose names are the elements of internal slots list, and an internal slot. Set func to prototype, set func to true, set func to realm, set func to null. 0. Perform set function length, func, length 1. If prefix is not present, then a perform set function name, func, name 12. Else a perform set function name, func, name, prefix 13. Return func. Each built-in function defined in this specification is created by calling the create built-in function abstract operation. 0.4 built-in exotic object internal methods and slots. This specification defines several kinds of built-in exotic objects. These objects generally behave similar to ordinary objects except for a few specific situations. The following exotic objects use the ordinary object internal methods except where it is explicitly specified otherwise below. 0, 4, 1 bound function exotic objects. A bound function exotic object is an exotic object that wraps another function object. A bound function exotic object is callable. It has an internal method and may have an internal method. Calling a bound function exotic object generally results in a call of its wrapped function. An object is a bound function exotic object if its and, if applicable, internal methods use the following implementations, and its other essential internal methods use the definitions found in 10.1. These methods are installed in bound function create. Bound function exotic objects do not have the internal slots of ECMA script function objects listed in Table 30. Instead, they have the internal slots listed in Table 31, in addition to Table 31, internal slots of bound function exotic objects. Internal slot. Type. Description. Bound target function. A callable object. The wrapped function object. Bound this. An ECMA script language value. The value that is always passed as this value when calling the wrapped function. Bound arguments. A list of ECMA script language values. A list of values whose elements are used as the first arguments to any call to the wrapped function. 186. ECMA International 2024 10411. This argument, argue, NTS list. The internal method of a bound function exotic object F takes arguments this argument, an ECMA script language value, and arguments list, a list of ECMA script language values, and returns either a normal completion containing an ECMA script language value or a throw completion. It performs the following steps when called. Let target be F, let bound this be F, let bound args be F, let args be the list concatenation of bound args and arguments list. Return. Call. Target. Bound this. Args 0, 4, 1, 2. Arguments list. New target. The internal method of a bound function exotic object F takes arguments list, a list of ECMA script language values, a new target, a constructor, and returns either a normal completion containing an object or a throw completion. It performs the following steps when called. Let target be F, assert, is constructor, target, is true. Let bound args be F. Let args be the list concatenation of bound args and arguments list. If same value, F, new target, is true. Set new target to target. Return. Construct, target, args, new target. 0, 4, 1. 3 bound function create. Target function. Bound this. Bound args. The abstract operation bound function create takes arguments target function, a function object. Bound this. An ECMA script language value. And bound args. A list of ECMA script language values. And returns either a normal completion containing a function object or a throw completion. It is used to specify the creation of new bound function exotic objects. It performs the following steps when called. Let proto be target function. Let internal slots list be the list concatenation of and the internal slots listed in Table 31. Let obj be make basic object. Internal slots list. Set obj to proto. Set obj as described in 1, 0, 4, 1, 1. If this constructor, target function, is true, then, a set obj as described in 1, 0, 4, 1, 2. Set obj to target function. Set obj to bound this. Set obj to bound args 0. Return obj 0, 4. To array exotic objects. An array is an exotic object that gives special treatment to array index property keys. C6, 1, 7. A property whose property name is an array index is also called an element. Every array has a non-configurable length property whose value is always a non-negative integral number whose mathematical value is strictly less than 32. The value of the length property is numerically greater than the name of every known property whose name is an array index, whenever a known property of an array is created or changed. Other properties are adjusted as necessary to maintain this invariant. Specifically, whenever a known property is added whose name is an array index, the value, if the length property is changed, if necessary, to be one more than the numeric value of that array index, and whenever the value of the length property is changed. Every own property whose name is an array index whose value is not smaller than the new length is deleted. This constraint applies only to own. ECMA International 2024 187. Properties of an array and is unaffected by length or array index properties that may be inherited from its prototypes. An object is an array exotic object, or simply, an array, if its internal method uses the following implementation, and its other essential internal methods use the definitions found in 10.1. These methods are installed in array create 0, 4, 2, 1, p, desk. The internal method of an array exotic object takes arguments p, a property key, and desk, a property descriptor, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. If p is length, then a return array set length a desk. Else if p is an array index, then a let length desk be ordinary get own property a length b assert is data descriptor length desk is true c assert length desk is false d let length be length desk e assert length is a non-negative integral number f let index b 32 p g if index length and length desk is false return false h let succeeded b ordinary define known property a p desk I have succeeded is false return false j if index length then I set length desk to index plus 1 2 set succeeded to ordinary define known property a length desk 3 assert succeeded is true k return true return ordinary define known property a p desk 0 4 2 to array create length proto the abstract operation array create takes argument length a non-negative integer and optional argument proto an object and returns either a normal completion containing an array exotic object or a throw completion. It is used to specify the creation of new arrays. It performs the following steps when called. If length 232 1, throw a range error exception. If proto is not present, set proto to %array prototype %. Let a be make basic object. Set a to proto. Set a is specified in 1 0 4 2 1. Perform ordinary define known property a length property descriptor length true false false return a 0 4 2 3 array species create original array length the abstract operation array species create takes arguments original array an object and length a non-negative integer and returns either a normal completion containing an object or a throw completion. It is used to specify the creation of a new array or similar object. Using a constructor function that is derived from original array. It does not enforce that the constructor function returns an array. It performs the following steps when called. Let is array be is array original array. If is array is false, return array create length let c be get original array constructor. If this constructor c is true, then 88 ECMA International 2024. Let this realm be the current realm record. B let realm be get function realm c. See if this realm and realm are not the same realm record. Then I have same value c realm is true. Set c to undefined. If c is an object, then I set c to get c at species. B if c is null, set c to undefined. If c is undefined, return array create length. If this constructor c is false, throw a type error exception. Return construct c length 0 4 2 4 array set length a desk. The abstract operation array set length takes arguments a an array and desk a property descriptor and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. If desk does not have a field, then a return ordinary define known property a length desk. Let new len desk be a copy of desk. Let new len be 32 desk. Let number len be to number desk. If same value 0, new len number len is false. Throw a range error exception. Set new len desk to new len. Let old len desk be ordinary get own property a length assert is data descriptor. Old len desk is true. Assert old len desk is false. 0. Let old len be old len desk. 1. If new len old len, then a return ordinary define known property a length new lendesk. 2. If old lendesk is false, return false. 3. If new lendesk does not have a field or new lendesk is true, then let new writable be true. 4. Else, a note. Setting the attribute to false is deferred in case any elements cannot be deleted. B. Let new writable be false. C. Set new lendesk to true. 5. Let succeeded be. Ordinary define known property A. Length. New lendesk. 6. If succeeded is false, return false. 7. For each shown property key P of a such that P is an array index and 32. P. New len. In descending numeric index order, do let delete succeeded be. A. P. B. If delete succeeded is false, then I set new lendesk to 32. P plus 1. 2. If new writable is false, set new lendesk to false. 3. Perform. Ordinary define known property A. Length. New lendesk. 5. Return false. 8. If new writable is false, then assert succeeded to. Ordinary define known property A. Length. Property descriptor false. B. Assert succeeded is true. 9. Return true. Note if original array was created using the standard built-in array conster out for a realm that is not the realm of the running execution context, then a new array is created using the realm of the running execution context. This maintains compatibility with web browsers that have historically had that behavior for the array prototype methods that now are defined using array species create. ECMA International 2024 189. Note, in steps 3 and 4, if desk is an object then its value of method is called twice. This is legacy behavior that was specified with this effect starting with the second edition of this specification. 0, 4, 3 string exotic objects. A string object is an exotic object that encapsulates a string value and exposes virtual integer index data properties corresponding to the individual code unit elements of the string value. String exotic objects always have a data property named length whose value is the length of the encapsulated string value. Both the code unit data properties and the length property are non-writable and non-configurable. An object is a string exotic object, or simply a string object, if its and internal methods use the following implementations, and its other essential internal methods use the definitions found in 10.1. These methods are installed in string create. String exotic objects have the same internal slots as ordinary objects. They also have an internal slot 1, 0, 4, 3, 1, P. The internal method of a string exotic object S takes argument P, a property key, and returns a normal completion containing either a property descriptor or undefined. It performs the following steps when called. Let desk be ordinary get own property S, P. If desk is not undefined, return desk. Return string get own property S, P. 0, 4, 3, 2, P. Desk. The internal method of a string exotic object S takes arguments P, a property key, and desk, a property descriptor, and returns a normal completion containing a boolean. It performs the following steps when called. Let string desk be string get own property S, P. If string desk is not undefined, then let extensible be S. P. Return is compatible property descriptor, extensible, desk, string desk. Return ordinary define known property S, P. Desk. 0, 4, 3, 3. The internal method of a string exotic object O takes no arguments and returns a normal completion containing a list of property keys. It performs the following steps when called. Let keys be a new empty list. Let str be O. Assert str is a string. Let len be the length of str for each integer I such that 0 I len. In ascending order, do a append to string I to keys for each shown property key P of O such that P is an array index and to an integer or infinity P len. In ascending numeric index order, do a append P to keys for each shown property key P of O such that P is a string and P is not an array index. In ascending chronological order of property creation, do a append P to keys. 90. ECMA International 2024 8. For each shown property key P of O such that P is a symbol, In ascending chronological order of property creation, do A append P to keys 9. Return keys 0, 4, 3, 4 string create, value, prototype. The abstract operation string create takes arguments value, a string, and prototype, an object, and returns a string exotic object. It is used to specify the creation of new string exotic objects. It performs the following steps when called. Let S be make basic object. Set S to prototype. Set S to value. Set S as specified in 1, 0, 4, 3, 1. Set S as specified in 1, 0, 4, 3, 2. Set S as specified in 1, 0, 4, 3, 3. Let length be the length of value. Perform. Define property or throw S, length, property descriptor, length, false, enumerable, false, false. Return S, 0, 4, 3, 5 string get own property, S, P. The abstract operation string get own property takes arguments S, an object that has an internal slot, and P, a property key, and returns a property descriptor or undefined. It performs the following steps when called. If P is not a string, return undefined. Let index be canonical numeric index string, P. If index is undefined, return undefined. If is integral number, int x, is false, return undefined. If index is -0, return undefined. Let str be s. Assert. Str is a string. Let len be the length of str. If r, int x, 0 or len r, int x, return undefined. 0. Let result str be the substring of str from r, int x, to r. Index plus 1, 1. Return the property descriptor. Result str. False. True, false. 0, 4. 4 arguments exotic objects. Most ECMA script functions make an arguments object available to their code. Depending upon the characteristics of the function definition, its arguments object is either an ordinary object or an arguments exotic object. An arguments exotic object is an exotic object whose array index properties map to the formal parameters bindings of an invocation of its associated ECMA script function. An object is an arguments exotic object if its internal methods use the following implementations, with the ones not specified here using those found in 10.1. These methods are installed and create mapped arguments object. Arguments exotic objects have the same internal slots as ordinary objects. They also have an internal slot. Ordinary arguments objects also have an internal slot whose value is always undefined. For ordinary argument objects, the internal SL but is only used by object prototype to string 2, 0, 1, 3, 6. To identify them as such. Note 1. While creating mapped arguments object is grouped into this clause, it creates an ordinary object, not an arguments exotic object. ECMA International 2024 191. Note 2. The integer index data properties of an arguments exotic object whose numeric name values are less than the number of formal parameters of the corresponding function object initially share their values with the corresponding argument bindings in their function's execution context. This means that changing the property changes the corresponding value of the argument binding and vice versa. This correspondence is broken if such a property is deleted and then redefined, or if the property is changed into an accessor property. If the arguments object is an ordinary object, the values of its properties are simply a copy of the arguments passed to the function, and there is no dynamic linkage between the property values and the formal parameter values. Note 3. The parameter map object and its property values are used as a device for specifying the arguments object correspondence to argument bindings. The parameter map object and the objects that are the values of its properties are not directly observable from ECMA script code. An ECMA script implementation does not need to actually create or use such objects to implement the specified semantics. Note 4. Ordinary arguments objects define a non-configurable accessor property named callee, which throws a type error exception on access. The callee property has a more specific meaning for arguments exotic objects, which are created only for some class of non-strict functions. The definition of this property in the ordinary variant exists to ensure that it is not defined in any other manner by conforming ECMA script implementations. Note 5 ECMA script implementations of arguments exotic objects have historically contained an accessor property named caller. Prior to ECMA script 2017, this specification included the definition of a throwing caller property on ordinary arguments objects. Since implementations do not contain this extension any longer, ECMA script 2017 dropped the requirement for a throwing caller accessor 0441P. The internal method of an argument's exotic object args takes argument P, a property key, and returns a normal completion containing either a property descriptor or undefined. It performs the following steps when called. Let desc be ordinary get own property, args P. If desc is undefined, return undefined. Let map be args, let is mapped be. Has own property, map P. If is mapped is true, then a set desc to get map P6. Return desc 0442P. Desc. The internal method of an argument's exotic object args takes arguments P, a property key, and desc, a property descriptor, and returns a normal completion containing a boolean. It performs the following steps when called. Let map be args, let is mapped be. Has own property, map P. Let new arg desc be desc. If is mapped is true and is data descriptor, desc is true. Then, if desc does not have a field, desc has a field, and desc is false, then I set new arg desc to a copy of desc 2. Set new arg desc to get map P. Let allowed be ordinary define own property args P. New arg desc 92 ECMA International 2024 6. If allowed is false, return false. If is mapped is true, then if is accessor descriptor desc is true, then I perform map P. Be else. If desc has a field, then assert. The following set will succeed. Since formal parameters mapped by arguments objects are always writable, perform set map P. Desc false 2. If desc has a field and desc is false, then perform map P8. Return true 0443. The let map be args, let is mapped be. Has own property, map P. If is mapped is false, then a return ordinary get args P. Receiver 4. Else a assert. Map contains a formal parameter mapping for P. P return get map P 0444. The if same value args receiver is false, then a let is mapped be false. Else a let map be args be let is mapped be. Has own property map P. If is mapped is true, then a assert. The following set will succeed. Since formal parameters mapped by arguments objects are always writable, B perform set map P V false return ordinary set args P V receiver 0445 P. The internal method of an argument's exotic object args takes argument P, a property key, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Let map be args, let is mapped be. Has own property, map P. Let result be ordinary delete args P. If result is true and is mapped is true, then a perform map P5. Return result ECMA International 2024 193 1044 6. Create and mapped arguments object arguments list. The abstract operation create and mapped arguments object tag S argument arguments list. A list of ECMA script language values and returns an ordinary object. It performs the following steps when called. Let len be the number of elements in arguments list. Let obj be ordinary object create %object prototype set obj to undefined. Perform define property or throw obj length property descriptor len true enumerable false true. Let index be 0. Repeat while int x len a let val be arguments list, index b perform, create data property or throw, obj, to string, int x, val, c set index to index plus 1 perform, define property or throw, obj, add at iterator, property descriptor, percent array prototype values percent, true, false, true perform, define property or throw, obj, callee, property descriptor, percent throw type error percent, false, false, return obj, 0, 4, 4, 7 create mapped arguments object, func, formals, arguments list, env. The abstract operation create mapped arguments object takes arguments func, an object, formals, a parse node, arguments list, a list of ECMA script language values, and env, an environment record, and returns an arguments exotic object. It performs the following steps when called. Assert. Formals does not contain a rest parameter, any binding patterns, or any initializers. It may contain duplicate identifiers. Let len be the number of elements in arguments list. Let obj be make basic object. Set obj as specified in 1 0, 4, 4, 1. Set obj as specified in 1 0, 4, 4, 2. Set obj, set obj, set obj as specified in 1 0, 4, 4, 5. Set obj to percent object prototype percent 0. Let map be ordinary object create, null, 1. Set obj to map, 2. Let parameter names be the bound names of formals, 3. Let number of parameters be the number of elements in parameter names, 4. Let index be 0, 5. Repeat. While int x, len, a let val be arguments list, index b perform, create data property or throw, obj, to string, int x, val, c set index to index plus 1, 6, perform, define property or throw, obj, length, property descriptor, len, true, false, true, 7. Let map names be a new empty list, 8. Set index to number of parameters 1, 9. Repeat. While index 0, 94. ECMA International 2024. A, B, C. Let name be parameter names. Index. If map names does not contain name, then I append name to map names. 2. If int x, len, then let g be make arg getter, name, env. Let p be make arg setter, name, env. Perform map. To string, int x, property descripto get, g, false, true, set index to index 1, 20. Perform. Define property or throw, obj, add at iterator, property descriptor, percent array prototype values percent, true, false, true, 1. Perform. Define property or throw, obj, callee, property descriptor, func, true, false, true, 2. Return obj, 0, 4, 4, 7, 1 make arg getter, name, env. The abstract operation make arg getter takes arguments name, a string, and env, an environment record, and returns a function object. It creates a built-in function object that when executed returns the value bound for name and env. It performs the following steps when called. Let getClosure be a new abstract closure with no parameters that captures name and env and performs the following steps when called. A return env get binding value, name, false. Let getter be create built-in function, getClosure, 0. Note, getter is never directly accessible to ECMA script code. Return getter, 0, 4, 4, 7, to make arg setter, name, env. The abstract operation make arg setter takes arguments name, a string, and env, an environment record, and returns a function object. It creates a built-in function object that when executed sets the value bound for name and env. It performs the following steps when called. Let setClosure be a new abstract closure with parameters, value, that captures name and env and performs the following steps when called. A return env set mutable binding, name, value, false. Let setter be create built-in function, setClosure, 1. Note, Setter is never directly accessible to ECMA script code. Return setter 0, 4, 5 typed array exotic objects. A typed array is an exotic object that performs special handling of integer index property keys. Typed arrays have the same internal slots as ordinary objects and additionally length and internal slots. An object is a typed array if its and internal methods use the definitions in this section, and its other essential internal methods use the definitions found in 10.1. These methods are installed by typed array create 0, 4, 5, 1. P. The internal method of a typed array O takes argument P, a property key, and returns a normal completion containing either a property descriptor or undefined. It performs the following steps when called. If P is a string, then a let numeric index be canonical numeric index string P be if numeric index is not undefined. Then I let value be typed array get element. Oh, numeric index 2. If value is undefined, return undefined. 3. Return the property descriptor value true enumerable true true. Return ordinary get own property O. P. ECMA International 2024 195 10 4 5 2. P. The internal method of a typed array O takes argument P, a property key, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. If P is a string, then a let numeric index be canonical numeric index string P be if numeric index is not undefined. Return as valid integer index O. Numeric index return. Ordinary has property O. P 0, 4, 5, 3. P. Desk. The internal method of a typed array O takes arguments P, a property key, and desk, a property descriptor, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. If P is a string, then a let numeric index be canonical numeric index string P be if numeric index is not undefined. Then if as valid integer index O. Numeric index is false, return false. 2. If desk has a field and desk is false, return false. 3. If desk has an field and desk is false, return false. 5. If as accessor descriptor desk is true, return false. V. If desk has a field and desk is false, return false. V. If desk has a field, perform typed array set element O. Numeric index desk 7. Return true. Return ordinary define known property O. P. Desk 0, 4, 5, 4. The. If P is a string, then a let numeric index be canonical numeric index string P be if numeric index is not undefined. Then I return typed array get element O. Numeric index 2. Return ordinary get O. P. Receiver 0, 4, 5, 5. The. If P is a string, then a let numeric index be canonical numeric index string P be if numeric index is not undefined. Then I have same value O. Receiver is true. Then perform typed array set element O. Numeric index V. Return true. 2. If as valid integer index O. Numeric index is false, return true. Return ordinary set O. P. V. Receiver 96. ECMA International 2024 10 4, 5, 6. P. The internal method of a typed array O takes argument P, a property key, and returns a normal completion containing a boolean. It performs the following steps when cal led. If P is a string, then a let numeric index be canonical numeric index string P be if numeric index is not undefined. Then if as valid integer index O. Numeric index is false, return true, else return false. 2. Return ordinary delete O. P 0, 4, 5, 7. The internal method of a typed array O takes no arguments and returns a normal completion containing a list of property keys. It performs the following steps when called. Let tar record be capital M A, K, E, capital T, Y, P, E, D, capital A, R, R, A, Y, capital W, I, T, H, capital B, U, F, F, E, R, capital W, I, T, N, E, S, O, sexy ST. Let keys be a new empty list. If this typed array out of bounds, tar record, is false, then a let length be typed array length, tar record be for each integer I such that 0 I, length, in ascending order, do I append to string I to keys for each own property key P of O such that P is a string and P is not an integer index. In ascending chronological order of property creation, do I append P to keys for each own property key P of O such that P is a symbol. In ascending chronological order of property creation, do I append P to keys 6. Return keys 0, 4, 5, 8 typed array with buffer witness records. And typed array with buffer witness record is a record value used to encapsulate a typed array along with a cached byte length of the viewed buffer. It is used to help ensure there is a single shared memory read event of the byte length data block when the viewed buffer is a growable shared array buffer. Typed array with buffer witness records have the fields listed in Table 32. Table 32. Typed array with buffer witness record fields 0, 4, 5, 9, capital M, A, K, E, capital T, Y, P, E, D, capital A, R, R, A, Y, capital W, I, T, H, capital B, U, F, F, E, R, capital W, I, T, N, E, S, OBJ, order. The abstract operation, capital M, A, K, E, capital T, Y, P, E, D, capital A, R, R, A, Y, capital W, I, T, H, capital B, U, F, F, E, R, capital W, I, T, N, E, S, takes arguments obj, a typed array, and order, sexy st or unordered, and returns a typed array with buffer witness record. It performs the following steps when called. Let buffer be obj. If is detached buffer, buffer, is true, then a let byte length be detached. Field name, value, meaning, object, a typed array, the typed array whose buffer's byte length is loaded. Cached buffer byte length, a non-negative integer or detached. The byte length of the objects when the record was created. Copyright sign, ECMA International 2024 197. 3. Else, a let byte length be array buffer byte length. Buffer, order, return the typed array with buffer witness record. OBJ, byte length, 0, 4, 5, 1, 0 typed array create. Prototype. The abstract operation typed array create takes argument prototype, an object, and returns a typed array. It is used to specify the creation of new typed arrays. It performs the following steps when called. Let internal slots list be. Let A be make basic object. Internal slots list. Set A is specified in 1, 0, 4, 5, 1. Set A is specified in 1, 0, 4, 5, 2. Set A is specified in 1, 0, 4, 5, 3. Set A is specified in 1, 0, 4, 5, 6. Set A is specified in 1, 0, 4, 5, 7, 0. Set A to prototype 1. Return A 0, 4, 5, 1, 1 typed array byte length. Tar record. The abstract operation typed array byte length takes argument tar record, a typed array with buffer witness record, and returns a non-negative integer. It performs the following steps when called. If this typed array out of bounds, tar record, is true, return 0. Let length be typed array length, tar record. If length equals 0, return 0. Let O be tar record. If O is not auto, return no. Let element size be typed array element size. O, return length element size. 0, 4, 5, 1, 2 typed array length. Tar record. The abstract operation typed array length takes argument tar record, a typed array with buffer witness record, and returns a non-negative integer. It performs the following steps when called. Assert. Is typed array out of bounds. Tar record. Is false. Let O be tar record. If O is not auto, return no. Assert. Is fixed length array buffer. O is false. Let byte offset be O. Let element size be typed array element size. O. Let byte length be tar record. Assert. Byte length is not detached. Return floor. Byte length. Byte offset. Element size. 0, 4, 5, 1, 3 is typed array, out of bounds. Tar record. The abstract operation is typed array, out of bounds takes argument tar record, a typed array with buffer witness record, and returns a boolean. It checks if any of the object's numeric properties reference a value at an index not contained within the underlying buffer's bounds. It performs the following steps when called. 2. Let O be tar record. Let buffer byte length be tar record. 98. ECMA International 2024. 3. Assert. Is detached buffer. O. Is true if and only if buffer byte length is detached. If buffer byte length is detached, return true. Let byte offset start be O. If O is auto, then a let byte offset end be buffer byte length. Else, a let element size be typed array element size. O, be let byte offset end be byte offset start plus O element size. If byte offset start, buffer byte length or byte offset end, buffer byte length, return true. Note: 0 length typed arrays are not considered out of bounds. 0, return false. 0, 4, 5, 1, 4 is valid integer index. O, index. The abstract operation is valid integer index takes arguments O, a typed array, and an x, a number, and returns a boolean. It performs the following steps when called. If is detached buffer, O, is true, return false. If is integral number, int x, is false, return false. If index is -0, return false. Let tar record be capital M, A, K, E, capital T, Y, P, E, D, capital A, R, R, A, Y, capital W, I, T, H, capital B, U, F, F, E, R, capital W, I, T, N, E, S, O, unordered. Note: bounds checking is not a synchronizing operation when O's backing buffer is a growable shared array buffer. If is typed array out of bounds, tar record. Is true, return false. Let length be typed array length. Tar record. If R, int x, 0 or R, int x, length, return false. Return true. 0, 4, 5, 1, 5 typed array get element. O, index. The abstract operation typed array get element takes arguments O, a typed array, and an x, a number, and returns a number, a big int, or undefined. It performs the following steps when called. let value be named evaluation of initializer with argument function object. Else, let RHS be evaluation of assignment expression. B, let value be get value RHS. Return completion record. Return value empty. Class static block body. Class static block statement list. Assert arguments list is empty. Return evaluate class static block body of class static block body with argument function object 0, 2, 1. For ordinary call evaluate body F arguments list. The abstract operation ordinary call evaluate body takes arguments F, an ECMA script function object, and arguments list, a list of ECMA script language values, and returns either a normal completion containing an ECMA script language value or an abrupt completion. It performs the following steps when called. Return evaluate body of F with arguments F and arguments list 1, 0, 2, 2. Arguments list. New target. The internal method of an ECMA script function object F takes arguments list, a list of ECMA script language values, and new target, a constructor, and returns either a normal completion containing an object or a throw completion. It performs the following steps when called. Let caller context be the running execution context. Let kind be F, if kind is base, then let this argument be ordinary create from constructor, new target, %object prototype %4. Let callee context be prepare for ordinary call. F, new target, 178, ECMA International 2024. Note even though field initializers constitute a function boundary, calling capital F, U, N, C, T, I, O, N, capital D, E, C, L, A, R, A, T, I, O, N, capital I, N, S, T, A, N, T, I, A, T, I, does not have any observable effect and so is omitted. 5. Assert. Callee context is now the running execution context. If kind is base, then a perform ordinary call bind this. F. Callee context. This argument, B, let initialize result be completion, initialize instance elements. This argument, F, see if initialize result is an abrupt completion, then I remove callee context from the execution context stack and restore caller context as the running execution context. 2. Return initialize result. Let constructor env be the lexical environment of callee context. Let result be completion, ordinary call evaluate body, F. Arguments list. Remove callee context from the execution context stack and restore caller context as the running execution context. 0. If result is a return completion, then if result is an object, return result. B, if kind is base, return this argument. C, if result is not undefined, throw a type error exception. 1. Else, a return if abrupt. Result. 2. Let this binding be constructor env get this binding. 3. Assert. This binding is an object. 4. Return this binding. 0, 2, 3. Ordinary function create. Function prototype. Source text. Parameter list. Body. This mode. env. Private env. The abstract operation ordinary function create takes arguments fun. Shine prototype. An object. Source text. A sequence of Unicode code points. Parameter list. A parse node. Body a parse node. This mode. Lexical this or non-lexical this. env. An environment record. And private env. A private environment record or null. And returns an ECMA script function object. It is used to specify the runtime creation of a new function with a default internal method and no internal method, although one may be subsequently added by an operation such as make constructor. Dart source text is the source text of the syntactic definition of the function to be created. It performs the following steps when called. Let internal slots list be the internal slots listed in table 30. Let F be ordinary object create. Function prototype. Internal slots list. Set F to the definition specified in 1, 0, 2, 1. Set F to source text. Set F to parameter list. Set F to body. If the source text matched by body is strict mode code, let strict be true, else let strict be false. Set F to strict. If this mode is lexical, set F to lexical 0, else if strict is true, set F to strict 1, else set F to global 2, set F to false 3, set F to env 4, set F to private env 5, set F to get active script or module 6, set F to the current realm record 7, set F to undefined 8, set F to a new empty list 9, set F to a new empty list 0, set F to empty 1. Let len be the expected argument counter parameter list 2. Perform set function length f len 3. Return f ECMA International 2024 179 10 2 4 capital A D D capital R E S T R I C T E D capital F U N C T I O N capital P R O P E R T I E F realm. The abstract operation capital A D D capital R E S T R I C T E D capital F U N C T I O N capital P R O P E R T I E takes arguments f, a function object, and realm, a realm record, and returns unused. It performs the following steps when called. Assert. Realm exists and has been initialized. Let thrower be realm. Perform. Define property or throw f. Caller. Property descriptor. Thrower. Enumerable. False. True. Perform. Define property or throw f. Arguments. Property descriptor. Thrower. Enumerable. False. True. Return unused. 0, 2, 4, 1% throw type error %. This function is the %throw type error % intrinsic object. It is an anonymous built-in function object that is defined once for each realm. It performs the following steps when called. Throw type error exception. The value of the internal slot of this function is false. The length property of this function has the attributes false, false, false. The name property of this function has the attributes false, false, false. 0, 2, 5 make constructor f. Writable prototype. Prototype. The abstract operation make constructor takes argument f, an ECMA script function object or a built-in function object, and optional arguments writable prototype, a boolean, and prototype, an object, and returns unused. It converts f into a constructor. It performs the following steps when called. If f is an ECMA script function object, then a assert is constructor, f is false, b assert. F is an extensible object that does not have a prototype own property. C set f to the definition specified in 10, 2, 2 else. A set f to the definition specified in 10, 3, 2. Set f to base. If writable prototype is not present, set writable prototype to true. If prototype is not present, then a set prototype to ordinary object create %object prototype %b perform. Define property or throw prototype constructor property descriptor f. Writable prototype false, true. Perform. Define property or throw f. Prototype property descriptor prototype writable prototype false, false. Return unused. 80 ECMA International 2024 10 2 6 make class constructor f. The abstract operation make class constructor takes argument f, an ECMA script function object, and returns unused. It performs the following steps when called. Assert. F is false. Set f to true. Return unused. 0, 2, 7 make method f. Home object. The abstract operation make method takes arguments f, an ECMA script function object, and home object, an object, and returns unused. It configures f as a method. It performs the following steps when called. Set f to home object. Return unused. 0, 2, 8. Define method property. Home object. Key. Closure. Enumerable. The abstract operation define method property takes arguments home object, an object, key, a property key or private name, closure, a function object, and enumerable, a boolean, and returns either a normal completion containing either a private element or unused, or an abrupt completion. It performs the following steps when called. Assert. Home object is an ordinary, extensible object. If key is a private name, then a return private element. Method. Closure 3. Else, a let desk be the property descriptor. Closure. True. Enumerable. True. Be perform. Define property or throw. Home object. Key. Desk. See note. Define property or throw only returns an abrupt completion when attempting to define a class. Static method whose key is prototype. Dret. An unused. 0, 2. 9. Set function name. F. Name. Prefix. The abstract operation set function name takes arguments f, a function object, a name, a property key or private name, and optional argument prefix, a string, and returns unused. It adds a name property to f. It performs the following steps when called. Assert. F is an extensible object that does not have a name-own property. If name is a symbol, then a let description be name's value. B if description is undefined. Set name to the empty string. See else. Set name to the string concatenation of description, and else if name is a private name. Then a set name to name. If f has an internal slot, then a set f to name. If prefix is present, then a set name to the string concatenation of prefix. The code unit 0 times 0020 space and name. B if f has an internal slot, then I optionally set f to name. Perform. Define property or throw f. Name. Property descriptor. Name. False. Enumerable. False. True. Return unused. ECMA International 2024 181. The 10th of February 2010. Set function length. F. Length. The abstract operation set function length takes arguments f, a function object, and length, a non-negative int, ger or plus, and returns unused. It adds a length property to f. It performs the following steps when called. Assert. F is an extensible object that does not have a length-own property. Perform. Define property or throw f. Length. Property descriptor. Length. False. Enumerable. False. True. Return unused. 0, 2, 1, 1. Capital F U N C T I O N. Capital D E C L A R A T I O N. Capital I N S T A N T I A T I. Func. Arguments list. The abstract operation. Capital F U N C T I O N. Capital D E C L A R A T I O N. Capital I N S T A N T I A T I. Takes arguments func, an ECMA script function object, and arguments list, a list of ECMA script language values, and returns either a normal completion containing unused or an abrupt completion. Func is the function object for which the execution context is being established. Note 1. When an execution context is established for evaluating an ECMA script function, a new function environment record is created and bindings for each formal parameter are instantiated in that environment record. Each declaration in the function body is also instantiated. If the function's formal parameters do not include any default value initializers, then the body declarations are instantiated in the same environment record as the parameters. If default value parameter initializers exist, a second environment record is created for the body declarations. Formal parameters and functions are initialized as part of capital F, U, N, C, T, I, O, N, capital D, E, C, L, A, R, A, T, I, O, N, capital I, N, S, T, A, N, T, I, A, T, I. All other bindings are initialized during evaluation of the function body. It performs the following steps when called. Let callee context be the running execution context. Let code be func, ECMA script code. Let strict be func. Let formals be func. Let parameter names be the bound names of formals. If parameter names has any duplicate entries, let has duplicates be true. Otherwise, let has duplicates be false. Let simple parameter list be a simple parameter list of formals. Let has parameter expressions be contains expression of formals. Let var names be the var declared names of code. 0. Let var declarations be the var scope declarations of code. 1. Let lexical names be the lexically declared names of code. 2. Let function names be a new empty list. 3. Let functions to initialize be a new empty list. 4. For each element D of var declarations, in reverse list order, do if D is neither a variable declaration nor a binding nor a binding identifier. Then, I assert, D is either a function declaration, a generator declaration, an async function declaration, or an async generator declaration. 2. Let fn be the sole element of the bound names of D. 3. If function names does not contain fn, then insert fn as the first element of function names. Note, if there are multiple function declarations for the same name, the last declaration is used. Insert D as the first element of functions to initialize. 5. Let arguments object needed be true. 6. If func is lexical, then a note arrow functions never have an arguments object. B set arguments object needed to false. 7. Else if parameter names contains arguments, then a set arguments object needed to false. 82. ECMA International 2024. 18. Else if his parameter expressions is false, then if function names contains arguments or lexical names contains arguments, then I set arguments object needed to false. 9. If strict is true or has parameter expressions is false, then a note only a single environment record is needed for the parameters. Since calls to eval in strict mode code cannot create new bindings which are visible outside of the eval, B let env be the lexical environment of callee context. 0. Else, a note, a separate environment record is needed to ensure that bindings created by direct eval calls in the formal parameter list are outside the environment where parameters are declared. B let callee env be the lexical environment of callee context. C let env be new declarative environment. Callee env. D assert. The variable environment of callee context is callee env. E set the lexical environment of callee context to env. 1. For each string param name of parameter names, do a let already declared benv has binding. Param name, B note. Early errors ensure that duplicate parameter names can only occur in non-strict functions that do not have parameter default values or rest parameters. See if already declared is false. Then, I perform env create mutable binding. Param name, false. 2. If his duplicates is true, then perform env initialize binding. Param name, undefined 22. If arguments object nay dead is true, then if strict is true or simple parameter list is false, then I let AOB create a mapped arguments object, arguments list. B else, I note, a mapped argument object is only provided for non-strict functions that don't have a rest parameter, any parameter default value initializers, or any destructured parameters. 2. Let AOB create mapped arguments object, func, formals, arguments list, env. See if strict is true, then I perform env create a mutable binding, arguments, false. 2. Note, in strict mode code, early errors prevent attempting to assign to this binding, so its mutability is not observable. D else, I perform env create mutable binding, arguments, false. Perform env initialize binding arguments. F let parameter bindings be the list concatenation of parameter names and arguments. 3. Else let parameter bindings be parameter names. 4. Let iterator record be create list iterator record arguments list. 5. If his duplicates is true, then perform iterator binding initialization of formals with arguments iterator record and undefined 26. Else perform iterator binding initialization of formals with arguments iterator record and env 27. If his parameter expressions is false, then a note. Only a single environment record is needed for the parameters and top-level vars. Let instantiated var names be a copy of the list parameter bindings. See for each element n of var names. Do if instantiated var names does not contain n, then append n to instantiated var names. Perform env create mutable binding. N false. Perform env initialize binding. N undefined. Let var env be env 28. Else a note. A separate environment record is needed to ensure that closures created by expressions in the formal parameter list do not have visibility of declarations in the function body. Let var env be new declarative environment. Env. C set the variable environment of callee context to var env. Let instantiated var names be a new empty list. For each element n of var names. Do if instantiated var names does not contain n, then ECMA International 2024 183 1. Append n to instantiated var names. Perform var env create mutable binding. N false. If parameter bindings does not contain n, or if function names contains n, then let initial value be undefined 4. Else let initial value be env get binding value. N false. Perform var env initialize binding. N initial value. Note: a var with the same name as a formal parameter initially has the same value as the corresponding initialized parameter. 9. Note: an xb 3 2 1 adds additional steps at this point. 0. If strict is false, then let lexenv be new declarative environment. Var env be note: non-strict functions use a separate environment record for top-level lexical declarations so that a direct eval can determine whether any var scope declarations introduced by the eval code conflict with pre-existing top-level lexically scoped declarations. This is not needed for strict functions because a strict direct eval always places all declarations into a new environment record. 1. Else let lexenv be var env. 2. Set the lexical environment of callee context to lexenv. 3. Let lex declarations be the lexically scoped declarations of code. 4. For each element d of lex declarations, do a note: a lexically declared name cannot be the same as a function-generated declaration, formal parameter, or a var name. Lexically declared names are only instantiated here but not initialized. B for each element dn of the bound names of d. Do if this constant declaration of d is true, then perform lexenv create a mutable binding. Dn true 2. Else perform lexenv create mutable binding. Dn false. 5. Let private env be the private environment of callee context. 6. For each parse node f of functions to initialize, do let fn be the sole element of the bound names of f. Let fo be instantiate function object of f with arguments lexenv and private env. C perform var env set mutable binding. Fn fo false. 7. Return unused. 0.3 Built-in function objects. A built-in function object is an ordinary object. It must satisfy the requirements for ordinary objects set out in 10.1. In addition to the internal slots required of every ordinary object, see 10.1. A built-in function object must also have the following internal slots: a realm record that represents the realm in which the function was created, a string that is the initial name of the function. It is used by 2, 0, 2, 3, 5. The initial value of a built-in function object's internal slot is %function prototype %, unless otherwise specified. A built-in function object must have an internal method that conforms to the definition in 1, 0, 3, 1. A built-in function object has an internal method if and only if it is described as a constructor. or some algorithm in this specification explicitly sets its internal method. Such an internal method must conform to the definition in 1.0.3.2. An implementation may provide additional built-in function objects that are not defined in this specification. Note 2b. 3.2 provides an extension to the above algorithm that is necessary for backwards compatibility with web browser implementations of ECMAScript that predate ECMAScript 2015. 84. Copyright sign, ECMA International 2024, 1.0.3.1. This arguments list. The internal method of a built-in function object f takes arguments this argument, an ECMAScript language value, and arguments list, a list of ECMAScript language values, and returns either a normal completion containing an ECMAScript language value or a throw completion. It performs the following steps when called. Return, built-in call or construct, f. This arguments list, undefined 1.0.3.2, arguments list, new target. The internal method of a built-in function object f, when the method is present, takes arguments list, a list of ECMAScript language values, and new target, a constructor, and returns either a normal completion containing an object or a throw completion. It performs the following steps when called. Return, built-in call or construct, f, uninitialized, arguments list, new target 1.0.3.3 built-in call or construct, f. This arguments list, new target. The abstract operation built-in call or construct takes arguments f, a built-in function object. This argument, an ECMAScript language value or uninitialized, arguments list, a list of ECMAScript language values, and new target. A constructor or undefined, and returns either a normal completion containing an ECMAScript language value or a throw completion. It performs the following steps when called. Let caller context be the running execution context. If caller context is not already suspended, suspend caller context. Let callee context be a new execution context. Set the function of callee context to f. Let callee realm be f. Set the realm of callee context to callee realm. Set the script or module of callee context to null. Perform any necessary implementation-defined initialization of callee context. Push callee context onto the execution context stack. Callee context is now the running execution context. 0. Let result be the completion record that is the result of evaluating f in a manner that conforms to the specification of f if this argument is uninitialized. This value is uninitialized. Otherwise, this argument provides the this value arguments list provides the named parameters new target provides the new target value. 1. Note, if f is defined in this document, the specification of f is the behavior specified for it via algorithm steps or other means. 2. Remove callee context from the execution context stack and restore caller context as the running execution context. 3. Return result 0, 3, 4. Create built-in function, behavior, length, name, additional internal slots list, realm, prototype, prefix. The abstract operation create built-in function takes arguments behavior, an abstract closure, a set of algorithm steps, or some other definition of a function's behavior provided in this specification, length, a non-negative integer or plus, name, a property key or a private name, and additional internal slots list, a list of names of internal slots, and optional arguments realm, a realm record, prototype, an object or null, and prefix, a string. And return to function object additional internal slots list contains the names of additional internal slots that must. Note when callee context is removed from the execution context stack it must not be destroyed if it has been suspended and retained by an accessible generator for later resumption. ECMA International 2024 185 be defined as part of the object. This operation creates a built-in function object. It performs the following steps when called. If realm is not present, set realm to the current realm record. If prototype is not present, Set prototype to realm. Let internal slots list be a list containing the names of all the internal slots that 10.3 requires for the built-in function object that is about to be created. Append to internal slots list the elements of additional internal slots list. Let fun be a new built-in function object that, when called, performs the action described by behavior, using the provided arguments as the values of the corresponding parameters specified by behavior. The new function object has internal slots whose names are the elements of internal slots list, and an internal slot. Set fun to prototype. Set fun to true. Set fun to realm. Set fun to null. 0. Perform set function length. Func. Length 1. If prefix is not present, then a perform set function name. Func. Name 12. Else a perform set function name. Func. Name. Prefix 13. Return func. Each built-in function defined in this specification is created by calling the create built-in function abstract operation. 0.4 Built-in exotic object internal methods and slots. This specification defines several kinds of built-in exotic objects. These objects generally behave similar to ordinary objects except for a few specific situations. The following exotic objects use the ordinary object internal methods except where it is explicitly specified otherwise below. 0. 4. 1 Bound function exotic objects. A bound function exotic object is an exotic object that wraps another function object. A bound function exotic object is callable. It has an internal method and may have an internal method. Calling a bound function exotic object generally results in a call of its wrapped function. An object is a bound function exotic object if its and, if applicable, internal methods use the following implementations, and its other essential internal methods use the definitions found in 10.1. These methods are installed in bound function create. Bound function exotic objects do not have the internal slots of ECMA script function objects listed in Table 30. Instead, they have the internal slots listed in Table 31, in addition to and Table 31, internal slots of bound function exotic objects. Internal slot. Type. Description. Bound target function. A callable object. The wrapped function object. Bound this. An ECMA script language value. The value that is always passed as this value when calling the wrapped function. Bound arguments. A list of ECMA script language values. A list of values whose elements are used as the first arguments to any call to the wrapped function. 186. ECMA International 2024. 104111. This argument. Argun. NTS list. The internal method of a bound function exotic object F takes arguments this argument, an ECMA script language value, and arguments list, a list of ECMA script language values, and returns either a normal completion containing an ECMA script language value or a throw completion. It performs the following steps when called. Let target be F, let bound this be F, let bound args be F, let args be the list concatenation of bound args and arguments list. Return. Call. Target. Bound this. Args 0, 4, 1, 2. Arguments list. New target. The internal method of a bound function exotic object F takes arguments list, a list of ECMA script language values, a new target, a constructor, and returns either a normal completion containing an object or a throw completion. It performs the following steps when called. Let target be F, assert, is constructor, target, is true. Let bound args be F. Let args be the list concatenation of bound args and arguments list. If same value, F, new target, is true. Set new target to target. Return. Construct. Target. Args. New target. 0, 4, 1. 3 Bound function create. Target function. Bound this. Bound args. The abstract operation bound function create takes arguments target function, a function object. Bound this. An ECMA script language value. And bound args. A list of ECMA script language values. And returns either a normal completion containing a function object or a throw completion. It is used to specify the creation of new bound function exotic objects. It performs the following steps when called. Let proto be target function. Let internal slots list be the list concatenation of and the internal slots listed in Table 31. Let obj be make basic object. Internal slots list. Set obj to proto. Set obj is described in 104111. If this constructor target function is true, then a set obj is described in 104112. Set obj to target function. Set obj to bound this. Set obj to bound args 0. Return obj 0 4 to array exotic objects. An array is an exotic object that gives special treatment to array index property keys C6 1 7. A property whose property name is an array index is also called an element. Every array has a non-configurable length property whose value is always a non-negative integral number whose mathematical value is strictly less than 32. The value of the length property is numerically greater than the name of every known property whose name is an array index, whenever a known property of an array is created or changed. Other properties are adjusted as necessary to maintain this invariant. Specifically, whenever a known property is added whose name is an array index, the value E of the length property is changed, if necessary, to be one more than the numeric value of that array index, and whenever the value of the length property is changed. Every own property whose name is an array index whose value is not smaller than the new length is deleted. This constraint applies only to own. ECMA International 2024-187. Properties of an array and is unaffected by length or array index properties that may be inherited from its prototypes. An object is an array exotic object, or simply, an array, if its internal method uses the following implementation, and its other essential internal methods use the definitions found in 10.1. These methods are installed in array create 0, 4, 2, 1, p, desc. The internal method of an array exotic object takes arguments p, a property key, and desc, a property descriptor, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. If p is length, then a return array set length a desc. Else if p is an array index, then a let length desc be ordinary get own property a length b assert is data descriptor length desc is true c assert length desc is false d let length be length desc e assert length is a non-negative integral number f let index b 32 p g if index length and length desc is false return false h let succeeded b ordinary define known property a p desc I have succeeded is false return false j if index length then I set length desc to index plus 1 2 set succeeded to ordinary define known property a length desc 3 assert succeeded is true k return true return ordinary define known property a p desc 0 4 2 to array create length proto. The abstract operation array create takes argument length, a non-negative integer, and optional argument proto an object, and returns either a normal completion containing an array exotic object or a throw completion. It is used to specify the creation of new arrays. It performs the following steps when called. If length 232 1, throw a range error exception. If proto is not present, set proto to %array prototype %. Let a be make basic object. Set a to proto. Set a is specified in 1 0 4 2 1. Perform ordinary define known property a length property descriptor length true false false return a 0 4 2 3 array species create original array length. The abstract operation array species create takes arguments original array, an object, and length, a non-negative integer, and returns either a normal completion containing an object or a throw completion. It is used to specify the creation of a new array or similar object using a constructor function that is derived from original array. It does not enforce that the constructor function returns an array. It performs the following steps when called. Let is array be is array original array. If this array is false, return array create length. Let c be get original array constructor. If this constructor C is true, then 88. ECMA International 2024. Let this realm be the current realm record. B let realm be. Get function realm. C. See if this realm and realm are not the same realm record. Then I have same value. C. Realm is true. Set C to undefined. If C is an object, then I set C to get C. Add at species. B if C is null, set C to undefined. If C is undefined, return array create length. If this constructor C is false, throw a type error exception. Return construct C length 0 4 2 4 array set length A desk. The abstract operation array set length takes arguments A, an array, and desk, a property descriptor, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. If desk does not have a field, then a return ordinary define known property A length desk. Let new len desk be a copy of desk. Let new len be 32 desk. Let number len be to number desk. If same value 0, new len number len is false. Throw a range error exception. Set new len desk to new len. Let old len desk be ordinary get own property A length. Assert is data descriptor. Old len desk is true. Assert old len desk is false. 0. Let old len be old len desk. 1. If new len old len, then a return ordinary define known property A length new len desk. 2. If old len desk is false, return false. 3. If new len desk does not have a field or new len desk is true, then a let new writable be true. 4. Else. A note. Setting the attribute to false is deferred in case any elements cannot be deleted. B let new writable be false. C set new len desk to true. 5. Let succeeded be ordinary define known property A length new len desk. 6. If succeeded is false, return false. 7. For each own property key P of a such that P is an array index and 32 P new len in descending numeric index order. Do a let delete succeeded B A P B if delete succeeded is false, then I set new len desk to 32 P plus 1 2. If new writable is false, set new len desk to false. 3. Perform ordinary define known property A length new len desk. 5. Return false. 8. If new writable is false, then assert succeeded to ordinary define known property A length property descriptor false. B assert succeeded is true. 9. Return true. Note if original array was created using the standard built-in array conster outer for a realm that is not the realm of the running execution context, then a new array is created using the realm of the running execution context. This maintains compatibility with web browsers that have historically had that behavior for the array prototype methods that now are defined using array species create. ECMA International 2024 189. Note, in steps 3 and 4, if desk is an object, then its value of method is called twice. This is legacy behavior that was specified with this effect starting with the second edition of this specification. 0, 4, 3 string exotic objects. A string object is an exotic object that encapsulates a string value and exposes virtual integer index data properties corresponding to the individual code unit elements of the string value. String exotic objects always have a data property named length whose value is the length of the encapsulated string value. Both the code unit data properties and the length property are non-writable and non-configurable. An object is a string exotic object, or simply a string object, if its and internal methods use the following implementations, and its other essential internal methods use the definitions found in 10.1. These methods are installed in string create. String exotic objects have the same internal slots as ordinary objects. They also have an internal slot 1 0, 4, 3, 1, P. The internal method of a string exotic object S takes argument P, a property key, and returns a normal completion containing either a property descriptor or undefined. It performs the following steps when called. Let desk be ordinary getOwn property S P. If desk is not undefined, return desk. Return string getOwn property S P 0 4 3 2 P desk. The internal method of a string exotic object S takes arguments P, a property key, and desk, a property descriptor, and returns a normal completion containing a boolean. It performs the following steps when called. Let string desk be string getOwn property S P. If string desk is not undefined, then a let extensible be S. P return is compatible property descriptor extensible desk string desk return ordinary define own property S P desk 0 4 3 3. The internal method of a string exotic object O takes no arguments and returns a normal completion containing a list of property keys. It performs the following steps when called. Let keys be a new empty list. Let strbo assert str is a string. Let len be the length of str for each integer I such that 0I len in ascending order. Do a append to string I to keys for each own property key p of O such that p is an array index and to an integer or infinity p len in ascending numeric index order. Do a append p to keys for each own property key p of O such that p is a string and p is not an array index in ascending chronological order of property creation. Do a append p to keys. 90. ECMA International 2024 8. For each own property key p of O such that p is a symbol in ascending chronological order of property creation. Do a append p to keys 9. Return keys 0 4 3 4 string create value prototype. The abstract operation string create takes arguments value, a string, and prototype, an object, and returns a string exotic object. It is used to specify the creation of new string exotic objects. It performs the following steps when called. Let S be make basic object. Set S to prototype. Set S to value. Set S as specified in 1 0 4 3 1. Set S as specified in 1 0 4 3 2. Set S as specified in 1 0 4 3 3. Let length be the length of value. Perform. Define property or throw S length. Property descriptor length. False enumerable. False. False. Return S 0 4 3 5 string getOwn property S P. The abstract operation string getOwn property takes arguments S, an object that has an internal slot, and P, a property key, and returns a property descriptor or undefined. It performs the following steps when called. If p is not a string, return undefined. Let index be canonical numeric index string p. If index is undefined, return undefined. If is integral number, int x, is false, return undefined. If index is -0, return undefined. Let strbs assert str is a string. Let len be the length of str. If r, int x, 0 or len r, int x, return undefined. 0. Let result str be the substring of str from r, int x, to r, index plus 1, 1. Return the property descriptor, result str, false, true, false, 0, 4. 4 arguments exotic objects. Most ECMA script functions make an arguments object available to their code. Depending upon the characteristics of the function definition, its arguments object is either an ordinary object or an arguments exotic object. An arguments exotic object is an exotic object whose array index properties map to the formal parameters bindings of an invocation of its associated ECMA script function. An object is an arguments exotic object if its internal methods use the following implementations, with the ones not specified here using those found in 10.1. These methods are installed and create mapped arguments object. Arguments exotic objects have the same internal slots as ordinary objects. They also have an internal slot. Ordinary arguments objects also have an internal slot whose value is always undefined. For ordinary argument objects, the internal SL but is only used by object prototype to string 201. 3, 6, to identify them as such. Note 1. While creating mapped arguments object is grouped into this clause, it creates an ordinary object, not an arguments exotic object. ECMA International 2024 191. Note 2. The integer index data properties of an arguments exotic object whose numeric name values are less than the number of formal parameters of the corresponding function object initially share their values with the corresponding argument bindings in their function's execution context. This means that changing the property changes the corresponding value of the argument binding and vice versa. This correspondence is broken if such a property is deleted and then redefined, or if the property is changed into an accessor property. If the argument's object is an ordinary object, the values of its properties are simply a copy of the arguments passed to the function, and there is no dynamic linkage between the property values and the formal parameter values. Note 3. The parameter map object and its property values are used as a device for specifying the argument's object correspondence to argument bindings. The parameter map object and the objects that are the values of its properties are not directly observable from ECMA script code. An ECMA script implementation does not need to actually create or use such objects to implement the specified semantics. Note 4. Ordinary arguments objects define a non-configurable accessor property named callee, which throws a type error exception on access. The callee property has a more specific meaning for arguments exotic objects, which are created only for some class of non-strict functions. The definition of this property in the ordinary variant exists to ensure that it is not defined in any other manner by conforming ECMA script implementations. Note 5. ECMA script implementations of arguments exotic objects have historically contained an accessor property named caller. Prior to ECMA script 2017, this specification included the definition of a throwing caller property on ordinary arguments objects. Since implementations do not contain this extension any longer, ECMA script 2017 dropped the requirement for a throwing caller accessor. 0.441p. The internal method of an argument's exotic object args takes argument p, a property key, and returns a normal completion containing either a property descriptor or undefined. It performs the following steps when called. Let desk be ordinary get own property, args p. If desk is undefined, return undefined. Let map be args. Let is mapped be has own property, map p. If is mapped is true, then a set desk to get map p6. Return desk 0.442p. Desk. The internal method of an argument's exotic object args takes arguments p, a property key, and desk, a property descriptor, and returns a normal completion containing a boolean. It performs the following steps when called. Let map be args. Let is mapped be has own property, map p. Let new arg desk be desk. If is mapped is true and is data descriptor, desk, is true, then if desk does not have a field, desk has a field, and desk is false, then I set new arg desk to a copy of desk 2. Set new arg desk to get map p. Let allowed be ordinary define own property, args p. New arg desk 92. ECMA International 2024 6. If allowed is false, return false. If is mapped is true, then if is accessor descriptor, desk, is true, then I perform map p. Be else if desk has a field, then assert the following set will succeed. Since formal parameters mapped by arguments objects are always writable, perform set map p. Desk false 2. If desk has a field and desk is false, then perform map p8. Return true 0.443. The let map be args. Let is mapped be has own property, map p. If is mapped is false, then a return ordinary get args p. Receiver 4. Else a assert map contains a formal parameter mapping for p. P return get map p. 0.444. The if same value args receiver is false, then a let is mapped be false. Else a let map be args b. Let is mapped be has own property, map p. P. If is mapped is true, then A assert. The following set will succeed. Since formal parameters mapped by arguments objects are always writable. B perform. Set. Map. P. V. False. Return. Ordinary set. Args. P. V. Receiver 0, 4, 4, 5. P. The internal method of an argument's exotic object args takes argument P, a property key, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Let map be args. Let is mapped be. Has own property. Map. P. Let result be. Ordinary delete. Args. P. If result is true and is mapped is true, then a perform map. P5. Return result. ECMA International 2024 193 10 4 4 6. Create and mapped arguments object arguments list. The abstract operation create and mapped arguments object tag S arguments list. A list of ECMA script language values and returns an ordinary object. It performs the following steps when called. Let len be the number of elements in arguments list. Let obj be ordinary object create. Object prototype set obj to undefined. Perform. Define property or throw. Obj. Length. Property descriptor. Len. True. Enumerable. False. True. Let index be 0. Repeat. While index. Len. Let val be arguments list. Index. Be perform. Create data property or throw. Obj. To string. Index. Val. C set index to index plus 1. Perform. Define property or throw. Obj. Add at iterator. Property descriptor. Array prototype values true. False. True. Perform. Define property or throw. Obj. Callee. Property descriptor. Throw type error false. False. Return obj 0, 4, 4, 7. Create mapped arguments object func formals arguments list env. The abstract operation create mapped arguments object takes arguments func an object as node arguments list a list of EC.
Everyone's asking, like, AI,
Record.
2 plus 2 equals fish, or some shit.
The following steps when called.
AI is not artificial intelligence.
Binding patterns, or any initialized.
Whoever is, like, asking it to code, and it's actually writing your code, and, like, you get actual code from chatbot that works.
1, 0, 4, 4.
I don't know. That speaks for itself.
4, 4.
Chatbot can't do shit.
J. Set obj as specified. Names 4. Let index be 0, 5. Repeat. While index len let val be arguments list. Index.
And this cheater stuff, it's really dumb.
Obj.
It's just annoying.
Val C set index to index plus 1, 6. Perform. Define property or throw. Obj. Length. Property descriptor. Len. True. False. True. 7. Let map names be a new empty list.
Like triangles.
Number of parameters 1, 9.
I freaking have these people.
4. ECMA.
They got a fetish for triangles.
C. Let name be parameter names. Index.
It literally has to be turning someone on.
I append name to map names 2.
What the hell?
Then let G be make arg getter.
Is with triangles.
Let P be make arg setter. Name. env. Perform map. To string. Int x. Property descripto. Get. G. False. True. Set index to index 1, 20. Perform. Define property.
I simply
J. Add iterator. Property descriptor.
want to put the desktop,
Use percent.
capture it, send to the video card.
True. 1.
and pixelate it.
Define property or throw obj callie.
But I can't just, like, do a square in a shader.
True 2. Return obj 0 4 4 7.
No, instead,
Name env. The abstract operation make arg getter takes argument.
you have to make a triangle.
dnv an environment record and returns a function object. It creates a built-in function object.
So you can either make one large triangle,
It performs the following steps when called. Let getterClosure be a new abstract closure with no parameters that captures name and dnv and performs the following steps when called.
and then you, like, position the square inside of it.
False. Let getter be create built-in function getterClosure 0. Note, getter is never directly
Or
code. Return getter 0 4 4 7 to make arg setter name
you make, like, two triangles,
and make arg setter takes arguments
and you cut the image into two triangles, because you can't make a square.
and returns a function object. It creates a built-in function object that when executed sets the value bound for name and env. It performs the following steps when called. Let setterClosure be a new abstract closure with parameters value that captures name and dnv and performs the following steps when called. A return env set mutable binding name value false. Let setter be create built-in function setterClosure 1. Note, setter is never directly accessible to ECMA script code. Return setter 0 4 5 typed array exotic objects. A typed array is an exotic
What even?
index property keys. Typed arrays have the same internal slots as ordinary objects.
Literally, someone has a fetish with triangles.
Array fits
To enforce triangles
in this section.
and every geometric shape,
Methods use
saying you don't need any other shapes
these
because we got triangles.
8 0
It's fucking idiotic.
p. The internal method of a typed array O takes argument p. A property
It's like saying
and a normal completion.
you don't need primary colors.
The script are all undefined. It performs the following steps when called. If p is a string, then a let numeric index be canonical numeric index string p be if numeric index is not undefined. Then I let value be typed array get element. Oh, numeric index 2. If value is
Got green, is that purple or blue? I'll just go with blue. Green, blue, red.
true, enumerable, true, true, return ordinary get own property. O. P. ECMA International 2024 195 10 4 5 2. P. The internal method of a typed array O takes argument p, a property key, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. If p is a string, then a let numeric index be canonical numeric index string p be if numeric index is not
It's like saying
valid integer index.
you don't need primary colors
Return
to make colors.
p. O.
All you need
4 5 3.
is
Desk. The internal method of a typed array O takes arguments p, a property key, and desk, a property descriptor, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. If p is a string, then a let numeric index be canonical numeric index string p be if numeric index is not undefined. Then if is valid integer index. O. Numeric index is false. Return false 2. If desk has a field and desk is false, return
I don't know. All you need is, well, that's kind of like blue.
return false. If is access a descriptor, desk is true, return false. V. If desk has a field and desk is false, return false. V.
All you need is purple.
Perform
It's like saying you don't need a monitor with red, green, blue.
desk
All you need is a monitor with purple.
ordinary define known property
And purple
p
can be any color. Purple can be green. It can be blue, and it can be red.
canonical numeric index string p.
So it's like you don't need squares
Then
or circles.
Get element.
You just need triangles.
Return.
You can make a circle out of triangles.
Receiver 0, 4, 5, 5. If P is a string, then let numeric index be canonical numeric index string P be if numeric index is not undefined. Then if same value O receiver is true, then perform typed array set element O numeric index V return true 2. If is valid integer index O numeric index is false, return true. Return ordinary set O P V receiver 96 ECMA International 2024 10456 P. The internal method of a typed array O takes argument P, a property key, and returns a normal completion containing a boolean. It performs the following steps when cal led. If P is a string, then let numeric index be canonical numeric index string P be if numeric index is not undefined. Then if is valid integer index O numeric index is false, return true, else return false 2. Return ordinary delete O P 0 4 5 7. The internal method of a typed array O takes no arguments and returns a normal completion containing a list of property keys. It performs the following steps when called. Let tar record be capital M A K E.
So it's like saying
Y P E D capital A R R A Y capital W I T.
you don't need red, green, blue.
Capital B
You don't need red, green, blue.
F E
You don't need square, triangle, circle.
U I
The only shape you need is triangle.
S O sexiest T. Let keys be a new empty list. If it's typed array out of bounds, tar record is false. Then let length be typed array length. Tar record be free.
Because you can make everything with triangles.
In ascending order.
You can make a circle.
To string I to keys. For each shown property key P of O such that P is a string and P is not an integer index. In ascending chronological order of property creation, do A append P to keys. For each shown property key P of O such that P is a symbol. In ascending chronological order of property.
Oh look, it's a fucking circle.
6
Or you could also do it like this.
0 4 5 8. Typed array with buffer witness records. And typed array with buffer witness record is a record value used to encapsulate a typed array along with a cached byte length of the viewed buffer.
Oh my god, it's another circle.
Single
Or you can make a circle like this.
to block when the viewed buffer is a growable shared array buffer. Typed array with buffer witness records have the fields listed in Table 32. Table 32. Typed array with buffer witness record fields 0, 4, 5, 9. Capital M A
Oh my god, that's a circle too.
E
Holy crap, you can make anything with triangles.
A R
This is so fucking dumb.
Y
Holy fuck.
I T H capital B
This is idiotic.
F F
This is the stupidest shit ever.
W I
Someone that designed
S
the whole video card thing,
the
they got a fetish with triangles.
A K E
It's not acceptable.
I P E D capital A R R A Y capital W I T H capital B U F F E R capital W I T N E S takes arguments obj, a typed array, and order,
This is some annoying crap.
and returns a typed array with buffer witness record. It performs the following steps when called. Let buffer be obj. If is detached buffer is true, then a let byte length be detached. Field name, value, meaning, object, a typed array, the typed array whose buffer's byte length is loaded. Cached buffer byte length, a non-negative integer or detached, the byte length of the objects when the record was created. Copyright sign, ECMA International 2024 197. 3. Else, a let byte length be array buffer byte length. Buffer, order, return the typed array with buffer witness record. OBJ, byte length, 0, 4, 5, 1, 0 typed array create. Prototype, the abstract operation typed array create takes argument prototype, an object, and returns a typed array. It is used to specify the creation of new typed arrays. It performs the following steps when called. Let internal slots list be. Let A be make basic object. Internal slots list. Set A is specified in 1, 0, 4, 5, 1. Set A is specified in 1, 0, 4, 5, 2. Set A is specified in 1, 0, 4, 5, 3. Set A. Set A. Set A is specified in 1, 0, 4, 5, 6. Set A is specified in 1, 0, 4, 5, 7, 0. Set A to prototype 1. Return A 0, 4, 5, 1, 1 typed array byte length. Tar record. The abstract operation typed array byte length takes argument tar record, a typed array with buffer witness record, and returns a non-negative integer. It performs the following steps when called. If this typed array out of bounds tar record is true, return 0. Let length be typed array length tar record. If length equals 0, return 0. Let O be tar record. If O is not auto, return O. Let element size be typed array element size. O. Return length element size 0, 4, 5, 1, 2 typed array length tar record. The abstract operation typed array length takes argument tar record, a typed array with buffer witness record.
This triangle stuff is so dumb.
Forms the following steps.
It's like team triangle
Bounds.
or team not triangle.
Be tar record. If
It's so annoying.
return no. Assert. Is fixed length array
As chatbot.
is false. Let byte offset be O. Let element size be typed array element size.
How do I make a shader and not use triangles?
Byte length is not detached.
Let's see what chatbot says.
Byte length. Byte offset. Element size 0, 4, 5, 1, 3 is typed array out of bounds. Tar record. The abstract operation is typed array out of bounds takes argument tar record, a typed array with buffer witness record, and returns a boolean. It checks if any of the object's numeric properties reference a value at an index not contained within the underlying buffer's bounds. It performs the following steps when called. 2. Let O be tar record. Let buffer byte length be tar record. 98.
This is ridiculous.
100 plus JavaScript concept. How do I make a GPU shader and not use triangles? I need a rectangle, not two triangles that look like a triangle. If you're trying to render a rectangle using a GPU shader, like an OpenGL, WebGL, or similar, and you don't want to use two triangles, there are a few options, but they depend on why you want to avoid triangles. Spanner, reality check GPUs are designed to rasterize triangles. Even rectangles, quads, are usually broken down into triangles under the hood, because triangles are always planar. The interpolation math is simpler and faster, or modern GPU pipelines assume triangles. So if your goal is just to render a full-screen rectangle, for post-processing, procedural generation, etc., and you don't want to explicitly define two triangles, you still end up with triangles, but you can hide or avoid manually dealing with them.
This is so stupid. Holy fuck. This is literally idiotic. What the fuck?
And you don't want to explicitly define two triangles, you still end up with triangles, but you can hide or avoid manually dealing with them.
It's the stupidest thing ever. This is so dumb. I want to cry. It's so stupid. Reality check.
Reality check. GP user designed to rasterize triangles.
Like
Reality check.
I'm gonna go through the JavaScript standard. 15th edition. Page 1 to 816. And I should stop after that. That's all I'm gonna say for now. It's gonna be a reality check. This is so dumb.
Tick common approaches 1. Use a full screen triangle, single triangle trick. Instead of using 2 triangles for a quad, use one oversized triangle that covers the screen.
Yeah, the single triangle trick. Instead of just using a square, just trick it. Use a big ass triangle. Because why would you need a square or a rectangle when you got triangles? This is so dumb.
Red square. You cannot escape triangles if you're using the raster pipeline. Even quads get broken into triangles.
Oh, it's so dumb.
Or a throw completion. It attempts to change the bound value of the current binding of the identifier whose name is enter the value.
I gotta get stuff working. This is so stupid.
Cases it may not.
Fucking triangles. Holy crap.
Thrown if S is true. It performs the following steps when called. If envrec does not have a binding for n, then
Hey chatbot, it can't make valid code.
exception. B perform envrec create
This whole thing is really frustrating.
C perform
I just want to be done.
binding n v d return unused. If the binding for n and envrec is a strict binding, set S to true. If the binding for n and envrec has not yet been initialized, then A throw a reference error exception. Else if the binding for n and envrec is a mutable binding, then A change its bound value to V. Else A assert. This is an attempt to change the value of an immutable binding. B if S is true. Throw a type error exception. Return unused. Note an example of ECMA script code that results in a missing binding at step 1 is function f eval var x equals delete x 0 ECMA International 2024 137 9 1 1 1 6 get binding value n s. The get binding value concrete method of a declarative environment record envrec takes arguments n, a string, and s, a boolean, and returns either a normal completion containing an ECMA script language value or a throw completion. It returns the value of its bound identifier whose name is n if the binding exists but is uninitialized. A reference error is thrown. Regardless of the value of s, it performs the following steps when called. Assert. envrec has a binding for n. If the binding for n and envrec is an uninitialized binding, throw a reference error exception. Return the value currently bound to n and envrec, 1 1 1 7 delete binding n. The delete binding concrete method of a declarative environment record envrec takes argument n, a string, and returns a normal completion containing a boolean. It can only delete bindings that have been explicitly designated as being subject to deletion. It performs the following steps when called. Assert. envrec has a binding for n. If the binding for n and envrec cannot be deleted, return false. Remove the binding for n from envrec. Return true, 1 1 1 8 has this binding. The has this binding concrete method of a declarative environment record envrec takes no arguments and returns false. It performs the following steps when called. Return false, 1, 1, 1. 9 has superbinding. The has superbinding concrete method of a declarative environment record envrec takes no arguments and returns false. It performs the following steps when called. Return false, 1, 1, 1, 10 with base object. The with base object concrete method of a declarative environment record envrec takes no arguments and returns undefined. It performs the following steps when called. Return undefined, 1, 1, 2 object environment records. Each object in the environment record is associated with an object called its binding object. An object environment record binds the set of string identifier names that directly correspond to the property names of its binding object. Property keys that are not strings in the form of an identifier name are not included in the set of bound identifiers. Both own and inherited properties are included in the set regardless of the setting of their attribute. Note a regular declarative environment record. That is, one that is neither a function environment record nor a module environment record. Does not provide this binding. Note a regular declarative environment record. That is, one that is neither a function environment record nor a module environment record. Does not provide a super binding. 38. Copyright sign, ECMA International 2024. Because properties can be dynamically added and deleted from objects, the set of identifiers bound by an object environment record may potentially change as a side effect of any operation that adds or deletes properties. Any bindings that are created as a result of such a side effect are considered to be a mutable binding, even if the writable attribute of the corresponding property is false. Immutable bindings do not exist for object environment records. Object environment records created for with statements 14.11 can provide their binding object as an implicit this value for use in function calls. The capability is controlled by a Boolean field. Object environment records have the additional state fields listed in Table 17. Table 17, additional fields of object environment records. The behavior of the concrete specification methods for object environment records is defined by the following algorithms, 1, 1, 2, 1 has binding, n. The has binding concrete method of an object environment record envrec takes argument n, a string, and returns either a normal completion containing a Boolean or a throw completion. It determines if its associated binding object has a property whose name is n. It performs the following steps when called. Let binding object be envrec. Let found binding be. Has property binding object n. If found binding is false, return false. If the envrec is false, return true. Let unscopables be. Get binding object. Add at unscopables. If unscopables is an object, then a let block be to Boolean. Get unscopables n. Be if blocked is true, return false. Return true, 1, 1, 2. To create mutable binding n. D. The create mutable binding concrete method of an object environment record envrec takes arguments n, a string, and e, a Boolean, and returns either a normal completion containing unused or a throw completion. It creates in an environment records associated binding object a property whose name is n and initializes it to the value undefined. If d is true, the new property's attribute is set to true, otherwise it is set to false. It performs the following steps when called. Let binding object be envrec. Perform. Define property or throw binding object n. Property descriptor undefined. True, true. D. Return unused. Field name, value, meaning, binding object. An object. The binding object of this environment record is with environment. A Boolean indicates whether this environment record is created for a with statement. Note normally envrec will not have a binding for n, but if it does, the semantics of defined property or throw may result in an existing binding being replaced or shadowed or cause an abrupt completion to be returned. ECMA International 2024 139 9 1 1 2 3 Create a mutable binding n. S. The create a mutable binding concrete method of an object environment record is never used within this specification, 1 1 2 4 Initialize binding n. V. The initialize binding concrete method of an object environment record envrec takes arguments n, a string, and v, an ECMA script language value, and returns either a normal completion containing unused or a throw completion. It is used to set the bound value of the current binding of the identifier whose name is n to the value v. It performs the following steps when called. Perform envrec set mutable binding n, v, false, return unused, 1, 1, 2, 5 set mutable binding n, v, s. The set mutable binding concrete method of an object environment record envrec takes arguments n, a string, v, an ECMA script language value, and s, a boolean, and returns either a normal completion containing unused or a throw completion. It attempts to set the value of the environment record's associated binding object's property whose name is n to the value v. A property named n normally already exists, but if it does not or is not currently writable. Error handling is determined by s. It performs the following steps when called. Let binding object be envrec. Let still exist as b. Has property binding object n. If still exists as false and s is true, throw a reference error exception. Perform set binding object n, v, s. Return unused, 1, 1, 2, 6 get binding value n, s. The get binding value concrete method of an object environment record envrec takes arguments n, a string, and s, a boolean, and returns either a normal completion containing an ECMA script language value or a throw completion. It returns the value of its associated binding object's property whose name is n. The property should already exist, but if it does not, the result depends upon s. It performs the following steps when called. Let binding object be envrec. Let value be. Has property binding object n. If a value is false, then if s is false, return undefined. Otherwise throw a reference error exception for return get binding object n, 1, 1, 2, 7 delete binding n. The delete binding concrete met hod of an object environment record envrec takes argument n, a string, and returns either a normal completion containing a boolean or a throw completion. It can only delete bindings that correspond to properties of the environment object whose attribute have the value true. It performs the following steps when called. Note in this specification, all uses of create mutable binding for object environment records are immediately followed by a call to initialize binding for the same name. Hence, this specification does not explicitly track the initialization state of bindings in object environment records. 2. Let binding object be envrec. Return binding object n, 40, ECMA International 2024, 9, 1, 1, 2, 8 has this binding. The has this binding concrete method of an object environment record envrec takes no arguments and returns false. It performs the following steps when called. Return false, 1, 1, 2, 9 has super binding. The has super binding concrete method of an object environment record envrec takes no arguments and returns false. It performs the following steps when called. Return false, 1, 1, 2, 1, 0 with base object. The with base object concrete method of an object environment record envrec takes no arguments and returns an object or undefined. It performs the following steps when called. If envrec is true, return envrec. Otherwise, return undefined, 1, 1, 3 function environment records. A function environment record is a declarative environment record that is used to represent the top-level scope of a function and, if the function is not an arrow function, provides a this binding. If a function is not an arrow function and references super, its function environment record also contains the state that is used to perform super method invocations from within the function. Function environment records have the additional state fields listed in Table 18. Table 18. Additional fields of function environment records. Note: object environment records do not provide a this binding. Note: object environment records do not provide a super binding. Field name: value, meaning this value, an ECMA script language value. This is the this value used for this invocation of the function. This binding status: lexical, initialized, or uninitialized. If the value is lexical, This is an arrow function and does not have a local this value. Function object. An ECMA script. Function object. The function object whose invocation caused this environment record to be created. New target. An object or undefined. If this environment record was created by the internal method, is the value of the new target parameter. Otherwise, its value is undefined. Copyright sign, ECMA International 2024. 41. Function environment records support all of the declarative environment record methods listed in table 16 and share the same specifications for all of those methods except for has this binding and has super binding. In addition, function environment records support the methods listed in table 19. Table 19. Additional methods of function environment records. Method. Purpose. Bind this value. V. Set the end record that it has been initialized. Get this binding. Return the value of this environment records this binding. Throws a reference error if this binding has not been initialized. Get superbase. Return the object that is the base for super property accesses bound in this environment record. The value undefined indicates that such accesses will produce runtime errors. The behavior of the additional concrete specification methods for function environment records is defined by the following algorithms, 1, 1, 3, 1 bind this value, v. The bind this value concrete method of a function environment record envrec takes argument v, an ECMA script language value, and returns either a normal completion containing an ECMA script language value or a throw completion. It performs the following steps when called. Assert. envrec is not lexical. If envrec is initialized, throw a reference error exception. Set envrec to v. Set envrec to initialized. Return v, 1, 1, 3, 2 has this binding. The has this binding concrete method of a function environment record envrec takes no arguments and returns a boolean. It performs the following steps when called. If envrec is lexical, return false. Otherwise, return true. 9, 1, 1, 3. 3 has super binding. The has super binding concrete method of a function environment record envrec takes no arguments and returns a boolean. It performs the following steps when called. If envrec is lexical, return false. If envrec is undefined, return false. Otherwise, return true, 1, 1, 3. Forget this binding. The get this binding concrete method of a function environment record envrec takes no arguments and returns either a normal completion containing an ECMA script language value or a throw completion. It performs the following steps when called. Assert. envrec is not lexical. If envrec is uninitialized, throw a reference error exception. Return envrec. 42. ECMA International 2024. 9, 1, 1, 3, 5 get superbase. The get superbase concrete method of a function environment record envrec takes no arguments and returns either a normal completion containing either an object, null, or undefined, or a throw completion. It performs the following steps when called. Let home be envrec. If home is undefined, return undefined. Assert. Home is an object. Return home, 1, 1, 4 global environment records. A global environment record is used to represent the outermost scope that is shared by all of the ECMA script elements that are processed in a common realm. A global environment record provides the bindings for built-in globals, clause 19, properties of the global object, and for all top-level declarations, 8, 2, 9, the 8th of February 2011, that occur within a script. A global environment record is logically a single record, but it is specified as a composite encapsulating an object environment record and a declarative environment record. The object environment record has as its base object the global object of the associated realm record. This global object is the value returned by the global environment records get this binding concrete method. The object environment record component of a global environment record contains the bindings for all built-in globals, clause 19, and all bindings introduced by a function declaration, generator declaration, async function declaration, async generator declaration, or variable statement contained in global code. The bindings for all other ECMA script declarations in global code are contained in the declarative environment record component of the global environment record. Properties may be created directly on a global object. Hence, the object environment record component of a global environment record may contain both bindings created explicitly by function declaration, generator declaration, async function declaration, async generator declaration, or variable declaration declarations and bindings created implicitly as properties of the global object. In order to identify which bindings were explicitly created using declarations, a global environment record maintains a list of the names bound using its create global var binding and create global function binding concrete methods. Global environment records have the additional fields listed in Table 20 and the additional methods listed in Table 21. Table 20. Additional fields of global environment records. Field name, value, meaning, object record, and object environment record. Binding object is the global object. It contains global built-in bindings as well as function declaration, generator declaration, async function declaration, async generator declaration, and variable declaration bindings in global code for the associated realm. Global this value, an object, the value returned by this in global scope. Hosts may provide any ECMA script object value. Declarative record. A declarative environment record contains bindings for all declarations in global code for the associated realm code except for function declaration, generator declaration, async function declaration, async generator declaration, and variable declaration bindings. Var names, a list of strings. The string names bound by function declaration, generator declaration, async function declaration, async generator declaration, and variable declaration declarations in global code for the associated realm. Copyright sign, ECMA International 2024. 43. Table 21. Additional methods of global environment records. Method. Purpose. Get this binding. Return the value of this environment records. This binding has var declaration. N. Determines if the argument identifier has a binding in this environment record that was created using a variable declaration, function declaration, generator declaration, async function declaration, or async generator declaration, has lexical declaration. N. Determines if the argument identifier has a binding in this environment record that was created using a lexical declaration such as a lexical declaration or a class declaration, has restricted global property. N. Determines if the argument is the name of a global object property that may not be shadowed by a global lexical binding, can declare global var. N. Determines if a corresponding create global var binding call would succeed if called for the same argument. N. Can declare global function. N. Determines if a corresponding create global function binding call would succeed if called for the same argument. N. Create global var binding. N. D. Used to create and initialize to undefined a global var binding in the component of a global environment record. The binding will be a mutable binding. The corresponding global object property will have attribute values appropriate for a var. The string value n is the bound name. If D is true, the binding may be deleted. Logically equivalent to create mutable binding followed by a set mutable binding, but it allows var declarations to receive special treatment. Create global function binding. N. V. D. Create and initialize a global function binding in the component of a global environment record. The binding will be a mutable binding. The corresponding global object property will have attribute values appropriate for a function. The string value n is the bound name. V is the initialization value. If the Boolean argument D is true, the binding may be deleted. Logically equivalent to create mutable binding followed by a set mutable binding, but it allows function declarations to receive special treatment. The behavior of the concrete specification methods for global environment records is defined by the following algorithms. 1, 1, 4, 1 has binding. N. The has binding concrete method of a global environment record. The NVREC takes argument n, a string, and returns either a normal completion containing a Boolean or a throw completion. It determines if the argument identifier is one of the identifiers bound by the record. It performs the following steps when called. Let DCLREC be NVREC. If DCLREC has binding n is true, return true. Let OBJREC be NVREC. Return OBJREC has binding n, 1, 1, 4. To create mutable binding. N. D. The create create mutable binding concrete method of a global environment. Record envrec takes arguments n, a string, and e, a boolean, and returns either a normal completion containing unused or a throw completion. It creates a new mutable binding for the name n that is uninitialized. The binding is created in the associated 44 copyright sign ECMA International 2024 declarative record. A binding for n must not already exist in the declarative record. If D is true, the new binding is marked as being subject to deletion. It performs the following steps when called. Let DCLREC be envrec. If DCLREC has binding n is true, throw a type error exception. Return DCLREC create mutable binding n d, 1, 1, 4, 3 create a mutable binding n s. The create a mutable binding concrete method of a global environment. Record envrec takes arguments n, a string, and s, a boolean, and returns either a normal completion containing unused or a throw completion. It creates a new immutable binding for the name n that is uninitialized. A binding must not already exist in this environment. Record for n if s is true. The new binding is marked as a strict binding. It performs the following steps when called. Let DCLREC be envrec. If DCLREC has binding n is true, throw a type error exception. Return DCLREC create a mutable binding n s, 1, 1, 4, 4 initialize binding n v. The initialize binding concrete method of a global environment. Record envrec takes arguments n, a string, and v, an ECMA script language value, and returns either a normal completion containing unused or a throw completion. It is used to set the bound value of the current binding of the identifier whose name is n to the value v. An uninitialized binding for n must already exist. It performs the following steps when called. Let DCLREC be envrec. If DCLREC has binding n is true, then a return DCLREC initialize binding n v. Assert if the binding exists, it must be in the object environment. Record. Let objrec be envrec. Return objrec initialize binding n v, 1, 1, 4, 5 set mutable binding n v s. The set mutable binding concrete method of a global environment. Record envrec takes arguments n, a string, v, an ECMA script language value, and s, a boolean, and returns either a normal completion containing unused or a throw completion. It attempts to change the bound value of the current binding of the identifier whose name is n to the value v. If the binding is an immutable binding and s is true, a type error is thrown. A property named n normally already exists, but if it does not or is not currently writable, error handling is determined by s. It performs the following steps when called. Let DCLREC be n
This is why makefiles suck.
is true.
Even chatbot can't make a makefile.
n v
This is so pathetic.
envrec. Return objrec set mutable
Chatbot is so not AI.
1, 4, 6 get binding value n f.
Oh, everything's so stupid.
Environment. Record envrec takes arguments n, a string, and s, a boolean, and returns either a normal completion containing an ECMA script language value or a throw completion. It returns the value of its bound identifier whose name is n if the binding is an uninitialized binding. Throw a reference error exception. A property named n normally already exists, but if it does
pasted that too many times. No. This Mac has 24 gigs of RAM. 24 gigs. But it like performs like it has 2. It's ridiculous. Yeah, I pasted this quite a few times. Dang it.
You cannot escape triangles. 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 You cannot escape triangles.
So like, don't forget.
You cannot escape triangle.
You can't escape triangles.
You cannot escape triangles. You cannot escape triangles. You cannot escape triangles. You cannot escape triangles. You cannot escape triangles. You cannot escape triangles. You cannot escape triangles.
You can't escape them. Nope.
You cannot escape
You cannot escape triangles.
You cannot escape
It's just the way it is.
triangles. You cannot escape triangles. You cannot escape triangles.
Don't don't be a square. Be a triangle.
You cannot escape triangles. You cannot escape
I hate triangles.
You cannot escape triangles.
Fucking triangles.
You cannot escape triangles. You cannot escape
Triangles are try hard.
triangles.
It's literally in the word.
You cannot escape triangles.
Try hard.
Triangles. You cannot escape triangles.
An angle.
You cannot escape triangles.
Put together.
Escape triangles. You can
You get a try hard circle.
You cannot escape triangles.
You get a try hard square.
You cannot
You get a try hard rectangle.
escape triangle.
Trying way too hard to make every fucking shape out of a fucking triangle.
You cannot escape triangles.
Try hard a goal.
You cannot escape
Triangle. You can't escape them.
triangles. You cannot escape 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 triangle. 9. 1. 2. To new declarative environment. E. The abstract operation new declarative.
Okay, I think I'm gonna do this.
An environment record or not.
Right now makes a triangle,
Declarative environment record.
because you cannot escape triangles.
New declarative.
You can't escape them.
Containing no bindings. Set env to E. Return env, 1, 2, 3 new object environment. O. W.
I'm gonna replace
Operation new object environment takes arguments O, an object, W, a boolean, and E, an
the code that makes the triangles with the pass-through vertex now.
board. It performs the following steps when called. Let env be a new object environment record. Set env to O, set env to W, set env to E. Return env, 1, 2, 4 new function environment. F. New target. The abstract operation new function environment takes arguments F, an ECMA script function object, and new target, an object or undefined, and returns a function environment record. It performs the following steps when called. Let env be a new function environment record containing no bindings. Set env to F. If F is lexical, set env to lexical, else.
So I'm losing the triangle.
Set env to new target. Set env to F. Return env, 1, 2, 5 new global environment. G. This value. The abstract operation new global environment takes arguments G, an object, and this value, an object, and returns a global environment record. It performs the following steps when called. Let obj-rec be new object environment. G. False. Null. Let DCL-rec be new declarative environment. Null. Let env be a new global environment record. Set env to obj-rec. Set env to this value. Set env to DCL-rec. Set env to a new empty list. Set env to null. Return env, 1, 2, 6 new module environment. E. The abstract operation new module environment takes argument E, an environment record, and returns a module environment record. It performs the following steps when called. Let env be a new module environment record containing no bindings. Set env to E. Return env, ECMA International 2024-151, 9.2 Private Environment Records. A private environment record is a specification mechanism used to track private names based upon the lexical nesting structure of class declarations and class expressions in ECMA script code. They are similar to, but distinct from, environment records. Each private environment record is associated with a class declaration or class expression. Each time such a class is evaluated, a new private environment record is created to record the private names declared by that class. Each private environment record has the fields defined in Table 23. Table 23. Private.
Let's see what this does.
Field name, value T, IP meaning, outer private environment. A. Private environment record or null. The private environment record of the nearest
That's a whole lot of nothing.
which this private environment record is associated is not contained in any other class. Names, a list of private names. The private names declared by this class. 9. 2. 1 private environment record operations. The following abstract operations are used in this specification to operate upon private environment records. 9. 2. 1. 1 new private environment. Outer privy env. The abstract operation new private environment takes argument outer privy env, a private environment record or null, and returns a private environment record. It performs the following steps when called. Let names be a new empty list. Return the private environment record. Outer privy env, names, 2, 1. To resolve private identifier, privy env, identifier. The abstract operation resolve private identifier takes arguments privy env, a private environment record, and identifier, a string, and returns a private name. It performs the following steps when called. Let names be privy env. For each private name Pn of names, do if Pn is identifier. Then I return Pn. Let outer privy env be privy env. Assert. Outer privy env is not null. Return resolve private identifier. Outer privy env, identifier. 0.3 realms. Before it is evaluated, all ECMA script code must be associated with the realm. Conceptually, a realm consists of a set of intrinsic objects, an ECMA script global environment, all of the ECMA script code that is loaded within the scope of that global environment, and other associated state and resources. A realm is represented in this specification as a realm record with the fields specified in Table 24, 52, copyright sign, ECMA International 2024, Table 24, realm record fields, field name, agent signifier, intrinsics, global object, global env, template map, an object or undefined value, an agent signifier, a record whose field names are intrinsic keys and whose values are objects, a global environment record, a list of records with fields, a template literal, parse node, and v, an array, f, the agent that owns this realm, the global object for this realm, the global environment for this realm, meaning the intrinsic values used by code associated with this realm, a list of records with fields are a string and a module record. Note 1: once a parse node becomes unreachable, the corresponding is also unreachable, and it would be unobservable if an implementation removed the pair from the list. Anything default value is undefined. Note 2: as mentioned in host load imported module 16.2.1.8. Note 1: in realm records is only used when running an import expression in a context where there is no active script or module field reserved for use by hosts that need to associate additional information with a realm record. Template objects are canonicalized separately for each realm using its realm records. Each value is a parse node that is a template literal. The associated ALU is the corresponding template object that is passed to a tag function, a map from the specifier strings imported by this realm to the solved module record. The list does not contain two different records with the same 9.3.1 create realm. The abstract operation create realm takes no arguments and returns a realm record. It performs the following steps when called. Let realm rec be a new realm record. Perform create intrinsics. Realm rec. Set realm rec to agent signifier. Set realm rec to undefined. Set realm rec to undefined. Set realm rec to a new empty list. Return realm rec. ECMA International 2024 153 9.3.2 create intrinsics. Realm rec. The abstract operation create intrinsics takes argument realm rec, a realm record, and returns unused. It performs the following steps when called. Set realm rec to a new record. Set fields of realm rec with the values listed in table 6. The field names are the names listed in column 1 of the table. The value of each field is a new object value fully and recursively populated with property values as defined by the specification of each object in clauses 19 through 28. All object property values are newly created object values. All values that are built-in function objects are created by performing create built-in function, steps, length, name, slots, realm rec, prototype, where steps is the definition of that function provided by this specification. Name is the initial value of the function's name property. Length is the initial value of the function's length property. Slots is a list of the names, if any, of the function's specified internal slots. And prototype is the specified value of the function's internal slot. The creation of the intrinsics and their properties must be ordered to avoid any dependencies upon objects that have not yet been created. Perform capital A, D, D, capital R, E, S, T, R, I, C, T, E, D, capital F, U, N, C, T, I, O, N, capital P, R, O, P, E, R, T, I, E, realm rec. Realm rec. Return unused. 3.3 set realm global object. Realm rec. Global obj. This value. The abstract operation set realm global object takes arguments realm rec, a realm record, global obj, an object or undefined, and this value, an object or undefined, and returns unused. It performs the following steps when called. If global obj is undefined, then a let intrinsics be realm rec. B set global obj to ordinary object create intrinsics. Assert global obj is an object if this value is undefined. Set this value to global obj. Set realm rect to global obj. Let new global env be new global environment. Global obj. This value. Set realm rect to new global env. Return unused. 3.4 Set default global bindings. Realm rec. The abstract operation set default global bindings takes argument realm rec, a realm record, and returns either a normal completion containing an object or a throw completion. It performs the following steps when called. Let global be realm rec for each property of the global object specified in clause 19. Do a let name be the string value of the property name. B let desc be the fully populated data property descriptor for the property, containing the specified attributes for the property. For properties listed in 19.2, 19.3, or 19.4, the value of the attribute is the corresponding intrinsic object from realm rec. See perform. Define property or throw global name desc return global. Point 4 Execution contexts. An execution context is a specification device that is used to track the runtime evaluation of code by an ECMA script implementation. At any point in time, there is at most one execution context per agent that is actually executing code. This is known as the agent's running execution context. All references to the running execution context in this specification denote the running execution context of the surrounding agent. The execution context stack is used to track execution contexts. The running execution context is always the top element of this stack. A new execution context is created whenever control is transferred from the executable code associated with the currently running execution context to an executable code that is not associated with that. 54. Copyright sign, ECMA International 2024. Execution context. The newly created execution context is pushed onto the stack and becomes the running execution context. An execution context contains whatever implementation-specific state is necessary to track the execution progress of its associated code. Each execution context has at least the state components listed in Table 25. Table 25. State components for all execution contexts. Component. Purpose. Code evaluation state. Any state needed to perform, suspend, and resume evaluation of the code associated with this execution context. Function. If this execution context is evaluating the code of a function object, then the value of this component is that function object. If the context is evaluating the code of a script or module, the value is null. Realm. The realm record from which associated code accesses ECMA script resources. Script or module. The module record or script record from which associated code originates. If there is no originating script or module, as is the case for the original execution context created in initialize host-defined realm, the value is null. Evaluation of code by the running execution context may be suspended at various points defined within this spec. Bifurcation. Once the running execution context has been suspended, a different execution context may become the running execution context and commence evaluating its code. At some later time, a suspended execution context may again become the running execution context and continue evaluating its code at the point where it had previously been suspended. Transition of the running execution context status among execution contexts usually occurs in stack-like last-in first-out manner. However, some ECMA script features require non-LFO transitions of the running execution context. The value of the realm component of the running execution context is also called the current realm record. The value of the function component of the running execution context is also called the active function object. ECMA script code execution contexts have the additional state components listed in Table 26. Table 26. Additional state components for ECMA script code execution contexts. Component. Purpose. Lexical environment. Identifies the environment record used to resolve identifier references made by code within this execution context. Variable environment. Identifies the environment record that holds bindings created by variable statements within this execution context. Private environment. Identifies the private environment record that holds private names created by class elements and the nearest containing class null if there is no containing class. The lexical environment and variable environment components of an execution context are always environment records. Execution contexts representing the evaluation of generators have the additional state components listed in Table 27. ECMA International 2024 155. Table 27. Additional state components for generator execution contexts. In most situations, only the running execution context, the top of the execution context stack, is directly manipulated by algorithms within this specification. Hence, when the terms lexical environment and variable environment are used without qualification, they are in reference to those components of the running execution context. An execution context is purely a specification mechanism and need not correspond to any particular artifact of an ECMA script implementation. It is impossible for ECMA script code to directly access or observe an execution context. 4.1 Get active script or module. The abstract operation get active script or module takes no arguments and returns a script record, a module record, or null. It is used to determine the running script or module based on the running execution context. It performs the following steps when called. If the execution context stack is empty, return null. Let EC be the topmost execution context on the execution context stack whose script or module component is not null. If no such execution context exists, return null. Otherwise, return X script or module. 4.2 Resolve binding. Name env. The abstract operation solve binding takes argument name, a string, and optional argument env, an environment record or undefined, and returns either a normal completion containing a reference record or a throw completion. It is used to determine the binding of name env can be used to explicitly provide the environment record that is to be searched for the binding. It performs the following steps when called. If env is not present or env is undefined, then A set env to the running execution context's lexical environment. Assert env is an environment record if the source text matched by the syntactic production that is being evaluated is contained in strict mode. Code. Let strict be true, else let strict be false. Return. Get identifier reference. env. Name. Strict. 4.3 Get this environment. The abstract operation get this environment takes no arguments and returns an environment record. It finds the environment record that currently supplies the binding of the keyword this. It performs the following steps when called. Let env be the running execution context's lexical environment 2. Repeat. Component purpose. Generator the generator that this execution context is evaluating. 156. ECMA International 2024. Note the result of resolve binding is always a reference record whose field is name. ABCDE. Let exists be env has this binding. If exists is true, return env. Let outer be env. Assert. Outer is not null. Set env to outer. Note the loop in step 2 will always terminate because the list of environments always ends with the global environment which has this binding. 4.4 Resolve this binding. The abstract operation resolve this binding takes no arguments and returns either a normal completion containing an ECMA script language value or a throw completion. It determines the binding of the keyword this using the lexical environment of the running execution context. It performs the following steps when called. Let env rec be get this environment. Return env rec get this binding. 4.5 Get new target. The abstract operation get new target takes no arguments and returns an object or undefined. It determines the new target value using the lexical environment of the running execution context. It performs the following steps when called. Let env rec be get this environment. Assert. env rec has a field. Return env rec. 4.6 Get global object. The abstract operation get global object takes no arguments and returns an object. It returns the global object used by the currently running execution context. It performs the following steps when called. 2.5 Let current realm be the current realm record. Return current realm, jobs and host operations to enqueue jobs. A job is an abstract closure with no parameters that initiates an ECMA script computation when no other ECMA script computation is currently in progress. Jobs are scheduled for execution by ECMA script host environments in a particular agent. This specification describes the host hook's host enqueue generic job. Capital H O S T capital E N Q U E U E capital F I N A L I Z A T I O N capital R E G I S T R host enqueue promise job and host enqueue timeout job to schedule jobs. The host hooks in this specification are organized by the additional constraints imposed on the scheduling of jobs. Hosts may define additional abstract operations which schedule jobs. Such operations accept a job abstract closure and a realm record or null, as parameters. If a realm record is provided, these operations schedule the job to be performed at some future time in the provided realm, in the agent that owns the realm. If null is provided instead for the realm, then the job does not evaluate TCMA script code. Their implementations must conform to the following requirements. At some future point in time, when there is no running context in the agent for which the job is scheduled and that agent's execution context stack is empty, the implementation must perform any host-defined preparation steps, invoke the job abstract closure, perform any host-defined cleanup steps, after which the execution context stack must be empty. Only one job may be actively undergoing evaluation at any point in time in an agent. Once evaluation of a job starts, it must run to completion before evaluation of any other job starts in an agent. The abstract closure must return a normal completion, implementing its own handling of errors. ECMA International 2024-157. Note: 1. Host environments are not required to treat jobs uniformly with respect to scheduling. For example, web browsers and Node.js treat promise handling jobs as a higher priority than other work. Future features may add jobs that are not treated at such a high priority. At any particular time, script or module, a script record, a module record, or null, is the active script or module if all of the following conditions are true. Get active script or module is script or module. If script or module is a script record or module record, let EC be the topmost execution context on the execution context stack whose script or module component is script or module. The realm component of EC is script or module. At any particular time, an execution is prepared to evaluate TCMA script code if all of the following conditions are true. The execution context stack is not empty. The realm component of the topmost execution context on the execution context stack is a realm record. Particular kinds of jobs have additional conformance requirements. 5.1 Job callback records. A job callback record is a record value used to store a function object and a host-defined value. Function objects that are invoked via a job enqueued by the host may have additional host-defined context. To propagate the state, job abstract closures should not capture and call function objects directly. Instead, use host make job callback and host calge ob callback. Job callback records have the fields listed in Table 28. Table 28. Job callback record fields. 5.2 Host make job callback. Callback, the host-defined abstract operation host make job callback takes argument callback, a function object, and returns a job callback record. An implementation of host make job callback must conform to the following requirements. It must return a job callback record whose field is callback. Note: 2 Host environments may prepare an execution to evaluate code by pushing execution contexts onto the execution context stack. The specific steps are implementation defined. The specific choice of realm is up to the host environment. This initial execution context and realm is only in use before any callback function is invoked. When a callback function related to a job, like a promise handler, is invoked, the invocation pushes its own execution context and realm. Note the WHATWG-HTML specification, https://html.spec.whatwg.org/ For example, uses the host-defined value to propagate the incumbent settings object for promise callbacks. Field name, value, meaning callback, a function object, the function to invoke when the job is invoked. Host defined, anything default value is empty. Field reserved for use by hosts. 158. ECMA International 2024. The default implementation of host make job callback performs the following steps when called. 1. Return the job callback record. Callback empty. ECMA script hosts that are not web browsers must use the default implementation of host make job callback, 5.3 host call job callback, v. Arguments list. The host-defined abstract operation host call job callback takes arguments job callback, a job callback record, v. an ECMA script language value, and arguments list, a list of ECMA script language values, and returns either a normal completion containing an ECMA script language value or a throw completion. An implementation of host call job callback must conform to the following requirements. It must perform and return the result of call job callback, v. arguments list. The default implementation of host call job callback performs the following steps when called. Assert is callable. Job callback is true. Return call job callback, v. arguments list. ECMA script hosts that are not web browsers must use the default implementation of host call job callback, 5.4 host enqueue generic job realm. The host-defined abstract operation host enqueue generic job takes argument job, a job abstract closure, and realm, a realm record, and returns unused. It schedules job in the realm in the agent signified by realm to be performed at some future time. The abstract closures used with this algorithm are intended to be scheduled without additional constraints, such as priority and ordering. An implementation of host enqueue generic job must conform to the requirements in 9.5, 5 host enqueue promise job realm. The host-defined abstract operation host enqueue promise job takes arguments job, a job abstract closure, and realm, a realm record or null, and returns unused. It schedules job to be performed at some future time. The abstract closures used with this algorithm are intended to be related to the handling of promises, or otherwise, to be scheduled with equal priority to promise handling operations. An implementation of host enqueue promise job must conform to the requirements in 9.5 as well as the following. If realm is not null, each time job is invoked, the implementation must perform implementation-defined steps such that execution is prepared to evaluate ECMA script code at the time of job's invocation. Let script or module be get active script or module at the time host enqueue promise job is invoked. If realm is not null, each time job is invoked, the implementation must perform implementation-defined steps such that script or module is the active script or module at the time of job's invocation. Jobs must run in the same order as the host enqueue promise job invocations that scheduled them. Note this is called at the time that the callback is passed to the function that is responsible for its being eventually scheduled and run. For example, promise then action, calls make job callback on then action at the time of invoking promise prototype then, not at the time of scheduling the reaction job. Note this requirement means that hosts cannot change the behavior of function objects defined in this specification. ECMA International 2024-159. Note the realm for jobs returned by new promise resolve thenable job is usually the result of calling get function realm on the then function object. The realm for jobs returned by new promise reaction job is usually the result of calling get function realm on the handler if the handler is not undefined. If the handler is undefined, realm is null. For both kinds of jobs, when get function realm completes abnormally, that is called on a revoked proxy, realm is the current realm record at the time of the get function realm call. When the realm is null, no user ECMA script code will be evaluated and no new ECMA script objects, for example, error objects, will be created. The WHATWG-HTML specification, https://html.spec.whatwg.org/ for example, uses realm to check for the ability to run script and for the entry, https://html.spec.whatwg.org/#entry concept, 5.6 host enqueue timeout job realm, milliseconds. The host-defined abstract operation host enqueue timeout job takes arguments timeout job, a job abstract closure, realm, a realm record, and milliseconds, a non-negative finite number, and returns unused. It schedules timeout job in the realm in the agent signified by realm to be performed after at least milliseconds. An implementation of host enqueue timeout job must conform to the requirements in 9.5. 9.6 init allows host-defined realm. The abstract operation initialize host-defined realm takes no arguments and returns either a normal completion containing unused or a throw completion. It performs the following steps when called. Let realm be create realm. Let new context be a new execution context. Set the function of new context to null. Set the realm of new context to realm. Set the script or module of new context to null. Push new context onto the execution context stack. New context is now the running execution context. If the host requires use of an exotic object to serve as realm's global object, let global be such an object, created in a host-defined manner. Otherwise, let global be undefined, indicating that an ordinary object should be created as the global object. If the host requires that this binding in realm's global scope return an object other than the global object, let this value be such an object created in a host-defined manner. Otherwise, let this value be undefined, indicating that realm's global this binding should be the global object. Perform set realm global object. Realm global. This value 0. Let global obj be. Set default global bindings. Realm 1. Create any host-defined global object properties on global obj 2. Return unused. 0.7 agents. An agent comprises a set of ECMA script execution contexts, an execution context stack, a running execution context, an agent record, and an executing thread. Except for the executing thread, the constituents of an agent belong exclusively to that the agent. An agent's executing thread executes algorithmic steps on the agent's execution contexts independently of other agents, except that an executing thread may be used as the executing thread by multiple agents, provided none of the agents sharing the thread have an agent record whose field is true. Note 1. Some web browsers share a single executing thread across multiple unrelated tabs of a browser window. For example, 60, copyright sign, ECMA International 2024. While an agent's executing thread is executing algorithmic steps, the agent is the surrounding agent for those steps. The steps use the surrounding agent to access the specification-level execution objects held within the agent, the running execution context, the execution context stack, and the agent records fields. An agent signifier is a globally unique opaque value used to identify an agent. Table 29. Agent record fields. Field name, value, meaning, little endian, a boolean. The default value computed for the is little endian parameter when it is needed by the algorithm's get value from buffer and set value in buffer. The choice is implementation defined and should be the alternative that is most efficient for the implementation. Once the value has been observed, it cannot change. Can block. A boolean determines whether the agent can block or not. Signifier. An agent signifier uniquely identifies the agent within its agent cluster. Is lock-free 1. A boolean, true if atomic operations on 1 byte values are lock-free. False otherwise. Is lock-free 2. A boolean, true if atomic operations on 2 byte values are lock-free. False otherwise. Is lock-free 8. A boolean, true if atomic operations on 8 byte values are lock-free. False otherwise. Candidate
My new goal
execution record. See the memory model kept alive. A list of
is to get the display, the screen, the desktop capture
objects and or symbols to be
into this triangle.
job
All I want to do.
and have been observed by any agent in.
That's it. That's all I want to do.
Note 2. The values of and are not necessarily determined by the hardware, but may also reflect.
I don't want to make a new pipeline. I don't want to do a new command buffer. I'm not going to mess with figuring out
4-byte atomic
how to change the command buffer
this. If an atomic
because I just don't care. I just want to be done.
the operation is not lock-free,
So the new plan,
wait-free. There is no up
I'm going to save a backup of everything.
steps may be required to complete a lock-free atomic operation. That an atomic access of size n is lock-free does not imply anything about the perceived
New plan, just get the desktop in this triangle. Whatever the fuck this triangle is, that's where I want to put the desktop.
as a sequence of several
That's the new plan.
accesses. See read shared memory and write shared memory for details. ECMA International 2024 161. Note 3. An agent is a specification mechanism and need not correspond to any particular artifact of an JavaScript implementation. 7.1 Agent signifier. The abstract operation agent signifier takes no arguments and returns an agent signifier. It performs the following steps when called. Let AR be the agent record of the surrounding agent. Return AR, 7.2 Agent can suspend. The abstract operation agent can suspend takes no arguments and returns a boolean. It performs the following steps when called. 2.8 Let AR be the agent record of the surrounding agent. Return AR, agent clusters. Note in some environments it may not be reasonable for a given agent to suspend. For example, in a web browser environment, it may be reasonable to disallow suspending a document's main event handling thread, while still allowing workers' event handling threads to suspend. An agent cluster is a maximal set of agents that can communicate by operating on shared memory. Every agent belongs to exactly one agent cluster. All agents within a cluster must have the same value for the field in their respective agent records. All agents within a cluster must have the same values for the field in their respective agent records. Similarly for the field, all agents within a cluster have different values for the field in their respective agent records. An embedding may deactivate, stop forward progress, or activate, resume forward progress, an agent without the agent's knowledge or cooperation. If the embedding does so, it must not leave some agents in the cluster active while other agents in the cluster are deactivated indefinitely. Note 1. Programs within different agents may share memory by unspecified means. At a minimum, the backing memory for shared array buffers can be shared among the agents in the cluster. There may be agents that can communicate by message passing that cannot share memory. They are never in the same agent cluster. Note 2. The agents in a cluster need not all be alive at some particular point in time. If agent A creates another agent B, after which A terminates and B creates agent C, the three agents are in the same cluster if A could share some memory with B and B could share some memory with C. Note 3. If different agents within an agent cluster have different values it becomes hard to use shared memory for multi-byte data. 62. Copyright sign. ECMA International 2024. Note 4. The purpose of the preceding restriction is to avoid a situation where an agent deadlocks or starves because another agent has been deactivated. For example, if an HTML shared worker that has a lifetime independent of documents and any windows were allowed to share memory with the dedicated worker of such an independent document, and the document and its dedicated worker were to be deactivated while the dedicated worker holds a lock, say, the document is pushed into its Windows history, and the shared worker then tries to acquire the lock, then the shared worker will be blocked until the dedicated worker is activated again, if ever. Meanwhile, other workers trying to access the shared worker from other windows will starve. The implication of the restriction is that it will not be possible to share memory between agents that don't belong to the same suspend-wait collective within the embedding. An embedding may terminate an agent without any of the agent's cluster's other agents' prior knowledge or cooperation. If an agent is terminated not by programmatic action of its own or of another agent in the cluster but by forces external to the cluster, then the embedding must choose one of two strategies: either terminate all the agents in the cluster, or provide reliable APIs that allow the agents in the cluster to coordinate so that at least one remaining member of the cluster will be able to detect the termination, with the termination data containing enough information to identify the agent that was terminated. Each of the following specification values, and values transitively reachable from them, belong to exactly one agent cluster. Candidate execution record, shared data block, waitlist record. Prior to any evaluation of any ECMAScript code by any agent in a cluster, the T execution field of the agent record for all agents in the cluster is set to the initial candidate execution. The initial candidate execution is an empty candidate execution whose field is a list containing, for each agent, an agent events record whose field is that agent's agent signifier, and whose fields are empty lists. Note 5 examples of that type of termination are operating systems or users terminating agents that are running in separate processes, the embedding itself terminating an agent that is running in process with the other agent's WinPer, Agent resource accounting indicates that the agent is runaway. Note 6. All agents in an agent cluster share the same candidate execution in its agent records field. The candidate execution is a specification mechanism used by the memory model. Note 7. An agent cluster is a specification mechanism and need not correspond to any particular artifact of an ECMA script implementation. Point 9. Forward progress. For an agent to make forward progresses for it to perform an evaluation step according to this specification, an agent becomes blocked when its running execution context waits synchronously and indefinitely for an external event. Only agents whose agent records field is true can become blocked in this sense. An unblocked agent is one that is not blocked. Implementations must ensure that every unblocked agent with a dedicated executing thread eventually makes forward progress. In a set of agents that share an executing thread, one agent eventually makes forward progress. ECMA International 2024 163. An agent does not cause another agent to become blocked except via explicit APIs that provide blocking. Point 10. Processing model of weak ref and finalization registry targets 9.10. 1 Objectives. This specification does not make any guarantees that any object or symbol will be garbage collected. Objects or symbols which do not live may be released after long periods of time, or never at all. For this reason, this specification uses the term may when describing behavior triggered by garbage collection. The semantics of weak refs and finalization registries is based on two operations which happen at particular points in time. When weak ref prototype derf is called, the referent, if undefined is not returned, is kept alive so that subsequent synchronous accesses also return the same value. This list is reset when synchronous work is done using the clear-kept objects abstract operation, when an object or symbol which is registered with the finalization registry becomes unreachable. C.
Here's the thing. Oh, where's this thing? So, I get it. The graphics pipeline is in layers. So it's like the vertex shader, and then the fragment shader. And that this is the vertex, and this is a fragment. And that they have to be called or placed in the pipeline in that order. First vertex, then the fragment. And it's gotta be a goddamn triangle. And it's within all these really stupid, idiotic. This is ridiculous. This is pathetic. This is the most annoying crap ever. None of this has anything to do with fucking hardware. It's all made up software. The whole triangle thing is fucking ridiculous. Binary is 2. On off. It's always 2. There is no magical 3 binary number. A triangle has 3 points, not 4. To say that a triangle is optimal is bullshit. It's the dumbest crap ever. Oh, this is so annoying. If this was like real, if this was based like off of like actual hardware, I would actually invest time into learning it. But this is all software driven. It's just made up magic land. It's so annoying. So I really don't care how this works. I don't care about all the steps. I just want to be done. On the CPU, when I go through the standard, I'm interacting with the actual CPU. It's like actual fucking freaking hardware. On the GPU, you don't get that. You get structs. And you get to call things that call things that do other things that run software. It's not fucking hardware. And if you like, come up with the most optimal way to do something with triangles, this is just dumb. It doesn't even apply to the real world. There is no such thing as like a magical triangle hardware. Oh, it's so stupid. I like hardware. Software is annoying. I just gotta get done. I don't understand the stupid pipeline. I don't care. I have to what? Set up a pipeline and switch between pipelines? I have to make how many more arrays? I have to make how many more pointers? This is so frustrating. My goal now is to just get the desktop inside this triangle. That's my goal. A very simple goal. I already got a triangle. I'm gonna put the desktop inside of there and then figure out from there. Because this is so frustrating. Annoying. I'm so tired of software. Why is software so crappy? I mean, like, what did the customer ever do to you to design such poorly written software? Why can't I just do text-to-speech? Why does it leak memory? Why do I have to restart the computer? Why? The modern OS is gonna be replaced.
1.
It's pathetic.
Chain B optional chain. Let new reference B. Chain evaluation.
I'm tired of wasting my time on all these dumb things
Let new value B.
that I can't control
New reference.
because I didn't write it.
And string B the string value of private identifier. Return make private reference.
If I write something dumb, at least it's my fault.
3rd of March 2010.
But I have no one to blame
3.
when this shit, like the fucking text-to-speech, just doesn't work.
Import call. Import. Assignment express. Get active script or module. If referrer is null, set referrer to the current realm record. Let argraph be. Evaluation of assignment expression. Let's specify B. Get value. Argraph. Let promise capability be. New promise capability. Promise %. Let's specify a string B completion. To string. Specifier. If abrupt reject promise. Specify a string. Promise capability. Perform host load imported module. Referrer. Specify a string. Empty. Promise capability. Return promise capability. 3. 3. 1 0 1. 1 continue dynamic import. Promise capability. Module completion. The abstract operation continue dynamic import takes arguments promise capability, a promise capability record, and module completion, either a normal completion containing a module record or a throw completion, and returns unused. It completes the process of a dynamic import originally started by an import call resolving or rejecting the promise returned by that call as appropriate. It performs the following steps when called. If a module completion is an abrupt completion, then a perform call promise capability undefined. Module completion be return unused. Let module be module completion. Let load promise be module load requested modules. Let rejected closure be a new abstract closure with parameters reason that captures promise capability and performs the following steps when called. A perform call promise capability undefined. Reason be return unused. Let onRejected be create built-in function rejected closure 1. Let link and evaluate closure be a new abstract closure with no parameters that captures module promise capability and onRejected and performs the following steps when called. A let link be completion module link be if link is an abrupt completion, then I perform call promise capability undefined link 2. Return unused. C. Let evaluate promise be module evaluate. D. Let fulfilled closure be a new abstract closure with no parameters that captures module and promise capability and performs the following steps when called. I let namespace be get module namespace module 2. Perform call promise capability undefined namespace 3. Return unused. E. Let unfulfilled be create built-in function fulfilled closure 0. F. Perform promise then evaluate promise unfulfilled onRejected. G. Return unused. Link and evaluate be create built-in function link and evaluate closure 0. Dot. Let perform promise then load promise link and evaluate onRejected. Return unused. ECMA International 2024 267. The 13th of March 2011 tag templates 3. 1 runtime semantics evaluation member expression template literal let tag ref be evaluation of member expression let tag fun be get value tag ref let this call be this member expression let tail call be as in tail position this call return evaluate call tag func tag ref template literal tail call expression template literal let tag ref be evaluation of call expression let tag func be get value tag ref let this call be this call expression let tail call be as in tail position this call return evaluate call tag func tag ref template literal tail call the 3rd of March 2012 meta properties 3 1 2 1 runtime semantics evaluation new target 1 return get new target import meter import meta let module be get active script or module assert module is a source text module record let import meter be module if import meter is empty then a set import meter to ordinary object create null b let import meter values be host get import meter properties module c for each record p of import meter values do I perform create data property or throw import meter p d perform host finalize import meter module e set module to import meter f return import meter else a assert import meter is an object b return import meter 3 1 2 1 host get import meter properties module record the host defined abstract operation host get import meter properties takes argument module record and returns a list of records with fields any CMA script language value. It allows hosts to provide property keys and values for the object returned from import meter. The default implementation of host get import meter properties is to return a new empty list. Note a tag template is a function call where the arguments of the call are derived from a template literal 1 3 2 8. The actual arguments include a template object 1 3 2 8 4 and the values produced by evaluating the expressions embedded within the template literal 68. Copyright sign ECMA International 2024 133 12 1 to host finalize import meter module record the host defined abstract operation host finalize import meter takes arguments import meter an object and module record and returns unused It allows hosts to perform any extraordinary operations to prepare the object returned from import meter. Most hosts will be able to simply define host get import meter properties and leave host finalize import meter with its default behavior. However, host finalize import meter provides an escape hatch for hosts which need to directly manipulate the object before it is exposed to ECMA script code. The default implementation of host finalize import meter is return unused. 3.4 Update expression syntax. Update expression, yield, await, left-hand side expression yield await, left-hand side expression yield await, left-hand side expression yield await, plus unary expression yield await, unary expression yield await, 1 3 4 1 static semantics, early errors, update expression, left-hand side expression plus, no line terminator here, plus, no line terminator here, left-hand side expression. It is an early syntax error if assignment target type of left-hand side expression is not simple. Update expression plus unary expression, unary expression. It is an early syntax error if assignment target type of unary expression is not simple. 3 4 2 postfix increment operator 1 3 4 2 1 runtime semantics. Evaluation, update expression, left-hand side expression plus, let LHS be. Evaluation of left-hand side expression, let old value be. To numeric, get value, LHS, if old value is a number, then let new value be number, add, old value, 1, else, assert, old value is a bigint, be let new value be bigint, add, old value, 1z, perform, put value, LHS, new value, return old value, ECMA International 2024 269, 1 3 4 3 postfix decrement operator 1 3 4 3 1 runtime semantics, evaluation, update expression, left-hand side expression, let LHS be. Evaluation of left-hand side expression, let old value be. To numeric, get value, LHS, if old value is a number, then let new value be number, subtract, old value, 1, else, assert, old value is a bigint, be let new value be bigint, subtract, old value, 1z, perform, put value, LHS, new value, return old value, 3 4 4 prefix increment operator 1 3 4 4 1 runtime semantics, evaluation, update expression, plus unary expression, let x be. Evaluation of unary expression, let old value be. To numeric, get value, exper, if old value is a number, then let new value be number, add, old value, 1, else, assert, old value is a bigint, be let new value be bigint, add, old value, 1z, perform, put value, exper, new value, return new value, 3 4 5 prefix decrement operator 1 3 4 5 1 runtime semantics, evaluation, update expression, unary expression, let x be. Evaluation of unary expression, let old value be. To numeric, get value, exper, if old value is a number, then let new value be number, subtract, old value, 1, else, assert, old value is a bigint, be let new value be bigint, subtract, old value, 1z, perform, put value, exper, new value, return new value, 70, ECMA International 2024, 13.5 unary operators syntax, unary expression, yield, await, update expression yield await, delete unary expression yield await, void unary expression yield await, type of unary expression yield await plus unary expression yield await, unary expression yield await, unary expression yield await, unary expression yield await plus await, await expression yield 3 5 1 the delete operator 3 5 1 1 static semantics, early errors, unary expression, delete unary expression. It is a syntax error if the unary expression is contained in strict mode code and the derived unary expression is primary expression, identifier reference, member expression, private identifier, call expression, call expression. Private identifier, optional chain. Private identifier, or optional chain. Optional chain. Private identifier. It is a syntax error if the derived unary expression is primary expression, capital
So, it looks like
R, capital P, A, R.
this part of the API, whatever, works.
Z, E.
And it grabs the mother-loving display capture from the buffer.
S, I.
So that's good. So all I want to do is put this
And capital C, O, V.
into the triangle.
Capital P, A.
Of course, it's not going to run.
N, T, H, E, S, I, Z, E, D, capital E, X, P, R, E, S, S, I, O, N, capital A, N, ultimately derives a phrase that, if used in place of unary expression, would produce a syntax error according to these rules. This rule is recursively applied. 3, 5, 1. To runtime semantics. Evaluation. Unary expression. Delete unary expression. Letter FB. Evaluation of unary expression. If ref is not a reference record, return true. If is unresolvable reference, ref is true, then assert. Ref is false, b return true. If is property reference, ref is true, then assert. Is private reference, ref is false. B if is super reference, ref is true. Throw a reference error exception. C let base objb. To object, ref. D let delete status be base obj, ref. E if delete status is false and ref is true. Throw a type error exception. F return delete status. Else a let base be. Base is an environment record. C return base delete binding, ref. The last rule means that
I turned all the bulk stuff off.
expression of the
So I'm going to run again.
International 2024 271.
And it runs.
Delete operator.
So all I want to do is simply, and I mean like,
Expression is a
when I say simply, I mean like, simply, like, you know, the word simple,
operator.
meaning not in a complex way,
It has the add
not in like initialize 70, 80 different structures,
option is throw
figure out where things attach to other things
outside of the above apps.
in a big web of a made-up imaginary land called
Choose to avoid the actual creation of that object. 3, 5,
you can't escape triangles
5, 2.
because you can't escape triangles.
Evaluation. Unary expression. Void unary expression. Let X be. Evaluation of unary expression. Exper. Return undefined. 3, 5, 3. The tippy off.
You can't escape triangles.
Runtime semantics. Evaluation. Unary
I guess you can't. Someone deal with it.
evaluation of unary
I just simply, then,
then if is
I simply, and I literally mean, simply,
undefined. Set
I simply want,
value.
I simply need to get
Return
the display capture into this triangle. That's all I need. Very simply.
symbol. If val is a boolean, return boolean. If val is a number, return number. 0. If val is a big int, return bigint. 1. Assert.
And then I can figure it out from there.
Note, the step is replaced in section B. 3, 6, 3, 3.
But I need something that works before I go around trying something new.
3, 5.
Because I don't know if any of the stuff I was doing worked. Because I can't get an output yet.
Current number type
I don't want to invest hours
equaled even though its value is not.
into typing in stuff, initializing stuff, setting stuff, in a pipeline, preparing stuff. If it doesn't work, then it's such a waste of time.
1 runtime
If I can get,
unary expression.
very simply, the desktop into this triangle,
Evaluation of
then I know that works. And I can adjust it and tweak it, set up a separate pipeline or whatever the hell it's called.
3.
But I have something working and I can change it.
Semantic.
I can't take getting something to work from nothing and spending hours setting up these magical calls that you can't even check if they succeeded
Is a number.
because it's all in the video card. You don't have access to it. So I don't know. This is so frustrating.
Third. Old value is a big.
I just want to write a JavaScript engine. And this is like eating up my time.
Verts its
It's like 7 days now.
value and then negates it.
I was planning at least 4. This is 7. This is so annoying.
Uses plus 0. Bitwise not operator. Unary expression. Unary expression. 3. 5. 6. 3. 5. Evaluation. Let x be. Evaluation of unary expression. Let old value be. To numeric. Get value. Exper. If old.
Where's chatbot?
A return number. Bitwise not. Old value 4. Else. AB. Assert. Old value is a big int. Return big int. Bitwise not. Old value. Logical not operator. Unary expression. Unary expression. 3. 5. 7. 3. 5. 7. 1 runtime semantics. Evaluation. Let x be.
So chatbot's like, I got this. So let's see what chatbot is gonna do.
If old value is true, return false. Return true. 3.6 exponentiation operator syntax. Exponentiation expression. Yield. Await. Unary expression yield await. Update expression yield await. Exponentiation expression yield await. ECMA International 2024 273 136 1 runtime semantics. Evaluation. Exponentiation expression. Update expression. Exponentiation expression. Return. Capital E V A L U A T E. Capital S T R I N G. Capital O R. Capital N U M E R I C. Capital B I N A R Y. Capital E. Update expression. Exponentiation.
Where's Master Chatbot?
7 multiplicative operators syntax. Multiplicative expression. Yield. Await. Exponent.
How do I simply capital, I'm gonna like caps lock the word simply.
Exponentiation expression yield await. Multiplicative operator. 1 of percent. 3. 7.
How do I simply?
Evaluation. Multiplicative expression. Multiplicative expression.
Put the screen capture into that triangle.
Multiplicative operator. Return. Capital E V A L U A T E. Capital S T R I N G.
And then I had like emphasized simply.
N U M E R I C. Capital B I N A R Y. Capital E. Multiplicative expression. Text. Exponentiation expression. 3.8 additive operato. RS syntax. Additive expression. Yield. Await. Multiplicative expression yield await. Additive expression yield await plus multiplicative expression yield await. Additive expression yield await. Multiplicative expression yield await. 3. 8. 1. The addition operator. Plus, note the addition operator either performs string concatenation or numeric addition. 3. 8. 1. 1 runtime semantics. Evaluation. Additive expression. Additive expression plus multiplicative expression. Return. Capital E V A L U A T.
Okay, what I'm going to do is not ask chatbot to do this. Instead, I'm just going to fill it in myself.
Capital
Because chatbot is not AI.
C.
It's like the complete, it's literally a plagiarism machine. It goes to Stack Overflow, and it takes answers, and it pretends it didn't get them there.
Multiplicative expression. Note, the operator performs multiplication, producing the product of its operands. The operator performs division, producing the quotient of its operands. The percent operator yields the remainder of its operands from an implied
Alright, so here, this is what I have to do, I guess. Simply, because it's just so simple.
2024 138 to the subtraction operator 3 8 2 1 runtime semantics evaluation additive expression multiplicative expression return capital E V A L U A T E capital S T R I N G capital O R capital N U M E R I C capital B I.
First, I need to make a Falcon image, whatever that means.
Expression, multiplicative expression, 3.9 bitwise shift operators syntax, shift expression, yield, await, additive expression, yield, await, 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 3 9 1 the left shift operator 3 9 1 1 runtime semantics evaluation shift expression
Why does it do this?
return cap
It's like
E
call VK, create image,
A T E capital S T
allocate, and bind the memory.
G capital O R capital N.
It's like, it's real simple, here's how you do it. And it gives you like 10% of how to do it. And it's like, wow, thank you for pointing out the obvious. Now where's the rest of it? And you ask for that, and chatbot's like, it just makes up garbage.
9 to the signed right shift operator 3 9
Yeah.
6 evaluation shift expression additive expression return capital E V A L U A T E capital S T R I N G capital O R capital N U R I C capital B I N A R Y capital E shift expression additive expression 3 9 3 the unsigned right shift operator. Note the operator performs subtraction, producing the difference of its operands. Note performs a bitwise left shift operation on the left operand by the amount specified. Operand. Note performs a sign filling bitwise right shift operation on the left operand by the amount specified by the right operand. Note performs a zero filling bitwise right shift operation on the left operand by the amount specified by the right operand. ECMA International 2024 275 139 3 1 runtime semantics evaluation shift expression additive expression return capital E V A L U A T E capital S T R I N G capital O R capital N U M E R I C capital B I N A R Y capital E shift expression additive expression 3.10 relational operators syntax relational expression in yield await shift expression yield await relational expression in yield 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 await shift expression yield await shift expression yield await equals shift expression.
Why does it do this?
Expression.
It's like, do this stuff,
Note.
and it says like, get image memory requirements. And it doesn't even give the function for it. And it acts Like it's like some function that exists in the wild,
plus
but it just makes up a name and it calls it VK whatever.
identifier.
It's so frustrating.
3. 1
Holy crap.
times semantics. Evaluation. Relational expression. Relational expression. Shift expression. Letter FB. Evaluation of relational expression. Little val B. Get value. Ref. Letter FB. Evaluation of shift expression. Letter val B. Get value. Ref. Letter B. Is less than. Val. Reval. True if R is undefined. Return false. Otherwise, return R. Relational expression. Relational expression. Shift expression. Letter FB. Evaluation of relational expression. Little val B. Get value. Ref. Letter FB. Evaluation of shift expression. Letter val B. Get value. Ref. Letter B. Is less than. Reval. Val. False. If R is undefined, return false. Otherwise, return R. Relational expression. Relational expression equals shift expression. Letter FB. Evaluation of relational expression. Little val B. Get value. Ref. Letter FB. Evaluation of shift expression. Letter val B. Get value. Ref. Letter B. Is less than. Reval. Val. False. If R is either true or undefined, return false. Otherwise, return true. 276. ECMA International 2024. Note to the in grammar parameter is needed to avoid confusing the in operator
Did it really just do it again?
in a for statement. Relational expression. Relational expression equals shift expression. Letter FB. Evaluation of relational expression. Little val B. Get value. Ref. Letter FB. Evaluation of shift expression. Letter val B. Get value. Ref. Letter B. Is less than. Val. Reval. True if R is I.
Okay, no, this time it actually added it.
Otherwise, return true. Relational expression. Relational expression instance of shift expression. Letter FB.
Are you kidding me?
Expression. Little val B. Get value. Ref. Letter FB. Evaluation of shift expression. Letter val B. Get value. Ref. Return.
Oh wait, this is actually an API call. Okay.
Val. Relational expression. Relational expression in shift expression. Letter FB. Evaluation of relational expression. Little val B. Get value. Ref. Letter FB. Evaluation of shift expression. Letter val B. Get value. Ref. If reval is not an object, throw a type error exception. Return. Has property. Reval. To property key. Val. Relational expression. Private identifier in shift expression.
Why is this so...
Identifier. Letter FB. Evaluation of shift expression. Letter val B. Get value. Ref. If reval is not an object, throw a type error exception. Let private env be the root. Ning execution context's private environment. Let private name be resolved. Private identifier. Private env. Private identifier. If private element find. Reval. Private name. Is not empty. Return true. Return false. 3. 1 0. 2 instantia operator. V. Target. The abstract operation instantia operator takes arguments v, any CMA script language value, and target, any CMA script language value, and returns either a normal completion containing a boolean or a throw completion. It implements the generic algorithm for determining if v is an instance of target either by consulting target.
Okay, so...
If absent, determining whether the value of target's prototype property is present in v's prototype chain. It performs the following steps when called. If target is not an object, throw a type error exception. Let inst of handler be. Get method. Target. At has instance. If inst of handler is not undefined, then a returns a boolean. Call. Inst of handler. Target. V. If is callable. Target. Is false. Throw a type error exception. Return. Ordinary has instance. Target. V. Note steps 4 and 5 provide compatibility with previous editions of ECMA script that did not use at has
VK image is that...
Antics. If an object does not define or
the descriptor, or
default instancia,
why do you need two things to keep track of a single thing for every single thing?
quality operate
It is really frustrating.
expression in yield await relational expression in yield await equality expression in yield await equals relational expression in yield await equality expression in yield await equals relational expression in yield await equality expression in yield await
So you have the device, the logical device, not the physical device,
equality expression in yield await equal
and they have alloc info,
yield await 3 1 runtime semantics evaluation equality expression
they have texture, image memory.
expression letter fb evaluation of equality expression letter val b
In this one, you pass in the address,
evaluation of relational expression letter val b get value ref
which means that it is a null beforehand.
equality expression
Afterhand, it's going to hold an address.
letter fb
So this is called first
letter val b get value ref
because texture, image memory does not hold anything.
val b get value ref
So device and alloc info, wherever this is null, that's to be assigned to texture, or like
t expression
it holds some relation
expression letter fb
to whatever the hell texture image memory is.
get value ref letter fb evaluate
In texture, image memory is going to contain these details or whatever.
equal val
The logical device and the alloc info.
equality expression
And it's also passing in the address of alloc info.
evaluation of equality expression letter val b get value ref letter
Why is it passing in the address?
of relational express ion letter
Why is it actually? Like why?
let rb is strictly equal val
This is local memory.
return false otherwise
Why is the address needed?
278 ECMA International 2024 note the result of evaluating an equality operator is always of type boolean reflecting whether the relationship named by the operator holds between its two operands. Note 1 given the above definition of equality, string comparison can be forced by $sign equals $sign b. Numeric comparison can be forced by plus equals plus b. Boolean comparison can be forced by equals b. Note 2 the equality operators maintain the following invariant.
Well, I guess it needs the address. Because there's no pointer. So you have to pass in something. And if you pass in the data, that's not the address.
Order of
It's a local struct on the stack.
the operator is not
So that must be passed in, not because it's assigned, but because it needs to be passed in somehow.
objects, each representing the same string value. Each string object would be considered equal to the string value by
So if there's a pointer to this, then the pointer we passed in, it wouldn't need to be, the address wouldn't need to be taken of it,
equals a and a equals new
because the pointer would already have been decayed to the address itself
equals new
as value
full.
of the pointer that the pointer holds reference to when dereferenced we'll be accessing.
There is no attempt
I hate everything.
semantic
And then texture image.
character or string equal.
Oh my god, this needs to end.
Use that are canonically equal according to the Unicode standard.
Everything is named almost the same.
Both strings are already in normalized form. 3.12
I can't take it.
operators syntax bitwise and expression in
It might as well be the same.
t expression and yield await bitwise and expression in
Because I'm lazy. It's so much extra effort to keep track of this shit.
await bitwise and expression and yield await bitwise or expression and yield await bitwise and expression and yield await bitwise or expression in yield await
So this
expression and yield
is a local struct.
yield await bitwise or expression and yield
No, it's not.
1 2
It's a global VK image. Is that a pointer?
and expression and equality expression return capital E
What it is, it's annoying. It's annoying. This is all So annoying.
E, capital S, T, R, I, N, G, capital O.
There's nothing quite like an opaque handle that is like so freaking fancy.
C,
I mean, like, opaque handle.
N, A.
There's nothing more fancy than opaque handle.
And equality expression. ECMA International 2024 279. Bitwise or expression.
So I think that means it's a pointer.
Bitwise and expression. Return. Capital E, V.
Opaque means not transparent or see-through.
Capital
Huh.
T, R, I.
It can also refer to something that is difficult to understand or obscure.
U, M, E, R.
In the context of light and materials, it means that light cannot pass through it.
N, A.
Metaphorically, meta, it can describe things like arguments or processes that are unclear.
Return.
No, it's not hard or unclear to grasp. It's fucking distorted and intentionally made and set up in a way to make it hard and unclear.
G, capital O, R, capital N, U,
Opaque.
I, C, capital B, I,
I'll assume it's a pointer.
R, Y, capital E, bitwise or expression. Bitwise or expression. 3 point.
So this one, global, appears first.
Logical and expression.
Right here. Or create image.
Bitwise or expression and yield await. Logical and expression in
Image info is passed in.
or expression and yield await. Logical or expression in yield await.
It's a local struct, so the address is taken. On success, texture image holds what? I guess it holds all this stuff. Oh, I hate this. You have to like get and set and get and set. This whole thing it could be simplified. It could be literally rewritten so many different ways. It's inside out. This is so annoying. Why not just do this? This is what it's doing, basically. This is no more readable. It's just as unreadable. Why not just make one giant function? Is that, like, too complicated? Would that not make sense? Why not just make one big ass function that it returns to be assigned like like how you'd normally expect a C function to be? Just make one big ass function. And it's so much easier to understand. And then do something like this. Instead of using p next for like the next pointer, make something like p error, like pointer to error or something. And then like make it null. So like I pass in this, and then if this is not null, it means there's an error. So then after this call, like a normal human writes a normal function, even if it's big, it's just a big ass function. But you're like, well, it is what it is. This struct thing, these structs are freaking out of control. This is ridiculous. Just make it a giant function. And then at the end, I can test like this and go like if texture image key error does not equal null, and then I can fucking handle the error. And if the error is handled and I like resolve it, then I could even do like set it back to null. Except this would probably need to be garbage collected in some way. So something like VK recycle error or something. Or like VK resolved. So now, if there was an error, and I was able to handle the error, inside after it. So like, let's say like it didn't have enough memory. So like I change the memory size and I call it again. I can check again after it. If there's an error, and then I can throw an error. Because at some point, it's not resolved. Does this not make more sense? How did I just duplicate that? Man, this computer is laggy as hell. How does this not make sense? Even if it's just like this. Why not this? This makes so much more sense. Instead, it's a whole bunch of like disjointed structures passed in by address whenever it doesn't have an address, because it has to be decayed to an address, and when it can't be, you gotta get the address somehow. So you get the address, or it's passed by address because it's global. It needs to be modified to an opaque pointer. It's just sloppy. This is ridiculous. This would make a lot more sense. So I'm done complaining for now. It's just so annoying. Even if I know what to look for, it's annoying because it's extra looking that I gotta freaking look for. And then you can use anonymous structs or like whatever it's called. Compound structs or compact. I don't know what they're called. I don't remember. Except you can use a named property list. And that way, if the function arguments change, they're by named properties. So it doesn't matter. It has the overhead of accessing through a pointer to get to it. Except it will be on the stack, so it shouldn't be any slower than an argument passed in. Alright, I'm gonna like drag it down. Because I'm writing a JavaScript engine. I'm gonna meet the whole standard. I'm gonna make up my own standard for all the things that don't make sense. Like my standard, it's gonna actually be 64-bit. So I should focus on things that I'm actually gonna change instead of complain about things I'm not gonna change. This is gonna get a whole new makeover.
And takes argument D, an environment record or null, and returns a declarative environment record. It performs the following steps when called. Let env be a new declarative environment record containing no bindings. Set env to E. Return env, 1, 2, 3 new object environment. O, W, E. The abstract operation new object.
What is the point
An object.
of texture memory
Environ.
or texture image?
And returns an object environment record. It performs the following steps when called. Let env be a new object environment record. Set env to O. Set env to W.
If it is bound, what's the point of texture image if texture image memory is what's bound?
The abstract operation new function environment takes arguments F,
Is what's being binded.
function object, and new target, an object or undefined, and returns a function environment record. It performs.
Is texture image
Let env be a new function environment record containing no bindings.
available for free use after binding the logical device to texture image memory.
V, 1, 2, 5 new global environment, G, this value. The abstract operation new global environment takes arguments G, an object, and this value, an object, and returns a global environment record. It performs the following steps when called. Let obj rec be new object environment, G, false, null. Let DCL rec be new declarative environment, null. Let env be a new global environment record. Set env to obj rec. Set env to this value. Set env to DCL rec. Set env to a new empty list. Set env to null. Return env.
It's an excellent question, and this is exactly the kind of deep, grounded understanding that makes Vulkan manageable.
Record.
This is not manageable. This is a joke.
Forms the following steps when called. Let env be a new
Texture image is the handle
to E.
that represents the GP resource.
2024 1
It represents the texture object itself.
records. A private environment record is a
You use it to transition its layout
names based upon the
from undefined to shader read
lections and class expression.
or shader read. Bind an image view to it for sampling in a shader.
Private environment record is associated with a class declaration or class expression. Each time such a class is evaluated, a new private environment record is created to record the private names declared by that class. Each private environment record has the fields defined in Table 23. Table 23. Private environment record field.
It's the target of a copy,
Private environment. A. Private environment record or
specifically it as the target of a copy
record is associated
VK command buffered image
names, a list of private names.
of specify it as the target of a copy. As the target of a copy, VK command buffered image.
Operate upon
Attach it to a descriptor. VK bind image memory.
private environment. Outer privy env.
Destroy it when you're done.
Operation new private environment.
Why does it need to be global?
A private environment record or null, and returns a private environment record. It performs the following steps when called. Let names be a new empty list. Return the private environment record. Outer privy env, names, 2, 1. To resolve private identifier, privy env, identifier. The abstract operation resolve private identifier takes arguments privy env, a private environment record, and identifier.
Yeah, but it doesn't even call this.
Earns a private name. It performs the following steps when called. Let names be privy env. For each private name Pn of names, do if Pn is identifier. Then I return Pn. Let outer privy env be privy env. Assert. Outer privy env is not null. Return resolve private identifier. Outer privy env, identifier. 3 realms. Before it is evaluated, all ECMA script code must be associated with the realm. Conceptually, a realm consists of a set of intrinsic objects, an ECMA script global environment, all of the ECMA script code that is loaded within the scope of that global environment, and other associated state and resources. A realm is represented in this specification as a realm record with the fields specified in Table 24. 52. Copyright sign, ECMA International 2024. Table 24. Realm record fields. Field name, agent signifier, intrinsics, global object, global env, template map, an object or undefined value, an agent signifier, a record whose field names are intrinsic keys and whose values are objects, a global environment record, a list of records with fields, a template literal, parse node, and v, an array.
So after calling bind image memory, the texture image can be destroyed.
Realm, meaning the intrinsic values
Why? This is so dumb.
with fields are a string and a module record.
Oh, this is fucking stupid.
Reachable. The corresponding is also unreachable, and it would be unobservable if an implementation removed the pair from the list. Anything default value is undefined. Note 2 as mentioned in host load imported module 16.2.1.8. Note 1 in realm records is only used when running an import expression in a context where there is no active script or module. Field reserved for use by hosts that need to associate add.
And what the fuck is the point
Template objects are canonicalized separately for each realm using its realm records. Each value is a parse node that is a template
of texture image memory?
corresponding template object that is passed to a tag function, a map from the specifier strings imported by this realm to the solved module record. The list does not contain two different records with the same 9.3.
Yeah, it splits resources.
Create realm takes no arguments and returns a realm record.
It splits resources.
When called,
I'm not gonna say your mom.
perform create intrinsic.
Like images and buffers
Rect to agent sig.
from the memory they use.
Realm rect to undefined. Set realm rect to a new.
This gives you fine control, possible memory, aliasing,
100.
or aliasing, whatever.
The
Better batching, manual memory, budgeting.
and returns unused. It
You, the developer, must manually
set realm rect
create the resource, VK image, VK buffer,
values listed in tables.
query how much memory needs,
Names list
allocate the memory. This is so annoying.
object value fully and recursively populated with property values as defined by the specification of each object in clauses 19 through 28. Or object property values are newly created.
Hold on. Are you kidding me?
Values that are built-in function objects are created by performing create built-in function steps, length, name, slots, realm rec, prototype, where steps is the definition of that function provided by this specification. Name is the initial value of the function's name property. Length is the initial value of the function's length property. Slots is a list of the names, if any, of the function's specified internal slots. And prototype is the specified value of the function's internal slot. The creation of the intrinsics and their properties must be ordered to avoid any dependencies upon objects that have not yet been created. Perform capital A, D, D, capital R, E, S, T, R, I, C, T, E, D.
So they're both binded to device.
C, T, I, O, N, capital P, R, O, P, E, R.
This texture image hold reference to texture image memory.
Return unused, 3.3 set realm global.
Is this like a pointer? And this the value. In this object.
Set realm global object takes arguments realm rec, a realm record, global obj, an object or undefined, and this value, an object or undefined, and returns unused. It performs the following steps when called. If global obj is undefined, then a let intrinsics be realm rec, b set global obj to ordinary object create intrinsics. Assert global obj is an object. If this value is undefined, set this value to global obj. Set realm rec to global obj. Let new global env be new global environ nt. Global ob.
Oh my god, this is ridiculous.
Global env. Return unused. 3.4 set default global.
They all hold freaking. It's a big ass orgy.
Set
It's a big ass pointer orgy. This points to that, which points to this, which points to that.
containing an object or a throw completion. It performs the following steps when called. Let global be realm rec for each property of the global object specified in clause 19. Do a let name be the string value of the property name. B let desk be the fully populated data property descriptor for the property, containing the specified attributes for the property. For properties listed in 19.2, 19.3, or 19.4, the value of the attribute is the corresponding intrinsic object from realm rec. See perform. Define property or throw global name desk return global. Point 4 execution contexts. An execution context is a specification device that is used to track the runtime evaluation of code by an ECMA script implementation. At any point in time, There is at most one execution context per agent that is actually executing code. This is known as the agent's running execution context. All references to the running execution context in this specification denote the running execution context of the surrounding agent. The execution context stack is used to track execution contexts. The running execution context is always the top element of this stack. A new execution context is created whenever control is transferred from the executable code associated with the currently running execution context to an executable code that is not associated with that. 54. Copyright sign, ECMA International 2024. Execution context. The newly created execution context is pushed onto the stack and becomes the running execution context. An execution context contains whatever implementation-specific state is necessary to track the execution progress of its associated code. Each execution context has at least the state components listed in Table 25. Table 25. State components for all execution contexts. Component. Purpose. Code evaluation state. Any state needed to perform, suspend, and resume evaluation of the code associated with this execution context. Function. If this execution context is evaluating the code of a function object, then the value of this component is that function object. If the context is evaluating the code of a script or module, the value is null. Realm. The realm record from which associated code accesses ECMA script resources. Script or module. The module record or script record from which associated code originates. If there is no originating script or module, as is the
I got 1, 2, 3, 4, 5, 6.
did an initialize host
I'm gonna like carefully place each thing inside a section
context
and get it running.
points defined within this spec.
This time it's gonna work
The running execution context
because it has to.
on context
This is like really frustrating.
and commit
I can't take it.
its code. At some later time, a suspended execution context may again become the running execution context and continue evaluating its code at the point where it had previously been suspended. Transition of the running execution context status among execution contexts usually occurs in stack like last in first out manner.
How is nothing already named this?
Script features require non-lethal.
I don't know, at least I don't have to like rename anything.
The value of the realm component of the running execution context is also called the current realm record. The value of the function component of the running execution context is also called the active function object. ECMA script code execution contexts have the additional state components listed in Table 26. Table 26. Additional state components for ECMA script code execution contexts. Component. Purpose. Lexical environment. Identifies the environment record used to resolve identifier references made by code within this execution context. Variable environment. Identifies the environment record that holds bindings created by variable statements within this execution context. Private environment. Identifies the private environment record that holds private names created by class elements and the nearest containing class null if there is no containing class. The lexical environment and variable environment components of an execution context are always environment records. Execution
This looks a whole lot like the other code Jetpack gave me.
components listed in Table 27. ECMA International 2024 155. Table 27. Additional state components for generator execution contexts. In most situations, only the running execution context, the top of the execution context stack, is directly manipulated by algorithms within this specification. Hence, when the terms lexical environment
I gotta pass in. Just gotta pass in this.
they are in reference to those components of the running execution context. An execution context is purely a specification mechanism and need not
Lots of device. The physical device.
a script implementation. It is impossible for ECMA script code to directly access or observe an execution context. 4.1 Get active script or module. The abstract operation get active script or module takes no arguments and returns a script record, a module record, or null. It is used to determine the running script or module based on the running execution context. It performs the following steps when called. If the execution context stack is empty, return null. Let EC be the topmost
And instead, I'm gonna pass in the image.
Component is not null. If no such execution context exists, return null. Otherwise, return X script or module, 4.2 resolve binding. Name, env. The abstract operation resolve binding takes argument name, a string, and optional argument env, an environment record or undefined, and returns either a normal completion containing a reference record or a throw completion. It is used to determine the binding of name. Env can be used to explicitly provide the environment.
The height and width from it, or its property, whatever.
Performs the following steps when called. If env is not present or env is undefined, then a set env to the running execution context's lexical environment. Assert env is an environment record if the source text matched by the syntactic production that is being evaluated is contained in strict mode. Code.
I'll just make these variables
Be false. Return get identifier.
so I don't have to rename anything.
Strict, 4.3 get this environment. The
I just want to get done.
environment takes no arguments and returns an environment record. It finds the environment record that currently supplies the binding of the keyword this. It performs the following steps when called. Let env be the running execution context's lexical environment 2. Repeat. Component purpose. Generator the generator that this execution context is evaluating. 156. ECMA International 2024. Note the result of resolve binding is always a reference record whose field is name. ABCDE. Let exists be env has this binding. If exists is true, return env. Let outer be env. Assert. Outer is not null. Set env to outer. Note the loop in step 2 will always terminate because the list of environments always ends with the global environment which has a this binding. 4.4 resolve this binding. The abstract operation resolve this binding takes no arguments and returns either a normal completion containing an ECMA script language value or a throw completion. It determines the binding of the keyword this using the lexical environment of the running execution context. It performs the following steps when called. Let env rec be get this environment. Return env rec get this binding. 4.5 get new target. The abstract operation get new target takes no arguments and returns an object or undefined.
Then run it.
Using the lexical environment of the running execution context. It performs the following steps when called. Let env rec be get this environment. Assert. env rec has a field. Return env rec, 4.6 get global object. The abstract operation get global object takes no arguments and returns an object. It returns the global object used by the currently running execution context. It performs the following steps when called. 2.5 let current realm be the current realm record. Return current realm, jobs and host operations to enqueue jobs. A job
And of course,
with no parameters that initiates an ECMA script computation when no other ECMA script computation is currently in progress. Scheduled for execution by ECMA script host environments in a particular agent. This specification describes the host hooks host enqueue generic job. Capital H O S T capital E N Q U E U E capital
so no errors. That's a good sign.
A L I Z A T I
Now I just have
capital R E G I S T
steps 2, 3, 4, 5, 6.
job and host enqueue timeout job to schedule jobs. The host hooks in this specification are organized by the additional constraint.
To go. Okay.
Hosts may define additional abstract operations which schedule jobs. Such operations accept a job abstract closure and a realm record or null, as parameters.
I'm really hoping it's gonna work.
Operations schedule the job to be performed at some future time and
I can't stand if it doesn't work. Like, this is really... it's water.
not evaluate ECMA script code. Their implementations must conform to the following requirements. At some future point in time, when there is no running context in the agent for which the job is scheduled and that agent's execution context stack is empty, the implementation must Perform any host-defined preparation steps. Invoke the job abstract closure. Perform any host-defined cleanup steps. After which the execution context stack must be empty. Only one job may be actively undergoing evaluation at any point in time in an agent. Once evaluation of a job starts, it must run to completion before evaluation of any other job starts in an agent. The abstract closure must return a normal completion, implementing its own handling of errors. ECMA International 2024-157. Note: 1. Host environments are not required to treat jobs uniformly with respect to scheduling. For example, web browsers and Node.js treat promise handling jobs as a higher priority than other work. Future features may add jobs that are not treated at such a high priority. At any particular time, script or module, a script record, a module record, or null, is the active script or module if all of the following conditions are true. Get active script or module is script or module. If script or module is a script record or module record, let EC be the topmost execution context on the execution context stack whose script or module component is script or module. The realm component of EC is script or module. At any particular time, an execution is prepared to evaluate ECMA script code if all of the following conditions are true. The execution context stack is not empty. The realm component of the topmost execution context on the execution context stack is a realm record. Particular kinds of jobs have additional conformance requirements. 5.1 Job callback records. A job callback record is a record value used to store a function object and a host-defined value. Function objects that are invoked via a job enquered by the host may have additional host-defined context. To propagate the state, job abstract closures should not capture and call function objects directly. Instead, use host make job callback and host call job callback. Job callback records have the fields listed in Table 28. Table 28. Job callback record fields, 5.2 host make job callback. Callback, the host-defined abstract operation host make job callback takes argument callback, a function object, and returns a job callback record. An implementation of host make job callback must conform to the following requirements. It must return a job callback record whose field is callback. Note: 2 host environments may prepare an execution to evaluate code by pushing execution contexts onto the execution context stack. The specific steps are implementation defined. The specific choice of realm is up to the host environment. This initial execution context and realm is only in use before any callback function is invoked. When a callback function related to a job, like a promise handler, is invoked, the invocation pushes its own execution context and realm. Note the WHATWG-HTML specification, https://html.spec.whatwg.org/ For example, uses the host-defined value to propagate the incumbent settings object for promise callbacks. Field name, value, meaning, callback, a function object, the function to invoke when the job is invoked. Host-defined, anything default value is empty. Field reserved for use by hosts. 158. ECMA International 2024. The default implementation of host make job callback performs the following steps when called. 1. Return the job callback record. Callback. Empty. ECMA script hosts that are not web browsers must use the default implementation of host make job callback, 5.3 host call job callback. Job callback. V. Arguments list. The host-defined abstract operation host call job callback takes arguments job callback, a job callback record, V, an ECMA script language value, and arguments list, a list of ECMA script language values, and returns either a normal completion containing an ECMA script language value or a throw completion. An implementation of host call job callback must conform to the following requirements. It must perform and return the result of call. Job callback. V. Arguments list. The default implementation of host call job callback performs the following steps when called. Assert. Is callable. Job callback. Is true. Return. Call. Job callback. V. Arguments list. ECMA script hosts that are not web browsers must use the default implementation of host call job callback, 5.4 host enqueue generic job. Job. Realm. The host-defined abstract operation host enqueue generic job takes arguments job, a job abstract closure, and realm, a realm record, and returns unused. It schedules job in the realm in the agent signified by realm to be performed at some future time. The abstract closures used with this algorithm are intended to be scheduled without additional constraints, such as priority and ordering. An implementation of host enqueue generic job must conform to the requirements in 9.5, 5 host enqueue promise job, realm. The host-defined abstract operation host enqueue promise job takes arguments job, a job abstract closure, and realm, a realm record or null, and returns unused. It schedules job to be performed at some future time. The abstract closures used with this algorithm are intended to be related to the handling of promises, or otherwise, to be scheduled with equal priority to promise handling operations. An implementation of host enqueue promise job must conform to the requirements in 9.5 as well as the following. If realm is not null, each time job is invoked, the implementation must perform implementation-defined steps such that execution is prepared to evaluate ECMA script code at the time of job's invocation. Let script or module be get active script or module at the time host enqueue promise job is invoked. If realm is not null, each time job is invoked, the implementation must perform implementation-defined steps such that script or module is the active script or module at the time of job's invocation. Jobs must run in the same order as the host enqueue promise job invocations that scheduled them. Note this is called at the time that the callback is passed to the function that is responsible for its being eventually scheduled and run. For example, promise then action, calls make job callback on then action at the time of invoking promise prototype then, not at the time of scheduling the reaction job. Note this requirement means that hosts cannot change the behavior of function objects defined in this specification. ECMA International 2024 159. Note the realm for jobs returned by new promise resolved thenable job is usually the result of calling get function realm on the then function object. The realm for jobs returned by new promise reaction job is usually the result of calling get function realm on the handler if the handler is not undefined. If the handler is undefined, realm is null. For both kinds of jobs, when get function realm completes abnormally, that is called on a revoked proxy. Realm is the current realm record at the time of the get function realm call. When the realm is null, no user ECMA script code will be evaluated and no new ECMA script objects, for example, error objects, will be created. The WHATWG-HTML specification, https://html.spec.whatwg.org/ For example, uses realm to check for the ability to run script and for the entry, https://html.spec.whatwg.org/ #entry concept, 5.6 host enqueue timeout job, realm, milliseconds. The host-defined abstract operation host enqueue timeout job takes arguments timeout job, a job abstract closure, realm, a realm record, and milliseconds, a non-negative finite number, and returns unused. It schedules timeout job in the realm in the agent signified by realm to be performed after at least milliseconds. An implementation of host enqueue timeout job must conform to the requirements in 9.5, 9.6 initialize host-defined realm. The abstract operation initialize host-defined realm takes no arguments and returns either a normal completion containing unused or a throw completion. It performs the following steps when called. Let realm be create realm. Let new context be a new execution context. Set the function of new context to null. Set the realm of new context to realm. Set the script or module of new context to null. Push new context onto the execution context stack. New context is now the running execution context. If the host requires use of an exotic object to serve as realm's global object, let global be such an object created in a host-defined manner. Otherwise, let global be undefined, indicating that an ordinary object should be created as the global object. If the host requires that this binding in realm's global scope return an object other than the global object, let this value be such an object created in a host-defined manner. Otherwise, let this value be undefined, indicating that realms global. This binding should be the global object. Perform set realm global object. Realm global. This value 0. Let global obj be. Set default global bindings. Realm 1. Create any host-defined global object properties on global obj. 2. Return unused. 0.7 agents. An agent comprises a set of ECMA script execution contexts, an execution context stack, a running execution context, an agent record, and an executing thread. Except for the executing thread, the constituents of an agent belong exclusively to that the agent. An agent's executing thread executes algorithmic steps on the agent's execution contexts independently of other agents, except that an executing thread may be used as the executing thread by multiple agents, provided none of the agents sharing the thread have an agent record whose field is true. Note 1. Some web browsers share a single executing thread across multiple unrelated tabs of a browser window. For example, 60, copyright sign, ECMA International 2024, while an agent's executing thread is executing algorithmic steps. The agent is the surrounding agent for those steps. The steps use the surrounding agent to access the specification level execution objects held within the agent, the running execution context, the execution context stack, and the agent records fields. An agent signifier is a globally unique opaque value used to identify an agent. Table 29, agent record fields. Field name, value, meaning, little endian, a boolean. The default value computed for the is little endian parameter when it is needed by the algorithm's get value from buffer and set value in buffer. The choice is implementation defined and should be the alternative that is most efficient for the implementation. Once the
Now it's step 2, I guess.
agent can block or not. Signifier. An agent signifier uniquely identifies the agent within its agent cluster. Is lock-free 1.
This sucks.
Operations on 1 byte values are lock fr, ee. False otherwise. Is lock-free 2. A boolean. True if atomic operations on 2 byte values are lock-free. False otherwise. Is lock-free 8. A boolean. True if atomic operations on 8 byte values are lock-free. False otherwise. Candidate execution. A. Candidate execution record. See the memory model. Kept alive. A list of either objects or symbols. Initially a new empty list, representing the list of objects and or symbols to be kept alive until the end of the current job. Once the values of and have been observed by any agent in the agent cluster, they cannot change. Note 2. The values of and are not necessarily determined by the hardware, but may also reflect implementation choices that can vary over time and between ECMA script implementations. There is no field. 4-byte atomic operations are always log-free. In practice, if an atomic operation is implemented with any type of lock, the operation is not lock-free. Lock-free does not imply wait-free. There is no upper bound on how many machine steps may be required to complete a lock-free atomic operation. That an atomic access of size n is lock-free does not imply anything about the perceived atomicity of non-atomic accesses of size n.
Yeah, but it's like, here, create a buffer with blah blah blah.
Sequence of several separate memory accesses. See read shared memory.
And this with this. Like, that's not helpful.
International 2024 161. Note 3. An agent is a specification mechanism and need not correspond to any particular artifact of an ECMA script implementation. 7.1 Agent signifier. The abstract operation agent signifier takes no arguments and returns an agent signifier. It performs the following steps when called. Let AR be the agent record of the surrounding agent. Return AR, 7.2 Agent can suspend. The abstract operation agent can suspend takes no arguments and returns a boolean. It performs the following steps when called. 2.8 Let AR be the agent record of the surrounding agent. Return AR, agent clusters. Note in some environments it may not be reasonable for a given agent to suspend. For example, in a web browser environment, it may be reasonable to
What's a staging buffer?
event how
Is that a duplicate copy of
threads to suspend
the image data?
the maximal set of agent.
I hate.
Every agent belongs to exactly one agent.
Oh, it's so many stupid
field in their respective agent records. All agents within a cluster must have the same values for the field in their respective agent records. Similarly for the field, all agents within a cluster must have different for the field.
It acts as an intermediary, allowing data to be written from the CPU to a memory location accessible by the GPU,
Cooperation. If the embedding does so, it must not
and then copied to the final GPU. So is there an extra copy
within different
between?
By unspecified means. At a minimum, the backing memory for shared array buffers can be shared among the agents in the cluster. There may be agents that can communicate by message passing that cannot share memory. They are never in the same agent cluster. Note too, the agents in a cluster need not all be alive at some particular point in time. If agent A creates another agent B, after which A terminates and B creates agent C, the three agents are in the same cluster if A could share some memory with B and B could share some memory with C. Note 3, if different agents within an agent cluster have different values of it becomes hard to use shared memory for multi-byte data. 62. Copyright sign. ECMA International 2024. Note 4. The purpose of the preceding restriction is to avoid a situation where an agent deadlocks or starves because another agent has been deactivated. For example, if an HTML shared worker that has a lifetime independent of documents in any windows were allowed to share memory with the dedicated worker of such an independent document, and the document and its dedicated worker were to be deactivated while the dedicated worker holds a lock, say, the document is pushed into its Windows history, and the shared worker then tries to acquire the lock. Then the shared worker will be blocked until the dedicated worker is activated again, if ever. Meanwhile, other workers trying to access the shared worker from other windows will starve. The implication of the restriction is that it will not be possible to share memory between agents that don't belong to the same suspend-wake collective within the embedding. An embedding may terminate an agent without any of the agent's cluster's other agents' prior knowledge or cooperation. If an agent is terminated not by programmatic action of its own or of another agent in the
What is a staging buffer?
cluster, then the embedding must choose one of two strategies: either terminate all the agents in the cluster, or provide reliable APIs that allow the agents in the cluster to coordinate so that
Is it
the cluster will be able to detect the termination, with the termination data containing enough information to identify the agent that was terminated. Each
an array of pixel bytes?
and values transitively reachable from them belong to exactly one agent cluster. Candidate execution record, shared data block, waitlist record, prior
Or a handle?
of any ECMA script code by any agent in a cluster. The field of the agent record for all agents in the cluster is set to the initial candidate execution. The initial candidate execution is an empty candidate execution whose field is a list containing, for each agent, an agent events record whose field is that agent's agent signature.
And does it physically occupy
5 examples of that type of termination are operating systems or
user space in the C program or GPU space?
using an agent that is running in process with the other agent's whimper. Agent resource accounting indicates that the agent is runaway. Note 6. All agents in an agent cluster share the same candidate execution in its agent records field. The candidate execution is a specification mechanism used by the memory model. Note 7. An agent cluster is a specification mechanism and need not correspond to any particular artifact of an ECMA script implementation. Point 9. Forward progress. For an agent to make forward progresses for it to perform an evaluation step according to this specification, an agent becomes blocked when its running execution context waits synchronously and indefinitely for an external event. Only agent
It acts as a bridge between image data.
this sense. An unblocked agent is one that is not blocked. Implementation
Your X-frame frame buffer
blocked agent
to GPU VK image texture.
press in a set of agents that share an executing thread.
Oh my god, that's so stupid.
Progress. ECMA International 2.
Why does it need so many extra copies of every little thing?
Unblocked except by
Why?
blocking. 0.10 processing model of
This is dumb.
registry targets 9.10. 1 objectives. This specification does not make any guarantees that any object or symbol will be garbage collected. Objects or symbols which are not live may be released after long periods of time, or never at all. For this reason, this specification uses the term may when describing behavior triggered by garbage collections
Wait, what?
of weak refs and finalization registries is based on two operations which happen at particular points in time. When weak ref prototype derf is called, the referent, if undefined is not returned, is kept alive so that subsequent synchronous accesses also return the same value. This list is reset when synchronous work is done using the clear-kept objects abstract registered with
It says
unreachable, a call of the final
it doesn't live in your apps normal heap stack.
after synchronous ECMA script execution.
It's Vulkan managed.
Cleanup is performed with the
GPU mappable memory region.
of these actions. Clear-kept
It says it lets you get a void so your C code can write to it. When you call unmapped memory, Vulkan can transfer it to real GPU memory.
and defers the scheduling of clear-kept objects and cleanup finalization registry to the host environment. Some ECMA script implementations include garbage collector implementations which run in the background, including when ECMA script is idle. Letting the host environment schedule cleanup finalization registry allows it to resume ECMA script execution in order to run finalizer work, which may free up held values, reducing overall memory usage. 10.2 Liveness. For some set of objects and or symbols, S a hypothetical weak ref oblivious execution with respect to S is an execution whereby the abstract operation weak ref derf of a weak ref whose referent is an element of S always returns undefined. This, along with the liveness guarantee in the memory model, ensures that all sec.cst writes note eventually become observable to all agents. Note 1 weak ref obliviousness, together with liveness, capture two notions. 1. That a weak ref itself does not keep its referent alive.
So the staging buffer
Not imply that a value is live. To be concrete, if determining V's liveness depends on determining the liveness of a weak ref referent, R's liveness cannot assume V's liveness, which would be circular reasoning. Note 2 weak ref obliviousness is
it physically only ever occupies GPU VRAM.
then a weak ref referent in a cycle will be considered live even though its identity is only observed via other weak ref reference in the cycle. Note 3 colloquially, we say that an individual object or symbol is live if every set containing it is live. At any point during evaluation, a set of objects and or
And
if either of the following conditions is met.
it is not.
Any agents list 164. ECMA International 2024, there exists a valid future hype
C program address space,
with respect to S that observes the
which will be copied to GPU VRAM
is live if its identity is
after
ref means. A value's identity may be observed by observing a strict equality comparison or observing the value being used as key in a map. Note 5. Presence of an object or a symbol in a field, an internal slot, or a property does not.
VK unmap memory is called.
Example, if the value in question is never passed back to the program, then it cannot be observed. This is the case for keys in a weak map, members of a weak set, as well as the infields of a finalization registry cell record. The above definition implies that, if a key in a weak map is not live, then its corresponding value is not necessarily live either. Note 6 liveness is the lower bound for guaranteeing which weak refs engines must not empty. Liveness is
Oh, this is a crucial detail, of course.
in practice.
The staging buffer is intentionally allocated in host visible memory, not peer. So that's a lie.
At any time, if a set of objects and or symbols S does not live, an ECMA script implementation may
It's system RAM. Oh my god, this is so dumb.
and value of S. Do a for each weak ref such that ref is value. Do I set ref to empty. B for each finalization registry FG such that FG contains a record cell such that cell is value. Do I set cell to empty. 2. Optionally, perform capital H O S T capital E N Q U, E, U, E, capital F, I, N, A, L, I, Z, A, T, I, O, N, capital R, E, G, I, S, T, R, F, G. C for each weak map such that map contains a record R such that R value do. I set R to
Okay, why can't...
set such that set contains value do. I replace the element of set whose value is value with an element whose value is empty. ECMA International 2024 165.
I just use
The definition of
the X11 copy.
clause prescribes optimizations that an implementation may apply regarding weak refs. It is possible to access an object without observing its identity. Optimizations such as dead variable elimination and scalar replacement on properties of non-escaping objects whose identity is not observed are allowed. These optimizations are thus allowed to observably empty weak refs that point to such objects. On the other hand, if an object's identity is observable, and that object is in the internal slot of a weak ref, optimizations such as rematerialization that observably empty the weak ref are prohibited, because calling capital H, O, S, T, capital E, N, Q, U, E, U, E, capital F, I, N, A, L, I, Z, A, T, I, O, N, capital R, E, G, I, S, T, R, is optional. Registered objects in a finalization registry do not necessarily hold that finalization registry live. Implementations may omit finalization registry callbacks for any reason. For example, if the finalization registry itself becomes dead, or if the application is shutting down. Note 2.
If image data were intentionally mapped,
Symbols. If an implementation chooses a non
were intentionally placed at the address to be mapped,
mission requires that it empties weak refs for all values in this simultaneously. In other words,
at an address that ends up mapping it to the location of stage buffer, it would already be the stage buffer, correct?
execution that observes the value of v, 10.4 host hooks, 1041, capital H, O, S, T, capital E, N.
If image data were intentionally at an address that is mapped to the location of stage buffer, it would already be the stage buffer. And I'm saying correct, question mark.
R, E, G, I, S.
Theoretically, yes.
Finalization registry. The
You can't do that with the Vulkan as it exists today.
H.
If in theory, you could force image data to point exactly to the memory returned by VKMap memory
U.
on a staging buffer, Vulkan allocated in host visible memory, then yes, it would be like writing directly into the staging buffer. No need to memcopy.
G. I.
That's what you'd want.
R. Takes argument final
Pointer, device, staging buffer.
and returns unused. Let cleanup job be a new job abstract closure with no parameters that captures finalization registry and performs the following steps when called. Let cleanup result be completion. Cleanup finalization registry. Finalization registry. If cleanup result is an abrupt completion, perform any host-defined steps for reporting the error. Return unused. An implementation of capital H, O, S, T, capital E, N, Q, U, E, U, E, capital F, I, N, A, L, I, Z, A, T, I, O, N, capital R, E, G.
So it's not possible to flip between two image data buffers.
And future time, if possible. It must also conform to the requirements in 9.
So only one API uses it at a time.
The abstract operation clear-kept objects takes no arguments and returns unused. ECMA script implementations are expected to call clear-kept objects when a synchronous sequence of ECMAs.
Yes, you can flip between multiple XImage buffers, each with their own image data backing memory, so that one API touches one buffer at a time. That is possible and a common technique.
And 24.
What you're describing, you're asking, can I create two or more X images, each with their own memory, and alternate between them?
Object or
So that Vulkan reads one, while Xshim writes to the other.
let agent
Yes, that works. It is often used to avoid stalls in race conditions.
used. 0.13 Cleanup finalization registry. Finalization registry. The abstract operation cleanup finalization registry takes argument finalization registry, a finalization registry, and returns either a normal completion containing unused or a throw completion. It performs the following steps when called. Assert. Finalization registry hasn't internal slots. Let callback be finalization registry. While finalization registry contains a record cell such that cell is empty, an implementation may perform the following steps. A choose any such cell. B remove cell from finalization registry. C perform. Host call job callback. Callback. Undefined. Cell. Return unused. 0.14 can be held weekly. V. The abstract operation can be held weekly takes argument V, an ECMA script language value, and returns a boolean. It returns true if and only if V is suitable for use as a weak reference. Only values that are suitable for use as a weak reference may be a key of a weak map, an element of a weak set, the target of a weak ref, or one of the targets of a finalization registry. It performs the following steps when called. If V is an object, return true. If V is a symbol and key for symbol, V is undefined, return true. Return false. Note when the abstract operation add to kept objects is called with a target, object, or symbol, it adds the target to a list that will point strongly at the target until clear kept objects is called. Note a language value without language identity can be manifested without prior reference and is unsuitable for use as a weak reference. A symbol value produced by symbol 4, unlike other symbol values, does not have language identity and is unsuitable for use as a weak reference. Well-known symbol S are likely to never be collected, but are nonetheless treated as suitable for use as a weak reference because they are limited in number and therefore manageable by a variety of implementation approaches. However, any value associated to a well-known symbol in a live weak map is unlikely to be collected and could leak memory resources in implementations. 0. Ordinary and exotic objects behaviors. 0.1 Ordinary object internal methods and internal slots. All ordinary objects have an internal slot called. The value of this internal slot is either null or an object and is used for implementing inheritance. Assume a property named P is missing from an ordinary object but exists on its object. If P refers to a data property on the object,
I'll do this later.
as if P was a property of O, if P refers to a writable data property on the
I just gotta get it working first, I guess.
67. Object. Set access of P on O creates a new data property named P on O if P refers to a non-writable data property on the object. Set access of P on O fails. If P refers to an accessor property on the object, the accessor is inherited by O for both get access and set access. Every ordinary object has a Boolean valued internal slot which is used to fulfill the extensibility related internal method invariance specified in 6, 1, 7, 3. Namely, once the value of an object's internal slot has been set to false, it is no longer possible to add properties to the object, to modify the value of the object's internal slot, or to subsequently change the value of to true. In the following algorithm descriptions, assume O is an ordinary object, P is a property key value, V is any ECMA script language value, and ESC is a property descriptor record. Each ordinary object internal method delegates to a similarly named abstract operation. If such an abstract operation depends on another internal method, then the internal method is invoked on O rather than calling the similarly named abstract operation directly. These semantics ensure that exotic objects have their overridden internal methods invoked when ordinary object internal methods are applied to them. 0, 1, 1. The internal method of an ordinary object O takes no arguments and returns a normal completion containing either an object or null. It performs the following steps when called. Return ordinary get prototype of O1011. One ordinary get prototype of O. The abstract operation ordinary get prototype of takes argument O, an object, and returns an object.
Turn all this stuff off.
Following steps when called. Return O1012. V. The internal
Just use whatever the fuck it says.
an object or null, and returns a normal completion containing a boolean. It performs the follow-E and G steps when called. Return ordinary set prototype of O. V10. 1 ordinary set prototype of O. V. The abstract operation ordinary set prototype of takes arguments O, an object, and V, an object or null, and returns a boolean. It performs the following steps when called. Let current be O if same value, V, current, is true. Return true. Let extensible be O if extensible is false. Return false. Let bev. Let done be false. Repeat. While done is false if P is null. Then I set done to true. Be else if same value, P, O, is true. Then I return false. See else. If P is not the ordinary object internal method defined in 1011. Set done to true. 2. Else. Set P to P, set O to V, return true. 68. ECMA International 2024. Note the loop in step 7 guarantees that there will be no circularities in any prototype chain that only includes objects that use the ordinary object definitions for int 0, 1, 3. The internal method of an ordinary object O takes no arguments and returns a normal completion containing a boolean. It performs the following steps when called. Return ordinary is extensible. 1, 0, 1, 3. 1 ordinary is extensible. O. The abstract operation ordinary is extensible takes argument O, an object, and returns a boolean. It performs the following steps when called. Return O10, 1, 4. The internal method of an ordinary object O takes no arguments and returns a normal completion containing true. It performs the following steps when called. Return ordinary prevent extensions. 1, 0, 1, 4. 1 ordinary prevent extensions. O. The abstract operation ordinary prevent extensions takes argument O, an object, and returns true. It performs the following steps when called. Set O to false. Return true. 0, 1, 5. P. The internal method of an ordinary object O takes argument P, a property key, and returns a normal completion containing either a property descriptor or undefined. It performs the following steps when called. Return ordinary get own property. O. P10, 1, 5. 1 ordinary get own property. O. P. The abstract operation ordinary get own property takes arguments O, an object, and P, a property key, and returns a property descriptor or undefined. It performs the following steps when called. If O does not have a known property with key P, return undefined. Let D be a newly created property descriptor with no fields. Let X be O's own property whose key is P. If X is a data property, then A set D to the value of X's attribute. B set D to the value of X's attribute. Else, A assert X is an accessor property. B set D attribute. C set D value of X's. ECMA International 2024 169. 6. Set D to the value of X's attribute. Set D to the value of X's attribute. Return D 0, 1, 6. P. Desk. The internal method of an ordinary object O takes arguments P, a property key, and desk, a property descriptor, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Return ordinary define known property. O. P. Desk 1, 0, 1, 6. 1 ordinary define known property. O. P. Desk. The abstract operation ordinary define known property takes arguments O, an object, P, a property key, and desk, a property descriptor, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Let current be O. P. Let extensible be. Is extensible. O. Return. Capital V. A. L. I. D. A. T. E. Capital A. N. D. Capital A. P. P. L. Y. Capital P. R. O. P. E. R. T. Y. Capital D. E. S. C. R. I. O. P. Extensible. Desk. Current. 0. 1. 6. 2 is compatible property descriptor. Extensible. Desk. Current. The abstract operation is compatible property descriptor takes arguments extensible. A boolean. Desk. A property descriptor. And current. A property descriptor or undefined. And returns a boolean. It performs the following steps when called. Return. Capital V. A. L. I. D. A. T. E. Capital A. N. D. Capital A. P. P. L. Y. Capital P. R. O. P. E. R. T. Y. Capital D. E. S. C. R. I. Undefined. Extensible. Desk. Current 1 0 1 6 3. Capital V. A. L. I. D. A. T. E. Capital A. N. D. Capital A. P. P. L. Y. Capital P. R. O. P. E. R. T. Y. Capital D. E. S. C. R. I. O. P. Extensible. Desk. Current. The abstract operation. Capital V. A. L. I. D. A. T. E. Capital A. N. D. Capital A. P. P. L. Y. Capital P. R. O. P. E. R. T. Y. Capital D. E. S. C. R. I. Takes arguments O. An object or undefined. P. A property key. Extensible. A boolean. Desk. A property descriptor. And current. A property descriptor or undefined. And returns a boolean. It returns true if and only if desk can be applied as the property of an object with specified extensibility and current property current while upholding invariance. When such application is possible and O is not undefined, it is performed for the property named P, which is created if necessary. It performs the following steps when called. Assert. Is property key P is true if current is undefined. Then, if extensible is false, return false. B if O is undefined, return true. C if is accessor descriptor, desk, is true. Then, I create an own accessor property named P of object O whose and attributes are set to the value of the corresponding field in desk if desk has that field, or to the attribute's default value otherwise. T else, I create a known data property named P of object O whose and configurable attributes are set to the value of the corresponding field in desk if desk has that field, or to the attribute's default value, otherwise you return true. Assert. Current is a fully populated property descriptor. If desk does not have any fields, return true. If current low is false, then 70. ECMA International 2024. ABC. If desk has a field and desk is true, return false. If desk has a field and desk is not current, return false. If is generic descriptor, desk, is false and is accessor descriptor, desk, is not is accessor descriptor, current, return false. D if is accessor descriptor, current, is true, then I if desk has a current. 2. If desk has a current. E else if current is false, then I if desk has a field and desk is true, return false. 2. If desk has a field and same value, desk, current, is false, return false. If O is not undefined, then if is data descriptor, current, is true and is accessor descriptor, desk, is true, then I if desk has a field, let configurable be desk, else let configurable be current. 2. If desk has a field, let enumerable be desk, else let enumerable be current. 3. Replace the property named P of object O with an accessor property whose and attributes are set to configurable and enumerable.
Does it still run?
Attributes are set to the value of the corresponding field in desk if desk has that field, or to the attribute's default value otherwise. B else if is accessor descriptor. Current is true and is data descriptor. Desk is true. Then, I if desk has a field, let configurable be desk, else let configurable be current. 2. If desk has a field, let enumerable be desk, else let enumerable be current. 3. Replace the property named P of object O with a data property whose and enumerable attributes are set to configurable and enumerable, respectively, and whose and attributes are set to the value of the corresponding field in desk if desk has that field.
Okay, it still makes a triangle.
Else,
So nothing's broken yet.
corresponding attribute of the property named P of object O to the value of the field 7. Return true 0, 1, 7, P. The internal method of an ordinary object O takes argument P, a property key, and returns either, and
There's like a bunch of stuff with the same name.
it performs the following.
I carefully renamed everything. So it should be good.
Area has property O, P, 0, 1, 7, 1. Ordinary has property O, P. The abstract operation ordinary has property takes argument so, an object, and P, a property key, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps. W. Hen called. Let has own be. O. P. If his own is not undefined, return true. Let parent be. O. If parent is not null, then a return parent. P5. Return false. 0, 1, 8. The return. Ordinary get. O. P. Receiver. ECMA International 2024 171 10 1.
Alright, so now I got step 3, I guess.
E. Receiver. The abstract operation ordinary get takes argument so, an
It needs to work after this. It needs to, because I can't take it.
and returns either a normal completion containing an ECMA script language value or a throw completion. It performs the following steps when called. Let desk be. O. P. If desk is undefined, then a let parent be. O. B. If parent is null, return undefined. C. Return parent. If is data descriptor, desk, is true, return desk. Assert, is accessor descriptor, desk, is true. Let getter be desk. If getter is undefined, return undefined. Return. Call, getter, receiver 0, 1, 9. The return. Ordinary set. O. P. V. Receiver 1, 0, 1, 9. 1. Ordinary set. O. P. V. Receiver. The abstract operation ordinary set takes argument so, an object, P, a property key, V, an ECMA script language value, and receiver, an ECMA script language value, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Let own desk be. O. P. Return. Ordinary set with own descriptor. O. P. V. Receiver. Own desk. 0, 1, 9. 2. Ordinary set with own descriptor. O. P. V. Receiver. Own desk. The abstract operation ordinary set with own descriptor takes argument so, an object, P, a property key, V, an ECMA script language value, receiver, an ECMA script language value, and own desk, a property descriptor or undefined, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. If own desk is undefined, then a let parent be. O. B. If parent is not null, then I return parent. I set own desk to the property descriptor, undefined, true, true, true. If is data descriptor, own desk, is true, then 72. ECMA International 2024 ABCD E. If own desk is false, return false. If receiver is not an object, return false. Let existing descriptor be. Receiver, P. If existing descriptor is not undefined, then if is access a descriptor, existing descriptor, is true, return false. 2. If existing descriptor is false, return false. 3. Let value desk be the property descriptor, v. I've. Return. Receiver, P. Value desk, else. I assert. Receiver does not currently have a property P. 2. Return. Create data property. Receiver, P. V. Assert. Is access a descriptor? Own desk. Is true. Let setter be own desk. If setter is undefined, return false. Perform. Call. Setter. Receiver, V. Return true. 0, 1, 1, 0. P. The internal method of an ordinary object O takes argument P, a property key, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Return. Ordinary delete. O. P10. 1, 1, 0, 1 ordinary delete. O. P. The abstract operation ordinary delete takes arguments O, an object, and P, a property key, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Let desk be. O. P. If desk is undefined, return true. If desk is true, then A remove the own property with name P from O. B return true. Return false. 0, 1, 1, 1. The internal method of an ordinary object O takes no arguments and returns a normal completion containing a list of property keys. It performs the following steps when called. Return ordinary own property keys, O1, 0, 1, 1, 1, 1 ordinary own property keys. O. The abstract operation ordinary own property keys takes argument O, an object, and returns a list of property keys. It performs the following steps when called. Let keys be a new empty list. For each own property key P of O such that P is an array index, in ascending numeric index order, do A append P to keys. For each own property key P of O such that P is a string and P is not an array index, in ascending chronological order of property creation, do A append P to keys. For each own property key P of O such that P is a symbol, in ascending chronological order of property creation, do A append P to keys. 5. Return keys. 0, 1, 1, 2. Ordinary object create. Proto. Additional internal slots list. The abstract operation ordinary object create takes argument proto an object or null, and optional argument additional internal slots list, a list of names of internal slots, and returns an object. It is used to specify the runtime creation of new ordinary objects. Additional internal slots list contains the names of additional internal slots. ECMA International 2024 173. That must be defined as part of the object. Beyond and extensible. If additional internal slots list is not provided, a new empty list is used. It performs the following steps when called. Let internal slots list be. If additional internal slots list is present, set internal slots list to the list concatenation of internal slots list and additional internal slots list. Let O be make basic object. Internal slots list. Set O to proto. Return O. 0, 1, 1, 3. Ordinary create from constructor. Constructor. Intrinsic default proto. Internal slots list. The abstract operation ordinary create from constructor takes arguments constructor, a constructor, and intrinsic default proto, a string, and optional argument internal slots list, a list of names of internal slots, and returns either a normal completion containing an object or a throw completion. It creates an ordinary object whose value is retrieved from a constructor's prototype property, if it exists. Otherwise, the intrinsic named by intrinsic default proto is used for internal slots list contains the names of additional internal slots that must be defined as part of the object. If internal slots list is not provided, a new empty list is used. It performs the following steps when called. Assert. Intrinsic default proto is this specification's name of an intrinsic object. The corresponding object must be an intrinsic that is intended to be used as the value of an object. Let proto be. Get prototype from constructor. Constructor. Intrinsic default proto. If internal slots list is present, let slots list be internal slots list, else, let slots list be new empty list. Return ordinary object create, proto, slots list, 0, 1, 1 4 get prototype from constructor, constructor, intrinsic default proto. The abstract operation get prototype from constructor takes arguments constructor, a function object, and intrinsic default proto, a string, and returns either a normal completion containing an object or a throw completion. It determines the value that should be used to create an object corresponding to a specific constructor. The value is retrieved from the constructor's prototype property, if it exists. Otherwise, the intrinsic named by intrinsic default proto is used for. It performs the following steps when called. Assert. Intrinsic default proto is this specification's name of an intrinsic object. The corresponding object must be an intrinsic that is intended to be used as the value of an object. Let proto be. Get. Constructor. Prototype. If proto is not an object, then a let realm be. Get function realm. Constructor. Be set proto to realm's intrinsic object named intrinsic default proto. Return proto. Note, although ordinary object create does little more than call make basic object, its use communicates the intention to create an ordinary object, and not an exotic one. Thus, within this specification, it is not called by any algorithm that subsequently modifies the internal methods of the object in ways that would make the result non-ordinary. Operations that create exotic objects invoke make basic object directly. 174, ECMA International 2024. Note, if constructor does not supply a value, the default value that is used is obtained from the realm of the constructor function rather than from the running execution context. The 10th of January 2015 require internal slot. Oh, internal slot. The abstract operation require internal slot takes argument so, an ECMA script language value, and internal slot, an internal slot name, and returns either a normal completion containing unused or a throw completion. It throws an exception unless O is an object and has the given internal slot. It performs the following steps when called. If O is not an object, throw a type error exception. If O does not have an internal slot, throw a type error exception. Return unused. 0.2 ECMA script function objects. ECMA script function objects encapsulate parameterized ECMA script code closed over a lexical environment and support the dynamic evaluation of the code. An ECMA script function object is an ordinary object and has the same internal slots and the same internal methods as other ordinary objects. The code of an ECMA script function object may be either strict mode code, 1, 1, 2, 2, or non-strict code. An ECMA script function object whose code is strict mode code is called a strict function. One whose code is not strict mode code is called a non-strict function. In addition to an ECMA script function objects also have the internal slots listed in Table 30. Table 30. Internal slots of ECMA script function objects. Internal slot. Type. Description. Environment. An environment record. The environment record that the function was closed over. Used as the outer environment when evaluating the code of the function. Private environment. A. Private environment record or null. The private environment record for private names that the function was closed over null if this function is not syntactically contained within a class. Used as the outer private environment for inner classes when evaluating the code of the function. Formal parameters. A parse node. The root parse node of the source text that defines the function's formal parameter list. ECMA script code. A parse node. The root parse node of the source text that defines the function's body. Construct kind. Base or derived, whether or not the function is a derived class constructor. Realm. A realm record. The realm in which the function was created and which provides any intrinsic objects that are accessed when evaluating the function. Script or module. A script record or a module record. The script or module in which the function was created. This mode, lexical, strict, or global, defines how this references are interpreted within the formal parameters and code body of T. He function. Lexical means that this refers to the this value of a lexically enclosing function. Strict means that the this value is used exactly as provided by an invocation of the function. Global means that this value of undefined or null is interpreted as a reference to the global object. and any other this value is first passed to object. Copyright sign, ECMA International 2024, 75. Table 30, internal slots of ECMA script function objects. Continued. Internal slot. Type. Description. Strict. A boolean. True if this is a strict function. False if this is a non-strict function. Home object. An object. If the function uses super, this is the object whose provides the object where super property lookups begin. Source text. A sequence of Unicode code points. The source text that defines the function. Fields. A list of class field definition records. If the function is a class, this is a list of records representing the non-static fields and corresponding initializers of the class. Private methods. A list of private elements. If the function is a class, this is a list representing the non-static private methods and accessors of the class. Class field initializer name. A string, a symbol, a private name, or empty. If the function is created as the initializer of a class field, the name to use for named evaluation of the field. Empty otherwise is class constructor. A boolean indicates whether the function is a class constructor. If true, invoking the functions will immediately throw a type error exception. All ECMA script function objects have the internal method defined here. ECMA script functions that are also constructors in addition have the internal method 0, 2, 1. This arguments list. The internal method of an ECMA script function object f takes arguments this argument, an ECMA script language value, and arguments list, a list of ECMA script language values, and returns either a normal completion containing an ECMA script language value or a throw completion. It performs the following steps when called. Let caller context be the running execution context. Let callee context be prepare for ordinary call. F. Undefined. Assert. Callee context is now the running execution context. If f is true, then a let error be a newly created type error object. B note. Error is created in callee context with f's associated realm record. C. Remove callee context from the execution context stack and restore caller context as the running execution context. D. Return throw completion. Error. Perform ordinary call bind this. F. Callee context. This argument. Let result be completion. Ordinary call evaluate body. F. Arguments list. Remove callee context from the execution context stack and restore caller context as the running execution context. If result is a return completion, return result. ALU. Return of abrupt. Result. 0. Return undefined. 176. ECMA International 2024. Note when callee context is removed from the execution context stack in step 7 it must not be destroyed if it is suspended and retained for later resumption by an accessible generator. 1 0 2 1 1 Prepare for ordinary call. F. New target. The abstract operation prepare for ordinary call takes arguments f, an ECMA script function object, a new target, an object or undefined, and returns an execution context. It performs the following steps when called. Let caller context be the running execution context. Let callee context be a new ECMA script code execution context. Set the function of callee context to f. Let callee realm be f. Set the realm of callee context to callee realm. Set the script or module of callee context to f. Let local env be new function environment. F. New target. Set the lexical environment of callee context to local env. Set the variable environment of callee context to local env. 0. Set the private environment of callee context to f. 1. If caller context is not already suspended, suspend caller context. 2. Push callee context onto the execution context stack. Callee context is now the running execution context. 3. Note. Any exception objects produced after this point are associated with callee realm. 4. Return callee context. 0, 2, 1. 2 Ordinary call bind this. F. Callee context. This argument. The abstract operation ordinary call bind this takes arguments f, an ECMA script function object, callee context, an execution context, and this argument, an ECMA script language value, and returns unused. It performs the following steps when called. Let this mode be f. If this mode is lexical, return unused. Let callee realm be f. Let local env be the lexical environment of callee context. If this mode is strict, then let this value be this argument 6. Else, if this argument is either undefined or null, then
Okay, so, like,
assert global env.
the word, the function, mem, copy. It means memory, copy. It means physical copy for an array of bytes of whatever size that's passed in. Why are there so many copies of the same damn buffer?
Env bind this value 0.
For the staged memory, whatever that's called, there's a copy here. There's a mem copy. It's a physical loop that's usually optimized really good. So like it's a physical loop.
A list of ECF.
It's a function. It copies bytes. It's copying the frame buffer to location.
For an abrupt completion. It is
And that's CPU side.
function body. Function
That's step 2. And then step 3,
function body.
there's another one.
Function object and argument.
Another mem copy.
Return. Evaluate concise body of concise body.
Why does
177. Generate a body. Function body. Return.
I don't understand.
Generate a body of generate.
How is this stuff so incompetent? Why does it have to make 4 or 5 copies of the same thing from A to B to A to B? I don't understand. Why is this code, this API, this whole thing is so pathetic?
List. A concise body. Expression body. Return.
It's copying a whole frame buffer.
Body with arguments.
4K is a lot bigger than 1080.
Expression. Assert.
And this is a shit-ass first gen i7. It can't handle all this.
Definition. Assign.
It can, but it eats up all my CPU power.
B. Named evaluation of initial.
This is so frustrating.
Else. Alert.
I'm just gonna copy everything how it is. And if it works, it works. Later on, I'll figure out how to get rid of all the copies, because this is ridiculous.
Empty. Class static block body. Class static block statement list.
Oh my god, this is so ridiculous.
Turn. Evaluate class static block body of class static block body with argument function object 0, 2, 1. For ordinary call evaluate body F. Arguments list. The abstract operation ordinary call evaluate body takes arguments F, an ECMA script function object, and arguments list, a list of ECMA script language values, and returns either a normal completion containing an ECMA script language value or an abrupt completion. It performs the following steps when called. Return. Evaluate body of F with arguments F and arguments list 1, 0, 2, 2. Arguments list. New target. The internal method of an ECMA script function object F takes arguments list, a list of ECMAs.
Okay, maybe not. Maybe there's only one copy.
A constructor.
Chatbot just keeps changing. Man, I fucking hate Chatbot.
Steps when called. Let caller context be the running execution context. Let kind be F, if kind is base. Then, let this argument be. Ordinary create from constructor. New target. %object prototype %4. Let callee context be prepare for ordinary call. F. New target. 178. ECMA International 2024. Note even though field initializers constitute a function boundary. Calling. Capital F. U. N. C. T. I. O. N. Capital D. E. C. L. A. R. A. T. I. O. N. Capital I. N. S. T. A. N. T. I. A. T. I. Does not have any observable effect and so is omitted. 5. Assert. Callee context is now the running execution context. If kind is base, then a perform ordinary call bind this. F. Callee context. This argument, be let initialize result be completion, initialize instance elements. This argument, F. See if any, initialize result is an abrupt completion, then I remove Callee context from the
I don't need this, because I already have this.
context is the running execution context. 2. Return initialize result.
And I'm already calling.
Be the lexical environment of Callee context. Let result be completion. Ordinary call evaluate body. F. Arguments list. Remove Callee context from the execution context stack and restore Callee context as the running execution context. 0. If result is a return completion, then if result is an object, return result. B if kind is base, return this argument. C if result is not undefined, throw a type error exception. 1. Else a return if abrupt. Result. 2. Let this binding be constructor env get this binding. 3. Assert. This binding is an object. 4. Return this binding. 0. 2. 3 ordinary function create. Function source text. Parameter list. Body. This mode. env. Private env. The abstract operation ordinary function create takes arguments function prototype. An object. Source text. A sequence of Unicode code points. Parameter list. A parse node. Body a parse node. This mode. Lexical this or non-lexical this. env. An environment record. And private env. A private environment record or null. And returns an ECMA script function object. It is used to specify the runtime creation of a new function with a default internal method and no internal method, although one may be subsequently added by an operation such as make constructor. Dart source text is the source text of the syntactic definition of the function to be created. It performs the following steps when called. Let internal slots list be the internal slots listed in table 30. Let f be ordinary object create. Function prototype. Internal slots list. Set f to the definition specified in 1, 0, 2, 1. Set f to source text. Set f to parameter list. Set f to body. If the source text matched by body is strict mode code, let strict be true, else let strict.
Oh, it's just so annoying.
If this mode is lexical, this.
It's like, yeah, you call that right after you do all this. It just throws it in there.
Else. Set f.
This is so frustrating.
False. 3. Set f to env. 4. Set f to private env. 5. Set f to get active script or module. 6. Set f to the current realm record. 7. Set f to undefined. 8. Set f to a new empty list. 9. Set f to a new empty list. 0. Set f to empty. 1. Let len be the expected argument counter parameter list. 2. Perform set function length. F. Len. 3. Return F. ECMA International 2024 179. 1, 0, 2, 4. Capital A, D, D, capital R, E, S, T, R, I, C, T, E, D, capital F, U, N, C, T, I, O, N, capital P, R, O, P, E, R, T, I, E, F, realm. The abstract operation, capital A, D, D, capital R, E, S, T, R, I, C, T, E, D, capital F, U, N, C, T, I, O, N, capital P, R, O, P, E, R, T, I, E, takes arguments f, a function obj, ct, and realm, a realm record, and returns unused. It performs the following steps when called. Assert. Realm exists and has been initialized. Let thrower be realm. Perform. Define property or throw. F. Caller. Property descriptor. Thrower. Enumerable. False. True. Perform. Define property or throw. F. Arguments. Property descriptor. thrower, enumerable, false, true, return unused, 0, 2, 4, 1% throw type error percent. This function is the percent throw type error percent intrinsic object. It is an anonymous built-in function object that is defined once for each realm. It performs the following steps when called. Throw type error exception. The value of the internal slot of this function is false. The length property of this function has the attributes false, false, false. The name property of this function has the attributes false, false, false. 0, 2, 5. Make constructor f. Writable prototype. Prototype. The abstract operation make constructor takes argument f, any CMA script function object or a built-in function object, and optional arguments writable prototype, a boolean, and prototype, an object, and returns unused. It converts f into a constructor. It performs the following steps when called. If f is an ECMA script function object, then a assert is constructor, f is false, b assert. F is an extensible object that does not have a prototype own property. C set f to the definition specified in 1, 0, 2, 2. Else a set f to the definition specified in 1, 0, 3, 2. Set f to base. If writable prototype is not present, set writable prototype to true. If prototype is not present, then a set prototype to ordinary object create. Percent object prototype percent b perform. Define property or throw, prototype, constructor, property descriptor, f, writable, writable prototype, false, true, perform. Define property or throw, f, prototype, property descriptor, prototype, writable prototype, false, false, return unused. 80. ECMA International 2024, 10, 2, 6. Make class constructor, f. The abstract operation make class constructor takes argument f, any CMA script function object, and returns unused. It performs the following steps when called. Assert f is false, set f to true, return unused. 0, 2, 7. Make method f, home object. The abstract operation make method takes arguments f, any CMA script function object, and home object, an object, and returns unused. It configures f as a method. It performs the following steps when called. Set f to home object, return unused. 0, 2, 8. Define method property, home object, key, closure, enumerable. The abstract operation define method property takes arguments home object, an object, key, a property key or private name, closure, a function object, and enumerable, a boolean, and returns either a normal completion containing either a private element or unused, or an abrupt completion. It performs the following steps when called. Assert. Home object is an ordinary, extensible object. If key is a private name, then a return private element. Method. Closure 3. Else, a let desk be the property descriptor. Closure. True, enumerable. True, be perform. Define property or throw, home object, key, desk, C note. Define property or throw only returns an abrupt completion when attempting to define a class. Static method whose key is prototype. D return unused. 0, 2, 9. Set function name, f, name, prefix. The abstract operation set function name takes arguments f, a function object, a name, a property key or private name, and optional argument prefix, a string, and returns unused. It adds a name property to f. It performs the following steps when called. Assert. F is an extensible object that does not have a name own property. If name is a symbol, then a let description the name's value. B if description is undefined. Set name to the empty string. C else. Set name to the string concatenation of description. And else if name is a private name, then a set name to name. If f has an internal slot, then a set f to name. If prefix is present, then a set name to the string concatenation of prefix. The code unit 0 times 0020 space and name. B if f has an internal slot, then I optionally set f to name. Perform. Define property or throw f, name, property descriptor, name, false, enumerable, false, true, return unused. ECMA International 2024 181, the 10th of February 2010. Set function length, f, length. The abstract operation set function length takes arguments f, a function object, and length, a non-negative int, ger or plus, and returns unused. It adds a length property to f. It performs the following steps when called. Assert. F is an extensible object that does not have a length own property. Perform. Define property or throw f, length, property descriptor, length, false, enumerable, false, true, return unused, 0, 2, 1, 1, capital F, U, N, C, T, I, O, N, capital D, E, C, L, A, R, A, T, I, O, N, capital I, N, S, T, A, N, T, I, A, T, I, func, arguments list. The abstract operation, capital F, U, N, C, T, I, O, N, capital D, E, C, L, A, R, A, T, I, O, N, capital I, N, S, T, A, N, T, I, A, T, I, takes arguments func, an ECMA script function object, and arguments list, a list of ECMA script language values, and returns E, R. A normal completion containing unused or an abrupt completion func is the function object for which the execution context is being established. Note 1. When an execution context is established for evaluating an ECMA script function, a new function environment record is created and bindings for each formal parameter are instantiated in that environment record. Each declaration in the function body is also instantiated. If the function's formal parameters do not include any default value initializers, then the body declarations are instantiated in the same environment record as the parameters. If default value parameter initializers exist, a second environment record is created for the body declarations. Formal parameters and functions are initialized as part of capital F, U, N, C, T, I, O, N, capital D, E, C, L, A, R, A, T, I, O, N, capital I, N, S, T, A, N, T, I, A, T, I. All other bindings are initialized during evaluation of the function body. It performs the following steps when called. Let callee context be the running execution context. Let code be func. Let strict be func. Let formals be func. Let parameter names be the bound names of formals. If parameter names has any duplicate entries, let has duplicates be true. Otherwise, let has duplicates be false. Let simple parameter list be as simple parameter list of formals. Let has parameter expressions be contains expression of formals. Let var names be the var declared names of code. 0. Let var declarations be the var scope declarations of code. 1. Let lexical names be the lexically declared names of code. 2. Let function names be a new empty list. 3. Let functions to initialize be a new empty list. 4. For each element D of var declarations, in reverse list order, do if D is neither a variable declaration nor a binding nor a binding identifier. Then, I assert, D is either a function declaration, a generator declaration, an async function declaration, or an async generator declaration. 2. Let fn be the sole element of the bound names of D. 3. If function names does not contain fn, then insert fn as the first element of function names. Note, if there are multiple function declarations for the same name, the last declaration is used. Insert d as the first element of functions to initialize. 5. Let arguments object needed be true. 6. If func is lexical, then a note, arrow functions never have an arguments object. B set arguments object needed to false. 7. Else if parameter names contains arguments, Then, a set arguments object needed to false. 82. ECMA International 2024. 18. Else if his parameter expressions is false. Then, if function names contains arguments or lexical names contains arguments. Then, I set arguments object needed to false. 9. If strict is true or has parameter expressions is false. Then, a note, only a single environment record is needed for the parameters. Since calls to eval in strict mode code cannot create new bindings which of a sib are outside of the eval, b let env be the lexical environment of callee context. 0. Else, a note, a separate environment record is needed to ensure that bindings created by direct eval calls in the formal parameter list are outside the environment where parameters are declared. b let callee env be the lexical environment of callee context. c let env be new declarative environment. Callee env, deassert. The variable environment of callee context is callee env. Set the lexical environment of callee context to env. 1. For each string param name of parameter names, do a let already declared benv has binding. Param name, b note. Early errors ensure that duplicate parameter names can only occur in non-strict functions that do not have parameter default values or rest parameters. See if already declared is false. Then, I perform env create mutable binding. Param name, false. 2. If his duplicates is true, then perform env initialize binding. Param name, undefined 22. If arguments object needed is true, then if strict is true or simple parameter list is false, then I let AOB create a mapped arguments object, arguments list. B else, I note, a mapped argument object is only provided for non-strict functions that don't have a rest parameter. Any parameter default value initializers, or any destructured parameters. 2. Let AOB create mapped arguments object, func, formals, arguments list, env. See if strict is true. Then, I perform env create immutable binding, arguments, false. 2. Note, in strict mode code, early errors prevent attempting to assign to this binding, so its mutability is not observable. Else, I perform env create mutable binding, arguments, false. Perform env initialize binding, arguments. F let parameter bindings be the list concatenation of parameter names and arguments. 3. Else, a let parameter bindings be parameter names. 4. Let iterator record be create list iterator record, arguments list. 5. If his duplicates is true, then I perform iterator binding initialization of formals with arguments iterator record and undefined 26. Else, I perform iterator binding initialization of formals with arguments iterator record and env 27. If his parameter expressions is false, then, a note, only a single environment record is needed for the parameters and top-level vars. B let instantiated var names be a copy of the list parameter bindings. C for each element n of var names. Do I have instantiated var names does not contain n, then append n to instantiated var names. Perform env create mutable binding. N, false. Perform env initialize binding. N, undefined. D let var env be env 28. Else, a note, a separate environment record is needed to ensure that closures created by expressions in the formal parameter list do not have visibility of declarations in the function body. B let var env be new declarative environment. env, C set the variable environment of callee context to var env. D let instantiated var names be a new empty list. E for each element n of var names. Do I have instantiated var names does not contain n, then ECMA International 2024 183. 1. Append n to instantiated var names. Perform var env create mutable binding. N, false. If parameter bindings does not contain n, or if function names contains n, then a let initial value be undefined 4. Else, a let initial value be env get binding value. N, false. Perform var env initialize binding. N, initial value. Note, a var with the same name as a formal parameter initially has the same value as the corresponding initialized parameter. 9. Note, an xb 3, 2, 1 adds additional steps at this point. 0.
Okay, so chatbot's code, it's missing.
Declarative environment.
What is it?
Non-strict functions use a separate
It's totally missing, like entirely.
declarations so that a direct eval can determine whether
Whatever upload command buffer is,
the eval code
it's not even present.
level lexically
So I'm gonna assume whatever,
scans because a strict direct eval
that relates to this, where I set it to a solid color,
lexien vb variant
because it looks like this command buffer,
of callie context to lexi.
except it's being ended.
Let lex declarations be the lexically
So is it even related down here?
for each element D of lex declarations. Do a note. A lexically declared name cannot be the same as a function generator declaration, formal parameter, or revar name. Lexically declared names are only instantiated here but not initialized. B for each element Dn of the bound names of D. Do I if this constant declaration of D is true, then
Is this part of it even needed?
true to else.
I don't know. I'll figure it out later. This is really annoying.
Let private TNV be the private environment of callie context. 6. For each parse node f of functions to initialize
Does that mean I can make a different command buffer?
names of f, be let for be instantiate function
You know what? It doesn't matter.
lexenv in
I'm just gonna type in what looks like it's working, and that's good enough.
fn, fo, false,
So I'm gonna rename this to upload command buffer, whatever the heck I called it.
a built-in function object is an ordinary object
And then later on, I'll figure out if this stuff is even needed.
in 10.1. In addition to the internal slots required of every ordinary object, see 10.1. A built-in function object must also have the following internal
Oh my god, just work.
in which the function was created, a string that is the initial name of the function. It is used by 20235. The
3181.
function object's internal slot is %function prototype unless otherwise specified. A built-in function object must have an internal method that conforms to the definition in 1031. A built-in
Oh, it's missing the entire thing.
if it is described as a constructor or some algorithm in this specification explicitly sets its internal method. Such an internal method must conform to the definition in 1032. An implementation may provide additional built-in function objects that are not defined in this specification. Note 2b. 3.2 provides an extension to the above algorithm that is necessary for backwards compatibility with web browser implementations of ECMA script that predate ECMA script 2015. 84. Copyright sign, ECMA International 2024. 1031. This arguments list. The internal method of a built-in function object f takes arguments this argument, an ECMA script language value, and arguments list, a list of ECMA script language values, and returns either an
And this were,
script language value or a throw completion. It performs the following steps when called. Return, built-in call or construct, f, this argument,
the texture, whatever it is,
3,
gets assigned.
list, new target. The internal method of a built-in function object f, when the method is present, takes arguments list, a list of ECMA script language values, and new target, a constructor, and returns either a normal completion containing an object or a throw completion. It performs the following steps when called. Return, built-in call or construct, f, uninitialized, arguments list, new target 1033, built-in call or construct, f, this arguments list, new target. The abstract operation built-in call or construct takes arguments f, a built-in function object. This argument, an ECMA script language value or uninitialized, arguments list, a list of ECMA script language values, and new target. A constructor or undefined, and returns either a normal completion containing an ECMA script language value or a throw completion. It performs the following steps when called. Let caller context be the running execution context. If caller context is not already suspended, suspend caller context. Let callee context be a new execution context. Set the function of callee context to f. Let callee realm be f. Set the realm of callee context to callee realm. Set the script or module of callee context to null. Perform any necessary implementation. Defined initialization of callee context. Push callee context onto the execution context stack. Callee context is now the running execution context. 0. Let result be the completion record, that is the result of evaluating f in a manner that conforms to the specification of f if this argument is uninitialized. This value is uninitialized. Otherwise, this argument provides the this value arguments list provides the named parameter.
Texture image. There it is.
Note.
I swear to cheese. Like cheese. The food. Cheese. In rice. This better work.
Remove callee context from the execution context stack.
Just work.
Running execution context.
It's all I want. It's all I need. It's just to work.
3. For create built-in function, behavior, length, name, additional internal slots list, realm, prototype.
So paste it here.
Operation create built-in function takes argument.
I'm gonna paste it here.
Set of algorithm steps.
And then see what happens.
Behavior provided in this specific.
Hopefully, it's gonna work.
Integer plus, name, a property key or a private name, and additional internal slots list, a list of names of internal slots, and optional arguments rel.
Oh my god.
Type, an object or null, and prefix, a string. And returns a function object. Additional internal slots list contains the names of additional internal slots that must. Note, when callee context is removed from the execution context stack, it must not be destroyed if it has been suspended and retained by an
3217.
for later resumption. ECMA International 2024-185 be defined as part of the object. This operation creates a built-in function object. It performs the following steps when called. If realm is not present, set realm to the current realm record. If
Does it get passed in here too?
prototype to realm
I hate this so much.
list be a list
I freaking hate this.
the internal slots that 10.3 requires for the built-in function.
Why is this stuff so stupid?
To internal slots list the elements of additional internal slots.
It's like a double pointer that holds other pointers to other pointers. It's ridiculous.
Behavior, using the provided arguments as the values of the corresponding parameters specified by behavior.
Oh my god.
An object has internal slots whose names are the elements of internal slots list, and an internal slot.
3230.
Set func to realm, set func to null. 0. Perform set
I just want to know if it works.
func length 1. If prefix is not present, then a perform set function name func name 12. Else a perform set function name func name prefix 13.
Why is this stuff so ridiculous?
Defined in this specification is created by calling the create built-in function abstract operation. 0.4 built-in exotic object.
Like, all of these assignments and operations to do a simple thing. Holy crap.
Behave similar to ordinary objects.
This is ridiculous.
The following exotic objects use the ordinary object internal methods except where it is explicitly specified otherwise below. 0. 4.
Oh my god.
Objects.
I want to puke. This is so bad.
It is an exotic object that wraps another function object. A bound function
Oh, please work. No! Why?
method. Calling a bound function exotic object generally results in a call of its wrapped function. And
I think I see something.
on exotic object if it's and, if applicable, internal methods use the following implementation.
Nope. Nope, it's nothing.
Found in 10.1. These
Fucking nothing.
exotic objects do not have the internal slots of ECMA script function objects listed in Table 30. Instead, they have the internal slots listed in Table 31, in addition to and Table 31, internal slots of bound function exotic objects, internal slot, type, description, bound target function, a callable object, the wrapped function object, bound this.
Oh, you've got to be kidding me.
Value. The value that is always passed is the this value when calling the
I'm gonna try a solid color.
script language
Maybe I can put a solid color.
are used as the first arguments to any call to the wrapped function. 186 ECMA International 2024 1041.
Should be yellow. I fucking hate chatbot. Why is chatbot so dumb?
This argument, any CMA script language value, and arguments list.
Why can't chatbot fucking help me get done?
Completion containing an
I just want to be done.
throw completion. Steps when called. Let target be F. Let bound this be F. Let bound args be F. Let args be the list concatenation of bound args and arguments list. Return. Call. Target. Bound this. Args 0, 4, 1, 2. Arguments list. New target. The int.
Alright, I'm gonna try this now.
Object F takes arguments list. A list of ECMA script language values. A new target. A constructor, and returns either a normal completion containing an object or a throw completion. It performs the following steps when called. Let target be F, assert, is constructor, target, is true. Let bound args be F. Let args be the list concatenation of bound args and arguments list. If same value, F, new target, is true. Set new target to target, return. Construct, target, args, new target, 0, 4, 1, 3 bound function create, target function, bound this, bound args, the abstract operation bound function create take.
So I'm asking chatbot,
A function.
how do I modify this code
A script language value.
to simply put somehow
Language values. And
the image data to the mother-loving 2D surface? How? No bullshit. How?
function exotic.
It literally works, makes a solid color. I simply want pixels blitzed, copied. I don't give a fuck how. Just put them in and make this garbage work.
Function set obj to bound this. Set obj
Freaking garbage.
j 0, 4 to array exotic objects. An array is an exotic object that gives special treatment to array index property keys. C6 1 7.
This is literally all I wanted.
This is also called.
I want the image data, the CPU memory pixels, shove it into, yeah, fucking shove that shit, shove the fucking pixels right into the fucking 2D surface. That's all I want. And show it on the damn screen.
Array index.
No shaders, no pipelines. Yeah, brute force, copy from RAM to GPU and present it. Fucking give me that. I swear to cheese.
Array index. The value of the length property is changed.
It's not gonna give me this, is it?
Be one more than the numeric value of that array index. And whenever the value of the length property is changed, every own property whose name is an array index whose value is not smaller than the new length is deleted. This constraint applies only to own. ECMA International 2024 187. Properties of an array and is unaffected by length or array index properties that may be inherited from its prototypes. An object is an array exotic object, or simply an array if.
Oh, please work. I swear to God. I mean cheese. I swear to cheese.
Final methods use the definition.
I swear to cheese. And all that is Parmesan.
Create 0, 4, 2.
Just work.
The internal method of an array exotic object takes arguments p, a property key, and desc, a property descriptor, and returns either a normal completion containing a boolean or a throw completion.
It took so long to get that solid color.
Then a return array a desc, else if p is an array index. Then a let length desc be ordinary get own property a length b assert is data descriptor length desc is true c assert length desc is false d let length be length desc e assert length is a non-negative integral number f let index b 32. P. G if index length and length desc is false, return false. H. Let succeeded B. Ordinary define known property A. P. Desk I have succeeded is false, return false. J if index length, then I set length desk index plus 1, 2. Set succeeded to. Ordinary define known property A. Length desk 3. Assert succeeded is true. K. Return true. Return. Ordinary define known property A. P. Desk 0, 4, 2. To array create length proto. The abstract operation array create takes argument length, a non-negative integer, and opt inal argument proto an object, and returns either a normal completion containing an array exotic object or a throw completion. It is used to specify the creation of new arrays. It performs the following steps when called. If length 232 1, throw a range error exception. If proto is not present, set proto to %array prototype %. Let A be make basic object. Set A to proto. Set A is specified in 1 0 4 2 1. Perform. Ordinary define known property A. Length property descriptor length true, false, false. Return A 0 4 2 3. Array species create original array length. The abstract operation array species create takes arguments original array, an object, and length, a non-negative integer, and returns either a normal completion containing an object or a throw completion. It is used to specify the creation of a new array or similar object using a constructor function that is derived from original array. It does not enforce that the constructor function returns an array. It performs the following steps when called. Let is array be is array original array. If this array is false, return array create length. Let C be get original array constructor. If this constructor C is true, then 88 ECMA International 2024. Let this realm be the current realm record. B. Let realm be get function realm C. See if this realm and realm are not the same realm record. Then I have same value C. Realm is true. Set C to undefined. If C is an object, then I set C to get C at species. B. If C is null, set C to undefined. If C is undefined, return array create length. If this constructor C is false, throw a type error exception. Return construct C length 0 4 2 4. Array set length A desk. The abstract operation array set length takes arguments A, an array, and desk, a property descriptor, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. If desk does not have a field, then a return. Ordinary define known property A. Length desk. Let new len desk be a copy of desk. Let new len be 32 desk. Let number len be to number desk. If same value 0, new len, number len, is false. Throw a range error exception. Set new len desk to new len. Let old len desk be ordinary get own property A. Length assert is data descriptor. Old len desk is true. Assert old len desk is false. 0. Let old len be old len desk 1. If new len old len, then a return. Ordinary define known property A. Length new len desk 2. If old len desk is false, return false. 3. If new len desk does not have a field or new len desk is true, then a let new writable be true. 4. Else a note setting the attribute to false is deferred in case any elements cannot be deleted. B. Let new writable be false. C. Set new len desk to true. 5. Let succeeded be ordinary define known property A. Length.
Come on.
If succeeded is false, return false. 7. For each own property such that P is an array index and 32 P new len in descending numeric index order. Do a let delete succeeded B. A. P. B. If delete succeeded is false, then I set new len desk to 32 P plus 1 2. If new writable is false, Set new len desk to false. 3. Perform. Ordinary define known property A. Length. New len desk. 5. Return false. 8. If new writable is false, then assert succeeded to. Ordinary define known property A. Length. Property descriptor false. B. Assert succeeded is true. 9. Return true. Note if original array was created using the standard built-in array constructor for a realm that is not the realm of the running execution context, then a new array is created using the realm of the running execution context. This maintains compatibility with web browsers that have historically had that behavior for the array prototype methods that now are defined using array species create. ECMA International 2024 189. Note, in steps 3 and 4, if desk is an object, then its value of method is called twice. This is legacy behavior that was specified with this effect starting with the second edition of this specification. 0, 4, 3 string exotic objects. A string object is an exotic object that encapsulates a string value and exposes virtual integer index data properties corresponding to the individual code unit elements of the string value. String exotic objects always have a data property named length whose value is the length of the encapsulated string value. Both the code unit data properties and the length property are non-writable and non-configurable. An object is a string exotic object, or simply a string object, if its and internal methods use the following implementations, and its other essential internal methods use the definitions found in 10.1. These methods are installed in string create. String exotic objects have the same internal slots as ordinary objects. They also have internal slot 1, 0, 4, 3, 1, p. The internal method of a string exotic object S takes argument p, a property key, and returns a normal.
Oh my god. Finally.
It performs the following.
I'm gonna cry. It's fucking done. It's finally working. Holy fuck. That was way too complicated.
3, 2, p, desk. The internal method of a string exotic object S takes arguments p, a property key, and esc, a property descriptor, and returns a.
Now I gotta fucking scale it
It performs
down to 1080.
called let's
Man.
property S p if string desk is not
And I gotta apply the shader.
extensible b
Oh my god.
descriptor extensible desk string desk return ordinary define known property S p desk 0, 4, 3, 3. The internal method of a string exotic object O takes no arguments and returns a normal completion containing a.
Where's the system monitor?
It performs the following steps when called. Let keys be a new empty list. Let strbo assert. Str is a string. Let len be the length of str for each integer I such that 0I len in ascending order. Do a append to string I to keys for each own property key p of O such that p is an array index and to an integer or infinity p len in.
This eats up quite a bit, like 20%.
To keys for each own property key p of O such that p is a string and p is not an array index in ascending chronological order.
I need like stuff to change in the image.
90. ECMA International 2024 8. For each own property key p of O such that p is a symbol in ascending chronological order of property creation. Do a append p to keys 9. Return keys 0, 4, 3, 4 string create. Value prototype. The abstract operation string create takes arguments value, a string, and prototype.
It's like 20% CPU. Come on.
Creation of new string exotic object. Following steps when called. Let S be make basic object. Set S to prototype. Set S to value. Set S as specified in 1.
That's gonna have to do, I guess.
1. Set S as specified in 1.
I can optimize later.
Set S as specified in 1, 0, 4, 3.
I shouldn't have to use the CPU. It should be possible. I gotta get an AMD video card and just say fuck NVIDIA.
Length.
NVIDIA's like cock blocking,
S0
gatekeeping, access to stuff you purchase. So I'll get AMD.
operation string get don't
Oh, that's like rewrite stuff.
an object that has an internal slot.
You know what? This works. I'm whatever. I gotta like scale it
XP canonical new
from 4K down to 1080.
says undefined. Return undefined. If this integral number, int x, is false, return undefined. If index is -0, return undefined. Let str be s. Assert. str is a string. Let len be the length of str. If
But it is in the window, so
return undefined. 0
almost done.
be the substring of str from r. Int x to r. Index plus
I need to scale it first
scripter. Result str. Writable
to make sure it's like from 4K to 180.
0 4. 4 arguments exotic objects.
Actually,
Script functions make an arguments object available to their code. Depending upon the characteristics of the function definition, its
I should probably copy it, add 4K,
object or an arguments exotic object. An arguments exotic
and then when I scale it, it'll be sharper
properties map to the form
than scaling it first, and then using it.
function. An object
So it's gonna use more CPU.
if its internal methods use the following implementations, with the ones not specified here using those found.
It only uses more CPU when there's a lot of movement.
Mapped arguments object. Arguments exotic objects have the same internal slots as ordinary objects. They also have an internal slot.
I get some water.
Objects also have an internal slot whose value
I get closer, closer.
ordinary argument object
I'm almost back on track.
only used by object prototype to string 201336.
If I can get done with this today,
Mapped arguments object is
I can say fuck Windows, get off Windows,
object.
then on to the standard again. Or not onto the standard. Finish converting to 64-bit.
Integer. Index data properties of an
This took a whole week.
object whose numeric name values are less than the number of formal parameters of the corresponding function object initially share their values with the corresponding argument bindings in their function's execution context.
When I say it took a week, I mean a literal week of 24-hour days.
This correspondence is broken if such a property is deleted.
Man, that's way too long. How long does it take to make a shader? Why are there no answers on this website? This website has the worst answers. Only 3 days? Oh, well, it's an OpenCL.
Spanner, Vulkan is low level and verbose. Even a hello triangle is a major undertaking.
Testing, testing. Why is the sound not working?
NG. You cannot escape triangles. 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 You cannot escape triangles.
Okay, now it's working.
How many days does it take to make first FPU shader program?
That's supposed to be GPU, not FPU.
In Vulkan. Great. You're asking how long it takes to make your first shader program in Vulkan. That's a different beast from OpenGL or Shaditoya because Spanner, Vulkan is low level and verbose. Even a hello triangle is a major undertaking.
Yeah, making the hello triangle. That was fucking hell. Holy crap.
Hourglass with flowing sand. How long to make your first shader program in Vulkan? Brain. If you're a beginner in Vulkan, 3 to 7 days, depending on how much experience you have with.
And chatbot. Chatbot's no help. You can use chatbot. And you'll still get done in 7 days.
7 days.
God damn.
C++, or Rust, Zig, etc. GPU concepts, GLSL SPV, Vulkan's complexity, it's not beginner friendly. Fire, what shader program means in Vulkan. In Vulkan, a shader program involves 1. Writing a GLSL shader, vertex plus fragment. 2. Compiling to SPIV using the slang validator. 3. Creating VK shader module for each shader. 4. Creating a pipeline layout, descriptor sets, etc. 5. Creating a graphics pipeline that includes the shaders. 6. Submitting a command buffer to render. So, even if your shader is just version 450, void main, do nothing, the pipeline setup code is 90% of the work. Bricks, realistic timeline to first triangle in Vulkan. Vulkan SDK installation plus setup 1-2 hours.
That's actually accurate. It did take 1 to 2 hours.
Create Vulkan instance device swap chain 1 to 2 days.
I think that was actually like 3 days.
Create render pass. From a buffer, etc. 1 day.
I think that took 2 days. I'm probably retarded, because it took me a little bit longer. It just means a little bit slower. Except I'm not. I have ADHD. I was tested. Slow learning and ADHD hand in hand.
Write and compile GLSL to SPIVy 2 hours.
That didn't take 2 hours.
Create pipeline and draw call 1 to 2 days. And clockwise direction arrows. Faster alternatives if you're just trying to experiment with shaders. Don't go straight to Vulkan unless you want to learn Vulkan specifically. Instead, tick. Learn shaders first in OpenGL or WebGL. Faster feedback loop. GLFW plus GLAD plus OpenGL. Shader Toy. Instant feedback. Tick. Learn shaders first in OpenGL or WebGL. Faster feedback loop. GL. Tick. Summary experience level time to first shader. Vulkan. Absolute beginner 5-7 days, intermediate programmer 2-4 days, familiar with OpenGL 1 to 3 days. Brain. Vulkan is not made for quick shader experiments. It's for performance critical apps like engines, not prototyping.
Yeah, no, it's like, it's not for prototyping. Prototyping and Vulkan, they don't go together. Spending hours to figure out what's connected to what and why this does that and what that even is. That's 900% of the time.
Would you like a minimal Vulkan shader pipeline example to get started with? I can walk you through it.
I wish I was retarded. If I was retarded, life would be so much easier. But instead, I have to deal with the retarded people that wrote. Not that wrote. The retarded people at Google that don't know how to follow standard. I mean, how slow could you possibly be? Chatbot said the last time that Google met the whole standard was back in 2011. So 2025, minus 2011. Dang it. That's 14 years retarded. 14 years slow. I may have taken a couple days longer, but still within 5 to 7 days. But some things could have gone quicker. So I might be a day or two retarded. A little bit slower, because I'm trying to like actually figure it out. And because I'm like fighting with how to do it. Because it's really stupid how it's done. Just like I'm gonna fight to fucking win if there's a competition. Because I'm not gonna lose. So, like, Google better be ready to buy my fucking engine. Because if they don't, I'll compete. At least I'm only a couple days retarded. Google is literally 14 years retarded. That's like extra super slow. It's like so slow that they don't know what's going to hit them when there's a new web browser if someone decides to compete. Because who the fuck would use a retarded browser They can't simply meet a standard. In a retarded company, in a retarded company that finds it acceptable and standardizes collecting information on users.
You're referring to a significant legal case where Google settled a $5 billion privacy lawsuit related to its incognito mode in the Chrome browser.
A company retarded enough to go as low as spy on users in private mode and sell their porn histories, and then not hire porn stars, yet they have a collection of everybody in their porn search history. In databases, they have IPs, they have names, and they sell it so they can host free video. How retarded, how slow, that is not maintainable. Are you kidding me? And they don't even pay the people that post content. How fucking slow could YouTube, could Alphabet possibly be to pull a stunt like that? Over 14 years and longer. I think the jig is up. I'm gonna get some water.
Led, assert. Module is empty. Let internal slots list be the internal slots listed in table 33. Let n be make basic object. Internal slots list. Set m's essential internal methods to the definitions specified in 1.0.4.6. Set m to module. Let sorted exports be a list whose elements are the elements of exports ordered as if an array of the same values had been sorted using %array prototype sort % using undefined as compare f. Set m to sorted exports. Create own properties of n corresponding to the definitions in 28.3. Set module to m0. Return m0. 4. 7 immutable prototype exotic objects. An immutable prototype exotic object is an exotic object that has an internal slot that will not change once it is initialized. An object is an immutable prototype exotic object if its internal method uses the following implementation. Its other essential internal methods may use any implementation, depending on the specific immutable prototype exotic object in question. 0, 4, 7, 1. V. The internal method of an immutable prototype exotic object O takes argument v, an object or null, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Return. Set immutable prototype O. v10. 4. 7. To set immutable prototype O. V. The abstract operation set immutable prototype takes arguments O, an object, and v, an object or null, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Let current be O if same value, v, current, is true. Return true. Return false. 0.5 proxy object internal methods and internal slots. A proxy object is an exotic object whose essential internal methods are partially implemented using ECMA script code. Every proxy object has an internal slot called the value of is an object, called the proxy's handler object, or null. Methods, see Table 34, of a handler object may be used to augment the implementation for one or more of the proxy object's internal methods. Every proxy object also has an internal. Note, unlike other exotic objects, there is not a dedicated creation abstract operation provided for immutable prototype exotic objects. This is because they are only used by %object prototype % and by host environments. And in host environments, the relevant objects are potentially exotic in other ways and thus need their own dedicated creation operation. ECMA International 2024-203. Slot called whose value is either an object or the null value. This object is called the proxy's target object. An object is a proxy exotic object if its essential internal methods, including and, if applicable, use the definitions in this section. These internal methods are installed in proxy create, Table 34. Proxy handler methods, internal method, handler method, get prototype of, set prototype of, is extensible, prevent extensions, get own property descriptor, define own property, has set, delete property, own property keys, call, apply, construct. When a handler method is called to provide the implementation of a proxy object internal method, the handler method is passed the proxy's target object as a parameter. A proxy's handler object does not necessarily have a method corresponding to every essential internal method. Invoking an internal method on the proxy results in the invocation of the corresponding internal method on the proxy's target object if the handler object does not have a method corresponding to the internal trap. The and internal slots of a proxy object are always initialized when the object is created and typically may not be modified. Some proxy objects are created in a manner that permits them to be subsequently revoked. When a proxy is revoked, its and internal slots are set to null, causing subsequent invocations of internal methods on that proxy object to throw a type error exception. Because proxy objects permit the implementation of internal methods to be provided by arbitrary ECMA script code, it is possible to define a proxy object whose handler methods violates the invariants defined in 6.1.7.3. Some of the internal method invariants defined in 6.1.7.3 are essential integrity invariants. These invariants are explicitly enforced by the proxy object internal methods specified in this section. An ECMA script implementation must be robust in the presence of all possible invariant violations. In the following algorithm descriptions, assume O is an ECMA script proxy object, P is a property key value, V is any ECMA script language value, and desc is a property descriptor record. O for copyright sign, ECMA International 2024-1051. The internal method of a proxy exotic object O takes no arguments and returns either a normal completion containing either an object or null, or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy, O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Get prototype of. If trap is undefined, then a return target. Let handler proto be. Call. Trap. Handler. Target. If handler proto is not an object and handler proto is not null, throw a type error exception. Let extensible target be. Is extensible target 0. If extensible target is true, return handler proto 1. Let target proto be target 2. If same value, handler proto, target proto, is false, throw a type error exception 3. Return handler proto 0, 5, 2. V. The internal method of a proxy exotic object O takes argument V, an object or null, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy, O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Set prototype of if trap is undefined, then a return target. V. Let Boolean trap result be to Boolean. Call trap handler target. V. If Boolean trap result is false, return false. Let extensible target be is extensible target 0. If extensible target is true, return true 1. Let target prota be target 2. If same value v target prota is false, throw a type error exception 3. Return true. Note for proxy objects enforces the following invariance. The result of must be either an object or null. If the target object is not extensible, applied to the proxy object must return the same value as applied to the proxy object's target object. Note for proxy objects enforces the following invariance. The result of is a Boolean value. If the target object is not extensible, the argument value must be the same as the result of get prototype of applied to target object. ECMA International 2024 205 1053. The internal method of a proxy exotic object O takes no arguments and returns either a normal completion containing a Boolean or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler is extensible. If trap is undefined, then a return is extensible. Target. Let Boolean trap result be to Boolean. Call trap handler target. Let target result be is extensible. Target. If Boolean trap result is not target result, throw a type error exception 0. Return Boolean trap result 0. 5. 4. The internal method of a proxy exotic object O takes no arguments and returns either a normal completion containing a Boolean or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Prevent extensions. If trap is undefined, then a return target. Let Boolean trap result be to Boolean. Call trap handler target. If Boolean trap result is true, then a let extensible target be is extensible target be. If extensible target is true, throw a type error exception.
Okay, so now
Trap result 0. 5. 5. P. The internal method of a proxy exotic object O takes argument P.
do I want to make it resizable?
Containing either a property descriptor
Not really.
or a throw completion. It performs the following steps when called. Note for proxy objects enforces the following invariance. The result of is a Boolean value.
Oh, man.
Same value as applied to the proxy object's target object with the same argument. Note for proxy objects enforces the following invariance. The result of is a Boolean value. Applied to the proxy object only returns true if applied to the proxy object's target object is false. 2. Perform.
If I make the window 4K,
O. Let target be O. 06. ECMA International 2024 3. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Get own property descriptor. If trap is undefined,
I'm gonna save it back up
target P.
and then figure out.
JB. Call trap handler target P. If trap result obj.
And retarded means slow.
Throw
It doesn't mean handicapped.
target desk.
And I also called myself retarded,
If trap result
therefore,
defined, then if target desk is undefined,
yeah.
throw a type error exception. See let extensible
I gotta focus.
is extensible target. D. If extensible target is false, throw a type error exception. E. Return undefined 1. Let extensible target be is extensible target 2. Let
I have to stop making bad jokes,
trap result obj 3. Perform complete
but I can't.
result desk 4. Let valid be is compatible property descriptor.
Because
Result desk target desk
I'm not gonna make more jokes.
is false. Throw
That was it. Alright, I gotta focus.
if result desk is false, Then, if target desk is undefined or target desk is true, then I throw a type error exception. B, if result desk has a field and result desk is false, then I assert target desk has a field. 2. If target desk is true, throw a type error exception. 7. Return result desk. Note for proxy objects and
But that was actually 7 days, exactly.
be either an object or undefined. A property cannot be reported as non-existent if it exists as a non-configurable own property of the target object. A property cannot be reported as non-existent if it exists as a known property of a non-extensible target object. A property cannot be reported as existent if it does not exist as an own property of the target object and the target object is not extensible. A property cannot be reported as non-configurable unless it exists as a non-configurable own property of the target object. A property cannot be reported as both non-configurable and non-writable unless it exists as a non-configurable, non-writable own property of the target object. 0, 5, 6, p, desk. The internal method of a proxy exotic object O takes arguments p, a property key, and desk, a property descriptor, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Perform. Validate non-revoked proxy.
5 to 7 days.
Let handler be O. Assert. Handler is an object.
Literally 7 days. 5, 4, 3, 2, 1.
Undefined. Then a return target.
So at least it didn't take longer than 7 days.
From property descriptor. Desk. Let boolean trap.
Then I'd feel retarded. So at least it was 7 days, so I don't feel slow.
OBJ. If boolean.
Just normal speed, not slow speed.
0. Let target desk be target. P. ECMA International 2024 207. 11. Let extensible target be. Is extensible. Target. 2. If desk has a field and desk is false, then a let setting config false be true. 13. Else a let setting config false be false. 4.
Okay, I get this done so we can get to standard.
Then, if extensible target is false, throw a type error exception. B, if setting config false is true, throw a type error exception. 5. Else, if is compatible property descriptor, extensible target, target desk, is false, throw a type error exception. B, if setting config false is true and target desk is true, throw a type error exception. C, if is data descriptor, target desk, is true, target desk is false, and target desk is true. Then, if desk has a field and desk is false, throw a type error exception. 6. Return true. Note for proxy objects enforces the following invariance. The result of is a boolean value. A property cannot be added if the target object is not extensible. A property cannot be non-configurable unless there exists a corresponding non-configurable own property of the target object. A non-configurable property cannot be non-writable unless there exists a corresponding non-writable own
You can scale the image during the process of uploading it to the GPU.
property. Then
That means it's CPU side.
of the property to the target object using will not throw an exception. 0, 5, 7, p. The internal method of a proxy exotic object O takes argument p, a property key, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Perform. Validate non-revoked proxy. O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler has. If trap is undefined, then a return target. P. Let boolean trap result be to boolean. Call. Trap. Handler. Target. P. If boolean trap result is false, then a let target desk be target. P. B. If target desk is not undefined, then if target desk is false, throw a type error exception. 2. Let extensible target be. Is extensible. Target. 3. If extensible target is false, throw a type error exception. Return boolean trap result. 08. ECMA International 2024. Note for proxy objects enforces the following invariance. The result of is a boolean value. A property cannot be reported as non-existent if it exists as a non-configurable own property of the target object. A property cannot be reported as non-existent if it exists as a known property of the target object, and the target object is not extensible. 0, 5, 8. The perform. Validate non-revoke proxy. O.
Add a capture desktop at 4K.
Third. Handler is an object. Let trap be. Get method. Handler. Get. If trap is undefined, then a return target. Let trap result be. Call. Trap. Handler. Target. P. Receiver. Let target desk be target. P. If target desk is not undefined and target desk is false, then if is data descriptor. Target desk is true and target desk is false, then I have same value. Trap result. Target desk is false. Throw a type error exception. B if is accessor descriptor. Target desk is true and target desk 0. Return trap result. Note, the value reported for a property must be the same as the value of the corresponding target object property if the
So I gotta set the window to 1920 by 108. 108.
data property. The value
And then I'll set to
be undefined if the corresponding target object property is an unconfigurable
the program that gets the
find as its 0, 5, 9. The IC object
display capture.
P. A property key V. Any CMA script language value and receiver any CMA script language value and return
The XSHM get image.
a boolean or a throw completion. It performs the following step.
Set this to 4K.
Validate
Just take up more CPU, I guess.
BO. Let handler BO. Assert. Handler is
I'm not gonna waste time trying to like optimize or fight the system.
is undefined. Then
I already have a system fight,
boolean trap result.
so I get that done first.
Call. Trap. Handler. Target. P. V.
And just get this running.
Trap result is false. Return false. Let
So I'll update that to do 4K or capture 4K.
if target desk is not undefined and target desk is false.
And I'll update this shader
2024 200.
to scale it.
If is data descriptor. Target desk is true and target desk is false. Then I have same value. V.
And maybe I can just scale it to like
Throw a type
10 by 10 pixels.
accessor.
And maybe that'll be good enough. I'll just like do that to pixelate it
Then
for now.
desk 1.
And I'll center it
True. Note the
and then put the board around it.
the value of a
And then I'm done.
from the value of the corresponding
I think I'm gonna do that.
property if the corresponding
And then this will be over with.
object property is a non-writable, non-configurable own data
This long, 7 days. That was way too long.
target object property is a non-configurable own accessor property that has undefined as its 0, 5, 1, 0 P. The internal method of a proxy exotic object O takes argument P, a property key, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy. O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Delete property. If trap is undefined, then a return target. P. Let boolean trap result be to boolean. Call. Trap. Handler. Target. P. If boolean trap result is false, return false. Let target desk be target. P. 0. If target desk is undefined, return true. 1. If target desk is false, throw a type error exception. 2. Let extensible target be. Is extensible target. 3. If extensible target is false, throw a type error exception. 4. Return true. Note for proxy objects enforces the following invariance. The result of is a boolean value. A property cannot be reported as deleted if it exists as a non-configurable own property of the target object. A property cannot be reported as deleted if it exists as a known property of the target object and the target object is non-extensible. 0, 5, 1, 1. Property keys. The internal method of a proxy exotic object O takes no arguments and returns either a normal completion containing a list of property keys or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy. O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Own keys. 10. ECMA International 2024. 6. If trap is undefined, then a return target. Let trap result array be. Call trap handler target. Let trap result be. Create list from array like trap result array string symbol. If trap result contains any duplicate entries, throw a type error exception 0. Let extensible target be. Is extensible target 1. Let target keys be target 2. Assert target keys is a list of property keys 3. Assert target keys contains no duplicate entries 4. Let target configurable keys be a new empty list 5. Let target non-configurable keys be a new empty list 6. For each element key of target keys, do a let desk be target key be if desk is not undefined and desk is false. Then, I append key to target non-configurable keys C else. I append key to target configurable keys 7. If extensible target is true and target non-configurable keys is empty, then a return trap result 8. Let unchecked result keys be a list whose elements are the elements of trap result 9. For each element key of target non-configurable keys, do if unchecked result keys does not contain key, throw a type error exception be remove key from unchecked result keys 0. If extensible target is true, return trap result 1. For each element key of target configurable keys, do if unchecked result keys does not contain key, throw a type error exception be remove key from unchecked result keys 2. If unchecked result keys is not empty, throw a type error exception 3. Return trap result. Note for proxy objects enforces the following invariance. The result of is a list. The returned list contains no duplicate entries. The type of each result list element is either string or symbol. The result list must contain the keys of all non-configurable own properties of the target object. If the target object is not extensible, then the result list must contain all the keys of the own properties of the target object and no other values. 0, 5, 1, 2. This arguments list. The internal method of a proxy exotic object O takes arguments this argument, an ECMA script language value, and arguments list, a list of ECMA script language values, and returns either a normal completion containing an ECMA script language value or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy O. Let target be O. Arget. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Apply. If trap is undefined, then a return. Call. Target. This argument. Arguments list. Let arg-array be create array from list. Arguments list. Return. Call. Trap. Handler. Target. This argument. Arg-array. Note a proxy exotic object only has an internal method if the initial value of its internal slot is an object that has an internal method. ECMA International 2024-211. The 10th of May 2013. Arguments list. New target. The internal method of a proxy exotic object O takes arguments list, a list of ECMA script language values, a new target, a constructor, and returns either a normal completion containing an object or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy O. Let target be O. Assert. Is constructor. Target. Is true. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Construct. If trap is undefined, then a return. Construct. Target. Arguments list. New target. Let arg-array be create array from list. Arguments list. Let new obj be. Call. Trap. Handler. Target. Arg-array. New target. 0. If new obj is not an object, throw a type error exception. 1. Return new obj. Note 2 for proxy objects enforces the following invariance. The result of must be an object. 0. 5. 1 for validate non-revoke proxy. Proxy. The abstract operation validate non-revoke proxy takes argument proxy, a proxy exotic object, and returns either a normal completion containing unused or a throw completion. It throws a type error exception if proxy has been revoked. It performs the following steps when called. If proxy is null, throw a type error exception. Assert. proxy is not null. Return unused. 0, 5, 1, 5 proxy create. Target. Handler. The abstract operation proxy create takes arguments target, any CMA script language value, and handler, any CMA script language value, and returns either a normal completion containing a proxy exotic object or a throw completion. It is used to specify the creation of new proxy objects. It performs the following steps when called. If target is
So,
throw type error
what I want to do now is like
object.
turn off the triangle
Make basic object. Set P's essential intent.
because I don't think it's even needed now. It's like, I think it's being overwritten,
If is callable. Target.
but I'm not sure
A set P is specified in the 10th of May 2000.
because this code,
B if is constructor. Target. If
I'm not,
is specified in the 10th of May 2013. Set P to target. Set P to handler. Return P. 12. ECMA International 2000.
originally,
1A. Proxy exotic object only has an internal method if the initial value of its internal slot is an object that has an internal method. 11 ECMA script language.
I think the command buffers are set here,
Source text syntax. Source
and it says both of them.
code point. ECMA script source text is a sequence of Unicode code.
It's the same thing.
All Unicode code point values from
So I think we just toggle between them
to U plus 10FF, including surrogate,
for making the triangle.
occur in ECMA
And I think the code later overrides it.
script grammars. The actual encodings used to store and interchange ECMA script source text is not relevant.
So if it works how I think, which is assumption,
Forming ECMA script implementation processes the source text
if I enter 300 times or whatever,
character values. Each source character being a Unicode
after I stop entering, it should like
script implement
toggle back and forth between the last two frames,
text or behavior
because it'll be like stuck
normalization.
between whatever last frames that were in the flip buffer, whatever.
Individual Unicode
It's called a double buffer, but it's not really a double buffer.
character. Note in string literals. Regular expression.
I guess based on context.
Identifiers. Any
It'd be like saying
point may also be
V8 meets the JavaScript standard,
explicitly express a code point
because it doesn't.
with
It's not even close.
such an escape sequence.
Based on context,
Part of the comment.
could mean anything you want. Sure, of course, yeah,
Language in the
but they don't.
escape sequences. In a Java program, if the
But I will.
U000 for example, occurs within a single line comment, it is interpreted as a line
It's probably because I'm retarded.
code point U plus zeros
Who would be dumb enough
feed LF, and therefore the next code point.
to optimize JavaScript
Similarly, if the Unicode escape sequence
and then go through 816 pages of hell?
Java program, it is likewise interpreted as a line terminator, which is not.
I don't know, I guess me.
One must write N instead of U000A to cause a line feed, LF, to be part of the string value of a string literal. In an ECMA
Or there's like
escape sequence occurring within a
method to the madness.
for cannot contribute.
Yeah, no, it's about the money.
A Unicode is
Anyways,
occurring within a string literal in an ECMA script program always contributes to the literal and is never interpreted as a line terminator or as a code point that might terminate the
I'm just ignoring this.
one static
I think it's gonna toggle between two,
encode
where the last two frames are.
CP. The
After it hits 300, it stops entering.
encode code point takes argument CP, a Unicode code point, and returns a string. It performs the following steps when called.
That's a surprise.
CP0 time
It's yellow.
CP0x
Now why is it yellow?
return the string value consistent
Oh, because it's calling this.
value is CP. Let K1 be the code.
Yeah, that was,
Value is floor.
I was like, what the heck?
0 times 400 plus
Yeah, I did not expect that.
0. Let Q2 be the code unit whose
Let's say 300 frames, about now. Did it do it?
0 times 400 plus 0 XDCs
I need a background that changes more.
in concatenation of Q1 and Q2. ECMA International 2024 213 111 2 static
Yeah, this definitely slows down the computer.
text The abstract operation code points to string takes argument text, a sequence of Unicode code points, and returns a string. It converts text into a string value, as described in 6.1.4. It performs the following steps when called. Let result be the empty string. For each code point CP of text, do a set result to the string concatenation of result and UTF-16 encode code point CP3. Return result 1, 1, 3 static semantics, UTF-16 surrogate pair to code point, led.
This one moves most.
Operation UTF-16 surrogate pair to code point takes arguments led a code unit, and trail a code unit, and returns a code point. Two code units that form
So I'll run it again.
surrogate pair are converted to a code point. It performs the following steps when
At some point, at 300 entries, it'll stop. There it goes.
let CP be led 0xD800, 0 times 400 plus trail 0xDC00 plus 0 times 10,000. Return the code point CP 1, 1, 4 static semantics, code point at string, position. The abstract operation code pointed takes argument string, a string, and position, a non-negative integer, and returns a record with fields, a code point, a positive integer, and a boolean. It interprets string as a sequence of UTF-16 encoded code points, as described in 6.1.4, and read
I can't tell. Is it changing?
code unit at index position.
I think it is.
Steps when called. Let size be the length of
I
string
need a bigger gap between frames.
row and position. Size. Let first be the code unit at index position within string. Let CP be the code point whose numeric value is the numeric value of first. If a first is neither a leading surrogate nor a trailing surrogate, then I return the record CP 1, full 6. If a first is a trailing surrogate or position plus 1 equals size, then I return the record CP 1, true. Let second be the code unit at index position plus 1 within string. If second is not a trailing surrogate, then I return the record CP 1, true. Set CP to UTF-16 surrogate pair to code point, first, second, 0. Return the record CP 2, false, 1.
Make this entry A and then entry B.
Semantics. String to code points. String. The abstract operation string to code points takes argument string, a string, and returns a list of code points. It returns the sequence of Unicode code points that results from interpreting string as UTF-16 encoded Unicode text as described in 6.1.4. It performs the following steps when called. Let code points be a new empty list. Let size be the length of string. Let position be 0. Repeat. While position, size, let
So every
it, string, position, be append CP to code points. C set position to position plus CP. Return code points. 14. ECMA International 2024. 1.1.1. 6 static semantics. Parse text. Source text. Goal symbol. The abstract operation parse text takes argument source text, a sequence of Unicode code points, and goal symbol, a non-terminal in one of the ECMA script grammars, and returns a parse node or a non-empty list of syntax error objects. It performs the following steps when called. Attempt to parse source text using goal symbol as the goal symbol, and analyze the parse result for any early error conditions. Parsing and early error detection may be interleaved in an
Let's reset it separately.
if the parse succeeded and no early errors were found, return the parse node, an instance of goal symbol, at the root of the parse tree resulting from the parse. Otherwise, return a list of
Maybe like every 10 frames.
representing the parsing errors and or early
It's like 6.
more than one parse
Assuming it's like 6 per second or 60.
and ordering of error
Except I don't know how many per second.
defined.
I think it's like unlocked. Meaning,
Notes to see all
who knows how many frames per second. It just runs however fast it runs.
there are 4 types of EC
So it's probably less than 60 then.
source text that is treated
Because everything's probably taking up frame rate
global.
as you're running the script.
Not include any source text that is passed as part of a function declaration, function expression, generator declaration, generator expression, async function declaration, async function expression, async generator declaration, async generator expression, method definition, arrow function, async arrow function, class declaration, or class expression, eval.
And run it.
Text supplied to the built-in eval function. More precisely, if the parameter to the built-in eval function is a string, it is treated as an EC.
Oh, that didn't work.
The eval code for a particular invocation of eval
What I miss? Over here.
script function code is source text that is parsed to supply the value of the and internal slots, C10.2, of an ECMA script function object. The function code of a particular ECMA script function does not include any source text that is parsed as the function code of a nested function declaration, function expression, generator declaration, generator expression, async function declaration, async function.
That's not enough time difference.
Generator declaration, async generator expression, method definition, arrow function, async arrow function, class declaration, or class expression. In addition, if the source text referred to above is parsed as the formal parameters and function body of a function
Man, how many frames is it getting?
expression, the formal parameters and generator body of a generator
Oh,
declaration.
I'm incrementing the wrong counter.
The former L parameters and async function body of an async function declaration or async function expression, or the formal parameters and async generator body of an async generator declaration or async generator expression, then the source text matched by
I'm doing the wrong check.
if any of that declaration or expression is also included in the function code of the corresponding function. Module code is source text that is code that is provided as a module body. It is the code that is directly evaluated when a module is initialized. The module code of a particular module does not include any source
Well, yeah.
text that has an early error at a particular point, and also a syntax error at a later point. An implementation that does a parse pass followed by an early errors pass might report the syntax error and not proceed to the early errors pass. An implementation that interleaves the two activities might report the early error and not proceed to find the syntax error. A third implementation might report both errors. All of these behaviors are conformant. Copyright sign, ECMA International 2024-215. Text that is parsed as part of a nested function declaration, function expression, generator declaration, generator expression,
After this,
async function expression, async generator declaration,
I'm too bored to care.
expression, method definition, arrow function, async arrow
Yeah, no, that's not working either.
declaration, or class expression. Note 1 function code is generally provided as the bodies of function definitions. 15.2, arrow function definition.
Just like module it, maybe.
Method definitions. 15.4,
See what that'll do.
definitions. 15.5, async function definitions. 15.8, async generator function definitions. 15.6, and async arrow functions. 15.9. Function
So I did something.
from the arguments to the function constructor. 2 0 2 1 1. The generator function constructor. 2 7 3 1 1. And the async function constructor. 2 7 7.
Wait, why does it look completely different?
Effect of including the binding
That's really weird.
function code is that the early errors for strict mode code are applied to a binding identifier that is the name of a function whose body,
I can literally have two screens running,
and if the surrounding code is not strict,
and you can't see the secondary screen.
the prologues and the use strict directive. A directive prologue is the longest sequence
That's so weird.
occurring as the initial statement list items or module items of a function body, a script body, or a module body, and where each expression statement in the sequence consists entirely of a string literal token followed by a semicolon. The semicolon may appear explicitly or may be inserted by automatic semicolon insertion. 12.10. A directive
I could watch a movie
sequence, a use
as it flickers and see the desktop at the same time.
whose string literal is either of the exact
It's like multi-vision.
or use string.
Oh, wow, now it's doing something weird.
May not contain an escape sequence or line continuation. A directive
Alright, you can see that though.
use strict directive. However, an implementation may issue a warning if this occurs.
So it's like two images. On my screen, I can see both of them
MA script syntax
at the same time.
processed using either
Ah, this sucks.
syntax and symlog that contains a use strict directive. Module code is always strict mode code. All parts of a class declaration or a class expression are strict mode code. Eval code is strict mode code if it begins with a directive prologue that contains a use strict directive, or if the call to
Alright, I'm gonna do this now.
is contained in strict mode code. Function code is strict mode code if the associated function declaration, function expression, generator declaration, generator expression, async function declaration, async function expression, async generator declaration, async generator expression, method definition, arrow function, or async arrow function is contained in strict mode code, or if the code that produces the value of the function
Write the world's worst program ever.
contains a use strict directive. Function code that is supplied as the arguments to the built-in function, generator, async function, and async generator constructor.
This is how not to write a program.
String that when processed is a
Or you could, it doesn't matter, I don't care what you do.
prologue that contains a use strict directive.
This will enter the if
Not strict mode,
10 times.
strict code. 16. Copyright sign, ECMA.
It's the worst program ever.
4. Note the expression statements of a directive prologue are evaluated normally during evaluation of the containing production. Implementations may define implementation
I'll do that for like the other one too.
statements which are not a use strict directive and which occur in a directive prologue. If an appropriate notification mechanism exists, an implementation should issue a warning if it encounters in a directive prologue an expression statement that is not a use strict directive and which does not have a meaning defined by the implementation. 1. 2. 3 non-ECMA script functions. An ECMA script implementation may support the evaluation of function exotic objects whose evaluative behavior is expressed in some host-defined form of executable code other than ECMA script source text. Whether a function object is defined with an ECMA script code or as a built-in function is not observable from the perspective of ECMA script code that calls or is called by such a function object. 2. ECMA script language. Lexical grammar. The source text of an ECMA script or module is first converted into a sequence of input elements, which are tokens, line terminators, comments, or white space. The source text is scanned from left to right, repeatedly taking the longest possible sequence of code points as the next input element. There are several situations where the identification of lexical input elements is sensitive to the syntactic grammar context that is consuming the input elements. This requires multiple goal symbols for the lexical grammar. The input element hashbang or regexp goal is used at the start of a script or module. The capital I, N, P, U, T, capital E, L, E, M, E, N, T, capital R, E, G, capital E, X, P, capital O, R, capital T, E, M, P, L, A, T, E, capital T, A. Goal is used in syntactic grammar contexts where a regular expression literal, a template middle, or a template tail is permitted. The input element regexp goal symbol is used in all syntactic grammar contexts where a regular expression literal is permitted but neither a template middle nor a template tail is permitted. The input element template tail goal is used in all syntactic grammar contexts where a template middle or a template tail is permitted but a regular expression literal is not permitted. In all other contexts, input element div is used as the lexical goal symbol. Note the use of multiple lexical goals ensures that there are no lexical ambiguities that would affect automatic semicolon insertion. For example, there are no syntactic grammar contexts where both a leading division or division assignment and a leading regular expression literal are permitted. This is not affected by semicolon insertion.
Alright, try this.
1, 0, in examples such as the following. App equals b high g exec, cmap, d, where the first non-white space, non-comment code point after a line terminator is u plus 002f, solidus, and the syntactic context allows division or division assignment. No semicolon is inserted at the line terminator. That is, The above example is interpreted in the same way as up equals b high g exec, cmap, d, syntax, input,
It is flickering.
space, line terminator comment token div punctuator right brace punctuator, input element regexp, white space, line terminator comment token right brace punctuator regular expression literal, ECMA International 2024 217, capital I, N, P, U, T,
Alright, there we go.
L, E, M, E, N, T, capital R, E, G, capital E, X, P, capital O, R, capital T, E, M, P, L, A, T, E, capital T, A, white space, line terminator comment token regular expression literal template substitution tail, input element template tail, white
Any second will stop.
comment token div punctuator template substitution tail, input element hashbang or regex,
Okay, 300 might have been a big number.
to comment token hashbang comment regular expression literal 2.1 Unicode format control characters. The Unicode,
Oh my god, hurry up and stop.
that is, the characters in category CF in the Unicode character database such as left to right mark or right to left mark are control codes used to control the formatting of a range of text in the absence of higher level protocols for this, such as markup languages. It is useful to allow format control characters in source text to facilitate editing and display. All format control characters may be used within comments, and within string literals, template literals, and regular expression literals. U plus 200C, 0 width non-joiner, and U plus 200D, 0 width joiner, are format control characters that are used to make necessary distinctions when forming words or phrases in certain languages. In
Somehow it gets stuck on the same frame.
points may also be used in an identifier name after the first character. U plus F, 0 width no break space, is a format control character used primarily at the start of a text to mark it as Unicode and to allow detection of the text's encoding and byte order. ZWMBSP. Characters intended for this purpose can sometimes also appear after the start of a text. For example, as
But I think it's still sending
any CMA script sourced
the triangle.
ZWMBSP. Code points are treated as white space characters. See 12.2.
Except it's not.
Certain format control
I'm not sure.
of comments, string literals, and regular expression literals is summarized in Table 35. Table 35. Format control code point usage.
I'm gonna get some water.
Abbreviation usage.
You know, this is annoying.
C. 0 width not
I gotta figure out.
WNJ identifier part. U plus 200D 0 width joiner. ZWJ
If I turn off the triangle,
plus FEF 0 width no break space. ZWNBSP white space 218. ECMA International 2024 12.2 white space code.
in the background, will that mess up?
Ability and to separate tokens, indivisible lexical units, from each other, but are otherwise
When it gets a video capture.
code points may occur between any two tokens and at the start or end of input. White space code point
I still need a shader to be applied.
literal, a template, or
So can I like use the triangle shader and then put a different one in
part of a literal value,
and swap it with this one?
but cannot appear within PCMA script. White space code points are listed in Table 36. Table 36. White space code points.
There's too many bad options. They all suck. In that triangle, it lived more than one time. Every time I like refresh, that triangle lives more than once. So I gotta like stop bringing that triangle back. Otherwise it's actually not a YOLO triangle. Because it's kept alive. I gotta kill it. So I gotta make a decision. Man, every choice is gonna take work. Take modifying the freaking buffer, or changing some value, they'll probably fuck it up. Anything I do is gonna fuck it up. But it's kind of working, even though it's fucked up. I had some water.
Value is true. Return false. Return true. Evaluation. Let x be. Evaluation of array expression. Let old value be to Boolean. Get value. Exper. If old value is true. Return false. Return true. 3.6 exponentiation operator syntax. Exponentiation expression. Yield. Await. Unary expression yield await. Update expression yield await. Exponentiation expression yield await. ECMA International 2024 273 136 1 Runtime semantics. Evaluation. Exponentiation expression. Update expression. Exponentiation expression. Return. Capital E V A L U A T E. Capital S T R I N G. Capital O R. Capital N U M E R I C. Capital B I N A R Y. Capital E. Update expression. Exponentiation expression. 3.7 multiplicative operators syntax. Multiplicative expression. Yield. Await. Exponentiation expression yield await. Multiplicative expression yield await. Multiplicative operator. Exponentiation expression yield await. Multiplicative operator. 1 of percent 3 7 1 runtime semantics. Evaluation. Multiplicative expression. Multiplicative expression. Multiplicative operator. Exponentiation expression. Let optext be the source text matched by multiplicative operator. Return. Capital E V A L U A T E. Capital S T R I N G. Capital O R. Capital N U M E R I C. Capital B I N A R Y. Capital E. Multiplicative expression. Octext. Exponentiation expression. 3.8 additive operators syntax. Additive expression. Yield. Await. Multiplicative expression yield await. Additive expression yield await plus multiplicative expression yield await. Additive expression yield await. Multiplicative expression yield await. 3 8 1 The addition operator plus. Note the addition operator either performs string concatenation or numeric addition. 3 8 1 1 runtime semantics. Evaluation. Additive expression. Additive expression plus multiplicative expression. Return. Capital E V A L U A T E. Capital S T R I N G. Capital O R. Capital N U M E R I C. Capital B I N A R Y. Capital E. Additive expression plus. multiplicative expression. Note, the operator performs multiplication, producing the product of its operands. The operator performs division, producing the quotient of its operands. The percent operator yields the remainder of its operands from an implied division. 274. Copyright sign, ECMA International 2024. 138. To the subtraction operator. 3, 8, 2. 1 runtime semantics. Evaluation. Additive expression, multiplicative expression. Return. Capital E, V, A, L, U, A, T, E, capital S, T, R, I, N, G, capital O, R, capital N, U, M, E, R, I, C, capital B, I, N, A, R, Y, capital E, additive expression, multiplicative expression. 3.9 bitwise shift operators syntax. Shift expression, yield, await. Additive expression, yield, await. 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 3, 9, 1 the left shift operator. 3, 9, 1. 1 runtime semantics. Evaluation. Shift expression, additive expression. Return. Capital E, V, A, L, U, A, T, E, capital S, T, R, I, N, G, capital O, R, capital N, U, M, E, R, I, C, capital B, I, N, A, R, Y, capital E, shift expression, additive expression. 3, 9. To the signed right shift operator. 3, 9, 2. 1 runtime semantics. Evaluation. Shift expression, additive expression. Return. Capital E, V, A, L, U, A, T, E, capital S, T, R, I, N, G, capital O, R, capital N, U, M, E, R, I, C, capital B, I, N, A, R, Y, capital E, shift expression, additive expression. 3, 9. 3 the unsigned right shift operator. Note, the operator performs subtraction, producing the difference of its operands. Note performs a bitwise left shift operation on the left operand by the amount specified by the right operand. Note performs a sign filling bitwise right shift operation on the left operand by the amount specified by the right operand. Note performs a zero filling bitwise right shift operation on the left operand by the amount specified by the right operand. ECMA International 2024 275 13 9 3. 1 runtime semantics. Evaluation. Shift expression, additive expression. Return. Capital E, V, A, L, U, A, T, E, capital S, T, R, I, N, G, capital O, R, capital N, U, M, E, R, I, C, capital B, I, N, A, R, Y, capital E, shift expression, additive expression. 3.10 relational operators. Syntax. Relational expression in yield, await. Shift expression, yield, await. Relational expression in yield. Relational expression in yield. Relational expression in yield. Relational expression in yield. Relational expression in yield, await. Shift expression, yield, await, await. Shift expression, yield, await, await. Equals shift expression, yield, await, await. Equals shift expression, yield, await, await. Instantiar. Note 1. The result of evaluating a relational operator is always of type Boolean. reflecting whether the relationship named by the operator holds between its two operands. Shift expression yield await, plus in relational expression, plus in yield await, in shift expression yield await, plus in private identifier in shift expression yield await. 3. 1 0 1 runtime semantics, evaluation, relational expression, shift expression, letter FB, evaluation of relational expression, letter val B, get value, ref, letter FB, evaluation of shift expression, letter val B, get value, ref, letter B, is less than, val, reval, true if R is undefined, return false, otherwise, return R, relational expression, shift expression, letter FB, evaluation of relational expression, letter val B, get value, ref, letter FB, evaluation of shift expression, letter val B, get value, ref, letter B, is less than, val, false if R is undefined, return false, otherwise, return R, relational expression equals shift expression, letter FB, evaluation of relational expression, letter val B, get value, ref, letter FB, evaluation of shift expression, letter val B, get value, ref, letter B, is less than, val, false if R is either true or undefined, return false, otherwise, return true. 276, ECMA International 2024. Note to the in grammar parameter is needed to avoid confusing the in operator in a relational expression with the in operator in a for statement. Relational expression equals shift expression, letter FB. Evaluation of relational expression, letter val B. Get value, ref, letter FB. Evaluation of shift expression, letter val B. Get value, ref, letter B, is less than, val, reval, true if R is either true or undefined, return false, otherwise, return true. Relational expression instantia of shift expression, letter FB, evaluation of relational expression, letter val B, get value, ref, letter FB, evaluation of shift expression, letter val B, get value, ref, return, instantia of operator, val, reval, relational expression in shift expression, letter FB, evaluation of relational expression, letter val B, get value, ref, letter FB, evaluation of shift expression, letter val B, get value, ref, if reval is not an object, throw a type error exception, return, has property, reval, to property key, val, relational expression, private identifier in shift expression. Let private identifier be the string value of private identifier, letter FB. Evaluation of shift expression, letter val B. Get value, ref. If reval is not an object, throw a type error exception. Let private env be the running execution context's private environment. Let private name be resolved private identifier, private env. Private identifier. If private element find, reval, private name, is not empty, return true, return false. 3. 1 0 2 instantia of operator, v, target. The abstract operation instantia of operator takes arguments v, any CMA script language value, and target, any CMA script language value, and returns either a normal completion containing a boolean or a throw completion. It implements the generic algorithm for determining if V is an instance of target either by consulting target sat at has instance method or, if absent, determining whether the value of target's prototype property is present in V's prototype chain. It performs the following steps when called. If target is not an object, throw a type error exception. Let inst of handler be get method target at has instance. If inst of handler is not undefined, then a returns a boolean. Call inst of handler target v if is callable. Target is false. Throw a type error exception. Return ordinary has instance target v Note steps 4 and 5 provide compatibility with previous editions of ECMA script that did not use a at has instance method to define the instantia operator semantics. If an object does not define or inherit at has instance, it uses the default instantia semantics. ECMA International 2024 277 13.11 Equality operators. Syntax. Equality expression in yield await. Relational expression in yield await. Equality expression in yield await equals relational expression in yield await. Equality expression in yield await equals relational expression in yield await. Equality expression in yield await equals relational expression in yield await. Equality expressio and in yield await equals relational expression in yield await. 3.1.1 runtime semantics. Evaluation. Equality expression equals relational expression. Letter FB. Evaluation of equality expression. Letter val B. Get value. Ref. Letter FB. Evaluation of relational expression. Letter val B. Get value. Ref. Return. Is loosely equal. Val. Equality expression equals relational expression. Letter FB. Evaluation of equality expression. Letter val B. Get value. Ref. Letter FB. Evaluation of relational expression. Letter val B. Get value. Ref. Letter B. Is loosely equal. Val. If R is true, return false. Otherwise, return true. Equality expression equals relational expression. Letter FB. Evaluation of equality expression. Letter val B. Get value. Ref. Letter FB. Evaluation of relational expression. Letter val B. Get value. Ref. Return is strictly equal. Val. Equality expression equals relational expression. Letter FB. Evaluation of equality expression. Letter val B. Get value. Ref. Letter FB. Evaluation of relational expression. Letter val B. Get value. Ref. Let R be is strictly equal. Val. If R is true, return false. Otherwise, return true. 278. ECMA International 2024. Note the result of evaluating an equality operator is always of type Boolean, reflecting whether the relationship named by the operator holds between its two operands. Note 1. Given the above definition of equality, string comparison can be forced by $the $, $b. Numeric comparison can be forced by plus plus b. Boolean comparison can be forced by equals b. Note 2. The equality operators maintain the following invariants. Up equals b is equivalent to up equals b. Up equals b is equivalent to b equals a, except in the order of evaluation of a and b. Note 3. The equality operator is not always transitive. For example, there might be two distinct string objects, each representing the same string value. Each string object would be considered equal to the string value by the equals operator, but the two string objects would not be equal to each other.
Okay, so
Equals a and a equals new string are both true. New string equals
after thinking everything through and getting water,
of strings uses a simple equality.
I need to capture the desktop at 4K, not pixelated, because I need to like show the normal desktop when it's like not pixelated, but also when it's pixelated. And I googled on my phone, whatever, and you can't get the desktop scale down.
Strings are already in.
There's like other programs, but I'm not gonna switch. This works. I'm leaving it like this, so I gotta capture it at 4K
Equality expression and yield.
and send that to the GPU, and I gotta scale on the GPU instead.
Yield await.
And that's the only option I have. I'm not gonna change anything. This works. I'm tired of this.
Expression and yield await. Bitwise and
But I gotta pick a background.
wait. Bitwise or expression in yield await. Bitwise.
To put around the whatever desktop capture.
Bitwise or expression in yield await. 3.1.2 1 runtime semantics. Evaluation. Bitwise
And I could like just take
and expression into
the background from that guy's thing.
capital E V A L U A T E capital S
But that'd be kind of lame
I N G capital O
because like I'm not using his program. It's on Linux,
M
so I don't really want to like copy it from his program
B
if it's not his program, whatever,
A R
like Glassshade or whatever it is.
capital E bitwise and expression and equality expression ECMA International 2024 279 bitwise or expression bitwise or expression bitwise and expression return capital E V A L U A T E capital S T R I N G capital O
So
capital N U M E R I C capital
instead of like copying the background,
A
like this image, whatever in the background, the TV thing,
bitwise or expression
I'm gonna like find my own image.
or expression bitwise or expression bitwise or expression return capital E V A L U A T E capital S T R I N G
And I think I'll use this one.
R capital N U M E R I C capital B I N A Y capital E bitwise or expression bitwise or expression 3.13 binary logical operators syntax logical and expression in yield await bitwise or expression in yield await logical and expression in yield await and bitwise or expression in yield await logical or expression in yield await logical and expression in yield await logical or expression in yield await
If I can find it.
in yield await coalesce expression in yield await coalesce expression head in yield await bitwise or expression in yield await coalesce expression head in yield await coalesce expression in yield await bitwise or expression in yield await short circuit expression in yield await logical or expression in yield await coalesce expression in yield await 3.1.3 1 runtime semantics evaluation logical and expression and bitwise or expression letter FB evaluation of logical and expression letter val B
So like this one, I guess.
F letter bool be to boolean val if the bool is false return the val letter FB evaluation of bitwise or expression return get value ref logical
And I'll like make it square.
or expression logical and expression letter FB evaluation of logical or expression letter val
So like I'll use this outside image, whatever.
will be to boolean val if the bool is true return the val letter FB evaluation of logical and expression return get value ref 280 ECMA International 2024 the value produced by an
And maybe I'll put the car in the background
type boolean the value produced note
that like randomly drives by.
and expressions coalesce expression head bitwise or expression letter FB evaluation of coalesce expression head
Okay, where's the car?
get value ref if the val is either undefined or null then a letter FB evaluation of bitwise or expression be returned get value ref else a returnal val 3.14 conditional operator syntax conditional expression in yield await short circuit
So like screen capture this, I guess.
circuit expression in yield await assignment expression plus in yield await assignment expression in yield await 3.14 1 runtime
Why does the text
simulation
not go away?
short circuit expression assignment expression letter FB evaluation of short circuit expression letter val be to boolean get value ref If
Kind of like hide the minibar.
true ref B. Evaluation of the first assignment expression be return. Get value. True ref. Else. A let false ref B. Evaluation of the second assignment expression be return. Get value. False ref. Note the grammar for a conditional expression
I'll just screenshot it again later.
from that in C and Java, which each allow the second sub-expression to be an expression but restrict the third expression to be a conditional expression. The motivation for this difference in ECMA script is to allow an assignment expression to be governed by either arm of a conditional and to eliminate the confusing and fairly useless case of a comma expression as the center expression. ECMA International 2024-281, 13.15 Assignment operators syntax. Assignment expression in yield await. Conditional expression in yield await plus yield. Yield expression in await. Arrow function and yield await. Async arrow function and yield.
Could Chrome just load?
Side expression.
Why is this browser so shitty?
Expression and yield await. Left hand side expression yield await. Assignment operator assignment expression and yield await. Left hand side expression yield await. And equals assignment expression and yield await. Left hand side expression yield await. Equals assignment expression and yield await. Left hand side expression yield await equals assignment expression and yield await. Assignment operator 1 of equals percent equals plus equals 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 and equals 3.
Okay, so I don't know.
1 static semantics.
Instead of like this background,
Left-hand side expression equals assignment expression. If left-hand side expression
I'll do this, I guess.
array literal, the following early error rules are applied. Left-hand side expression must cover an assignment pattern. If left-hand side expression is neither an object literal nor an array literal, the following
I'll just take like a screenshot for now.
syntax error if assignment target
I have to like download the video, I guess,
assignment expression
because YouTube won't play it without like the freaking text at the top and bottom.
left-hand side expression
So like download it
expression left
and then clip it out or whatever.
equals assignment
So just like paste and create it for now.
expression equals assignment expression. It is a syntax error if assignment target type of left-hand side expression is not simple. 3.1.5 to runtime semantics. Evaluation. Assignment expression. Left-hand side expression equals assignment expression. 82. If left-hand side expression is neither an object literal nor an array literal, then a letter of B. Evaluation of left-hand side expression. BF is anonymous function definition. Assignment exp. Russian and is identifier ref of left-hand side expression.
Could something work?
I letter val B. Named evaluation of assignment expression with argument ref. C else. I letter ref B. Evaluation of assignment expression. 2. Letter val B. Get value. Ref. D perform. Put value. Ref. Reval. E return reval. Let assignment pattern be the assignment pattern that is covered by left.
We're stuck.
2024. 3. Let ref B. Evaluation of assignment expression. Let val B. Get value. Ref. Perform. Capital D E S T R U C T U R I N G. Capital A S S I G N M E N T. Capital E V A L U A T. Of assignment pattern with argument reval. Return reval. Assignment expression. Left-hand side expression. Assignment operator. Assignment expression. Letter of B. Evaluation of left-hand side expression. Letter val B.
It's not the clip tool.
Letter F B. Evaluation of assignment expression. Letter val B. Get value. Ref. Let assignment op text be the source text matched by assignment operator. Let op text be the sequence of Unicode code points associated with assignment op text in the following table. Assignment op text equals percent plus equals and equals. Let R B. Capital A P
So like, I don't know, just clip it or whatever.
Capital S T
I'm gonna put the video in the middle.
N G capital
This is all that's left, and then that's the shader.
N U M E
I just have to like apply the shader, whatever.
capital B I N A R Y capital O P E R val op text val perform put value ref R return R assignment expression left hand side expression and equals assignment expression let ref B evaluation of left hand side expression little val B get value ref let
I'm just doing this very
Boole's
like crappy
if it's
just to get it done.
mission assignment expression
I just want to get this thing done.
a ref of left
Later on I'll take like a video and clip out the middle
B name
so it'll look like slightly better.
with argument ref
This is gonna look like crap.
evaluation of assignment expression B let reval B get value ref perform put value ref reval return reval assignment expression left hand side expression equals assignment expression let ref B evaluation of left hand side expression little val B get value ref let bool be to boolean val if the bool is true return val if is anonymous function definition assignment expression is true and is identifier ref of left hand side expression is true then a letter val B named evaluation of assignment expression with argument ref 6 else a letter of B evaluation of assignment expression B let reval B get value ref ECMA International 2
What the heck?
83 7 perform put value ref reval return reval assignment expression left hand side expression equals assignment expression let ref B evaluation of left hand side expression little val B get value ref if a val is neither undefined nor null return val if is anonymous function definition assignment expression is true and is identifier ref of left hand side expression is true then a letter val B named evaluation of assignment expression with argument ref
For the love of shit.
of assignment expression B let reval B get value ref perform put value ref reval return reval 3 1 5 3 capital A P P L Y
What?
S T R I N G capital O R capital N U
I'm moving it.
E R
Oh, now it works. Okay. Yeah.
E I N
Never mind.
R Y
It just suddenly starts working.
R val op text reval the abstract operation capital A P P L Y capital S T R I N G capital O R capital N U M E R I C capital B I N A R Y capital O P E R takes arguments val any CMA script language value op text comma percent plus and or and reval any CMA script language value and returns either a normal completion containing either a string a begint or a number or a
What's up with this program?
following steps when called
Holy crap.
then a letter from B to primitive val B letter from B to primitive reval see if prim is a string or reprim is a string then I let lstrb to string or prim 2 let rstrb to string reprim 3
Control C.
concatenation of lst
Control V.
r d set val till prim e set reval to reprim note at this point
Oh man.
letter num B to numeric val letter num B to numeric reval if type num is not type renum throw a type error exception if num is a big int then Note when this expression occurs within strict mode code, it is a runtime error if ref in step 1D. 2, 2, 2, 2 is an unresolvable reference. If it is, a reference error exception is thrown. Additionally, it is a runtime error if the ref in step 8, 7, 7, 6 is a reference to a data property with the attribute value false, to an accessor property with the attribute value ABCD. Let if optext is return big int exponentiate num renum if optext is comma return big int divide num renum if optext is percent return big int remainder num renum if optext is return big int unsigned right shift num renum operation be the abstract operation associated with optext and type num. In the following table, 84 ECMA International 2
Wait, did it copy the whole thing?
num operation number exponentiate number multiply begin
Oh my god.
divide number remainder number add percent plus
This program is... I can't take it.
number optext type num plus big int
I can't take it. This program is so bad.
number big int comma number big int number big int number big int operation big int add number subtract big int subtract number left shift big int left shift number signed right shift big int signed right shift number and signed right shift number bitwise and big int bitwise and number bitwise or big int bitwise or number bitwise or big int bitwise or return operation num renum. Note 1 no hint is provided in the calls to primitive in steps 1A and 1B. All standard objects except dates handle the absence of a hint as if number were given. Dates handle the absence of a hint as if string were given. Exotic objects may handle the absence of a hint in some other manner. Note 2 step 1C differs from step 3 of the is less than algorithm by using the logical or operation instead of the logical and operation. 3, 1, 5, 4, capital E, V, A.
That's good enough.
U, A.
That works.
E, capital S, T, R, I, N, G, capital O, R, capital N, U, M, E, R, I, C, capital B, I, N, A, R, Y, capital E, left operand, optext, right operand. The abstract operation, capital E, V, A, L, U, A, T, E, capital S, T, R, I, N, G, capital O, R, capital N, U, M, E, R, I, C, capital B, I, N, A, R, Y, capital E, takes arguments left operand, a parse node, optext, a sequence of Unicode code points, and right operand, a parse node, and returns either a normal completion containing either a string, a big int, or a number, or an abrupt completion. It performs the following steps when called. Letter FB. Evaluation of left operand. Letter val B. Get value. Ref. Letter FB. Evaluation of right operand. Letter val B. Get value. Ref. Return. Capital A, P, P, L, Y, capital S, T, R, I, N, G, capital O, R, capital N, U, M, E, R, I, C, capital B, I, N, A, R, Y, capital O, P, E, R, val, optext, val. 3, 1, 5. 5. Destructuring assignment supplemental syntax. In certain circumstances when processing an instance of the production assignment expression, left-hand side expression equals assignment expression. The interpretation of left-hand side expression is refined using the following grammar. Assignment pattern, yield, await, object assignment pattern yield await. Array assignment pattern yield await. ECMA International 2024 285. Object assignment pattern. Yield await. Assignment dress property yield await. Assignment property list yield await. Assignment property list yield await. Assignment dress property yield await opt. Array assignment pattern. Yield await. Eligible assignment dressed element yield await opt. Assignment element list yield await. Assignment element list yield await. Eligible assignment dressed element yield await opt. Assignment dress property. Yield await. Dart. Destructuring assignment target yield await. Assignment property list. Yield await. Assignment property yield await. Assignment property list yield await. Assignment property yield await. Assignment element list. Yield await. Assignment elision element yield await. Assignment element list.
Man, there's still this down there.
Element yield await. Assignment elision element.
You know what? That's good enough.
Elision assignment element yield await. Assignment property. Yield await. Identifier reference yield await. Initializer. Plus in yield await opt. Property name yield await. Assignment element yield await. Assignment element. Yield await. Destructuring assignment target yield await. Initializer. Plus in yield await opt. Assignment dressed element. Yield await. Dart. Destructuring assignment target yield await. Destructuring assignment target. Yield await. Left hand side expression yield await. 3, 1, 5, 5, 1 static semantics. Early errors. Assignment property. Identifier reference initializer opt. It is a syntax error if assignment target type of identifier reference is not simple. Assignment.
Oh, damn it.
Structuring assignment.
Everything sucks.
Syntax error if destructuring assignment Roget is either an array literal or an object literal.
Oh my god, dang it.
Left hand side expression. If left
This works. I'm gonna export this.
or an array literal. The following early error rules are applied. Left
And this will be
pattern.
the window for now.
Either an object literal nor
Yeah, it's total trash.
following early error rule.
At least I got this working.
Copyright sign. ECMA International 2024. It is
Well, it's not running right now.
target type of left hand side expression is not simple. 1, 3, 1, 5, 5.
I gotta do another stream. Damn it.
E S T R U C T U R I N G capital A S S I G N M E N T capital E V A L U A T. The syntax directed operation. Capital D E S T R U C T U R I N G capital A S S.
I'm gonna let the stream run on for 10 more minutes because it doesn't always send the whole stream, and let's start another stream right after this one.
A
And remember, I don't know, another stream after this.
take
And don't forget,
any CMA script language value and
you cannot escape triangles.
it is defined piecewise over the following productions. Object assignment pattern.
Why is it not working? Come on. Freaking software is crap. I could make an operating system better than this. Bunch of garbage.
You cannot escape
You can't escape triangles.
triangles. You cannot escape 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 triangles.